Hey there. Hey there, folks. It's Nick here from Geekle team. I set everything up, and I guess we're ready to go. This is a final check before we start. So just a couple of minutes left. Just write me if you hear and see me clearly. And yeah, we can start with a short intro and then the first speaker. Yeah. Oh, hi, Hedy. I remember you. Nice to see you again. Yeah, it seems to be working here too. All right. Nice. Thanks a lot for joining. Yeah. We tried hard to prepare all this content for you. Yeah, there will be a couple of pre-recorded talks, but most of the speakers will be live. And even if there will be pre-recorded talks, will still be a live Q&A session. You will be able to ask questions live. All right. So yeah, we're going to start in 3 minutes. So I got to leave. Enjoy.
Hey, lovely people, and welcome to Global Summit for Java Developers 21. We're excited to finally have this event up and running, and we are super glad to have you with us this morning. And with me, I have Karina. She's the community manager of this beautiful Java development community, and we're about to have 40 amazing hours of great content together with people from amazing companies with amazing speakers, and we're gonna cover some hot topics. So stay tuned for the newest update from the world of Java. And also we will have some great news. We will have some great announcements for the upcoming events. We're gonna have some promos. We're gonna have some surprises for you, some flash prices for the upcoming events. And so it's going to be cool. It's going to be hot. So stay tuned. Karina, thank you for your input into this event, and just a couple words from you. How are you feeling today?
I'm feeling very excited. Hello, Pavel. Thank you very much for introducing me. And yeah, I want to thank all of the team and all of the speakers. And I want to thank the programming committee who helped us and vote for the abstracts. And actually, it's their ideas we put to these events. And I want to thank all of the attendees who trusted us, trusted their time to our speakers. I'm really, really happy and excited.
Amazing.
So yeah, it's our already second Java events. We did the first last year in August. It was 24 hours. It was so much fun. Yeah, 48 speakers. Today we're going to have 2 days for Europe and CTD and American time zone. And we actually are going to have around 50 speakers and gathered, yeah, that's success. And we gathered 5,000 registrations. So there are so many things to discuss today. And I just want to share my excitement with all of you, because all of the speakers, I know they are excited. They write me messages to the Slack, and that they are waiting for the speeches and talks so much. So I just want to say that we are going to have mostly Q&A sessions after the topics. Just want to point your attention, and some of the Q&A sessions will be together with the speakers from the same areas. We will also have the guest Q&A sessions. This is the first time we organize like that. Means like the speakers from different days will come to each other to their Q&A sessions to have dispute, discussion together, answer the same questions. It's just everything made for your interest, and I hope you will enjoy it. Please be active. Watch all of the sessions if you have power for that. So I'm drinking coffee. Maybe you're drinking tea or something like that. So just enjoy it and answer as many questions as possible. We will also organize a giveaway among those who ask the questions for the speakers today or tomorrow. So we're going to have panel discussions, magic trick, Java 16 release, so many things. Yeah.
Exciting.
Thank you.
Okay, guys, and we'll pause just for a minute, and I'm going to be moderating this track, the senior track, and also Marie Vovchok will be moderating our career track, our junior track. So stay tuned, and we'll be back in a couple of seconds. Thank you.
Hello and welcome everyone to Java Summit 2021. I'm Maria Wojcik, really excited to be here, and I'm really excited that so many people of you are joining us. Please, as by the way, as Karina has already told you, as Pavel, as I have, they both have already mentioned, today we're going to learn and discuss those studies. Moreover, today you're going to, as you know, find out about the upcoming events, and also maybe some of you will get the tickets for our upcoming events for free. For this, please be today very attentive, be today very active. And just in case, quickly tell me, is maybe somebody is already joining us because it's really late at in the Americas. So probably maybe somebody still like of you are watching us right now. But also, of course, right now we'll be talking maybe as we discussed, and we will dedicate time specifically for Europe, specifically for America, and we have speakers from very different parts of the world, and we also discuss with them, and we'll also see, and they will also be explaining to us in what case, for what they are using Java programming language, and what challenges do they have, how do they overcome those challenges, and what lessons have they learned so far, which they can actually share them with you. And I believe when you're have some very interesting case studies from somebody, one of the most interesting, I would say, one of the at the same time public developers, when you can hear all of this, and you can actually learn yourself. And probably maybe some of you who is not even a developer, but you're very interested in IT. I believe that today's our festival, I would say, summit will help you and will actually spur your desire and will make you think about maybe how to become a developer, or maybe how to learn how to code, because I believe that this is a skill which in the future will be really, really valuable. I may tell you also from on the behalf of somebody who is like dealing a lot with blockchain developers, and I can tell you that it's a very valuable skill, especially when we're talking about the current digitized world. So thank you so much once again. Thank you for coming. Thank you everyone who has joined us today. And there will be lots to listen to. And I believe that our speaker also has a lot to share with you today, because today we have Romain Mani Bucau, who is a software architect at UPeak. And today he'll tell you more about living code solution for Java developers. I think he will be streaming directly from Paris. And if I'm not mistaken, he is almost ready, and probably he will be, he just needs like maybe 1 or 2 minutes just in case. But meanwhile, don't forget that in 45 approximately minutes, maybe even less, we're going to have with him our Q&A session. So you will have the chance to ask him questions directly. And for this, just you may try type them in our chat. So right now, by the way, I also wanted to say again, thank you, because I already see that you're very active in our comment section. You're already telling us what is going on. Let me just check, is Romain is here, and can he join us right now? Hopefully he will be able to do it a bit later. But in that case, meanwhile, let me just quickly tell you as well what is going on to be one of our upcoming events, because very soon we're going to have our next Flash prize, of course, for this year for Python, for ML, and AI Global Summit in 2021. So, Romain, about this, I'll tell you a bit later how to get discounts and maybe some of the tickets for free. Right now, Romain, can you please switch on the cameras that I can see you? Everybody can see you. Romain, hi.
Yeah.
Can you hear me? Oh,
Hello.
How are you doing today?
Yeah, good. What about you?
I'm doing great. Fantastic. Are you right now streaming live directly from Paris? How is it like? How is the situation there? And how is the what is the right now? What is happening in Paris?
Well, it's more or less okay. It's sunny, so that's good.
In terms of what is happening right now in the current situation, is it? Do you have some summits, or are they again all the time they're online? Of course, obviously, if I'm not mistaken.
Yeah, but no, it's more than fine in Paris. Yeah.
Bonjour. I can see that some of our viewers are actually telling you bonjour to Paris. And another one, somebody is here as well in Paris, so they are watching you closely. So Romain, today, more about code solutions for Java developers. Be attentive if you have some message to deliver before your presentation to speakers. You're welcome.
Yeah, nothing much. I hope everybody will have fun and will appreciate the conf.
Definitely. So let's have fun and let's listen to what Romain has to share with you. I'll see you very soon.
Thank you. So hello, everyone. So today I'll talk about living code. So let me present myself very quickly. So my name is Romain Menibiko, as you already know. I'm a software architect for UPIC. I'm an Apache committer. And I'm also on social networks, as most of you, I guess. And I have a blog if you want to follow me. So the agenda for today is what's living code? You probably know a bit about living documentation, but what's living code? Is it the same or not? Do you want to reuse or do something yourself to have this feature? And then we'll see how to do it in a project. And I'll show you a quick example we use at UPIC. It's an open source project I can share with you. And we are using this kind of techniques for it. So let's get started. So the living code or living software, or all this kind of semantic, is an extension of the living documentation movement. So living documentation, if you don't know about it, it's mainly about having part of the documentation generated to ensure it is up to date, like configuration keys, like test reports, and things like that. So the living code movement is kind of the same, but for the whole software. The main goal, to summarize it, is to ensure you have minimal human actions. And the final goal is to have a high-quality software with minimum resources. So indeed, one of the goals is to reduce the maintenance cost because you don't do some task. Another goal is to increase the quality because you avoid errors by copying, pasting, or writing manually things. And you keep the developer value high because if you ask a developer to, let's say, update a wiki, it is not a task with high value, so you will pay a developer to do something which does not cost much, or you will need somebody else to do it. And one risk, if you ask the developer to do it, is it is bothering and the developer will want to do something else. So if you want to keep the developer interested, it's a good option to set up on your project. So don't get scared. I put some formulas on the slide, but it's just to share the idea in very few characters. So overall, if you add a configuration in your application, as an example, you will also need to update the wiki or documentation of your software with this new key. So the cost for your software is the cost to add the configuration in your code, but also the cost to update the wiki. Or another example is if you update an endpoint, you will need to code the endpoint, indeed, but also to update the SDK for the endpoint or update the OpenAPI specification or things like that. So you see each time it is a sum of cost. So the generic formula is like that. What is important is to see that indeed when you do features, you sum the cost of the feature, but you also sum subtasks for each feature. It's not only about code. So living code is about ensuring you focus the cost on the code, on the high value, and you reduce the cost of all of the tasks. To try to illustrate the example of living code deliveries, I listed there some common cases. So the living documentation, which is the most common probably, you can find living configuration. So you add configuration to your software, you must reflect it in some documentation. Another common use case these days with microservices is to update an open API. So you have some endpoints, you want to document them to let people consume it. You write an open API or something equivalent. Another common case is to list available modules. For example, if you know Camel, Apache Camel, you have a lot of connectors in Camel, and the documentation for Camel is generated. So when you add a new connector, you don't need to do a lot of things. The documentation will be extracted from the code. That's a very interesting feature. And you can generate some code or resources to ensure you can embed your documentation inside your application. You know, like to have help in your application. So it's not that commonly done because often we update a wiki, we update a static website, but having it in your application, your Angular, your React, your Vue, or whatever website you have, is nicer because you inherit from the theme and the workflow of your website. So it's nice to embed the documentation. Another use case of a living code is the SDK. So it's typically when you generate an API or SPI. So you have some backend feature, implementation feature, and you extract from it the API users can rely on. What is more and more common these days, once again, thanks to microservices, is to extract a REST SDK, so a client. You generate a client. It can be a plain REST client or a gRPC, a JSON RPC, even a Kafka client if you expose some commands on top of topics. You can also generate as an SDK a configuration generator if you have a product and you want people to be able to configure your product easily with completion, with all the tooling of developers. I'm thinking to VS Code or IntelliJ, for instance. So you generate from your configuration model a DSL, and then the users can rely on this DSL. And one nice thing about that is it can be polyglot. So you can generate a configuration generator or HTTP client or whatever in TypeScript, in JavaScript, in Java, in Rust, or whatever you want. But one nice thing, as soon as you generate, you can embrace all languages and all environments. Whereas if you don't generate and have to maintain it manually, I think Cucumber project is doing it manually for most of the code. It's a lot of work. Another example is to generate a CLI, a command line interface. I just use a kubectl, so the Kubernetes client, as an example. So basically, Kubernetes has a lot of open API. It's a very big open API file. You can't open it in a browser with a Swagger UI very easily. And from it, they generate a command line interface. It's just binding all the open API on the command line. But it's a nice example you can use for your microservices if you are using JAX-RS or things like that. And this way you can call all your endpoints through a nanmin-like API very easily, and it's more ops friendly. And the last example I put about the living code generation is about optimization. So you can generate code to drop some reflection, Java reflection, or generate some resources to be able to build a Graal VM, so a native binary for your Java application, things like that. So you can generate documentation to communicate with users, SDK to communicate with other developers, applications, command line interface, it can be HTTP server, things like that, to add, to expose your code as features, or generate optimization to make your application behave better and faster generally. The next question is, living code is good. It's a great feature to have, but when you want to set up it, do you want to reuse the tool, or do you want to write a custom tool? So indeed, when you write a custom tool, you are using libraries and things like that, but to try to illustrate it, do you want to use a Maven plugin doing it for you? Or do you want to write a custom main or something like that you will run to do it in your project? This question is, so it looks obvious you want to reuse because it will not cost anything. But actually, when you evaluate it more deeply, it's a bit more complicated. Because when you reuse a tool, you have immediately a result. It works immediately. But as soon as you need to customize it, it's a bit complicated and sometimes you can't do it at all. One advantage of reusing it is if the technology is evolving, reusing a tool will generally give you the new feature. So for example, if you were using OpenAPI or Swagger at the very beginning, it was not supporting WebSockets and now it is supporting WebSockets. So you got it for free. But still, you are not always able to customize it as needed. And one very nasty drawback of reusing is it is doing it immediately for you without any knowledge or just some configuration, some XML or whatever. So you can use it without understanding what it does. And so the question is about the team knowledge you want. If you reuse too much, something too much too high level, let's say, you will lose some knowledge in the team, which can be okay in some cases, but in some cases it will be a risk because it can lead to vulnerabilities or this kind of issue. On the opposite, doing a custom solution, the do-it-yourself, it will be fully adapted to your case, so it will be pixel perfect, but you will have to pay to do it. A big advantage is it will work with any stack. So if you are using a library, very specific library or company library, let's say you have a company-wide configuration library using custom annotations, for example, the do-it-yourself solution will work, whereas the reuse will likely not work because nobody in the open source knows about your custom annotations. However, you will have to pay the maintenance as well as the initial development. But a big advantage of the do-it-yourself solution is that your team, or at least the company, will know a lot about the technology and how it is done and how it works. So it's safer for the company generally. One small note on that is that it requires some ecosystem knowledge. What it means is you need some knowledge about the technology, the underlying technology, and a bit about the, let's say we develop in Java libraries you can use to do that. So on the next slide, I try to put some very high-level cost evaluation of reuse strategy and do-it-yourself strategy. So generally, we'll tend to have a mix of both options because when something you can reuse does exactly what you want, it is worth using it. You import it, you configure it, and it does the work. But often you will add something a bit custom to refine it to your specific case. So it is generally a mix. So the overall cost of your delivery is the cost of the dev, but also the sum of the cost of the reuse you did and the custom development you did. So the question with this formula is, so my software always costs more than the dev, whereas the goal of the living code is to just have the cost of the software being the cost of the dev. So yeah, this is exactly the goal. We want the cost of the software to be the dev cost, but generally the cost is always higher because you always have tasks around the dev. So what the next formula says. So let's take an example to illustrate it. So let's say we do sprints and we evaluate a feature to more or less 3 days. So let's say we have one day of development, actual development, 1 day of testing, and 1 day of QA validation, whatever. Let's say we want we want to document all the configuration of the software in a wiki. And when we develop an endpoint, we update an OpenAPI specification for the application, and we also update a client. So let's say a TypeScript SDK for this example. So okay, so let's say we want to implement an hello world endpoint, a greeting endpoint. So basically, we will get a request API greet with a name in query parameter, and the response will be hello the name. Very simple example. So in Java, it can look like that. So we have a POJO or a record representing the payload. We use JAX-RS and microprofile config to implement the endpoint. So we bind the path and we inject the config as a field parameter of the endpoint. And the implementation is the common one you probably already know. So we just return a greeting POJO with respecting the pattern we configured. What you can note there is most of the code is using annotations. I'll come back on that later. So, okay, we have this code. It's pretty simple. We will assume we tested it and validated it. So the development is done. So now we need to go to the wiki page, add an entry, a bit like the snippet there. So we have some time to update the documentation. And we need to update the OpenAPI as well. So basically, adding the schema for the new POJO greeting and adding the new entry for the endpoint. What you can see there is you can do a lot of errors doing that manually. So for instance, in the wiki, I did a typo there. In the OpenAPI, I did a typo there. I can misconfigure the schema of the record POJO. I can forget a property or put an array instead of an object because I copied pasted another schema or whatever. In the OpenAPI, I can reuse an existing operation ID. If you have a big OpenAPI, it's not that easy to use a unique one. So it will create a conflict in Swagger UI, for example. I can misconfigure the parameter, don't put query, but put something else. And I can forget some responses. I put the 201, the default one, but I can forget the 404 or 400, for instance. And in OpenAPI, there are schemas, and it is using references generally. And I can do an error here as well. So I have a lot of errors to do if I do it manually. About the client generation, so I have an endpoint. I want to generate a TypeScript, a JavaScript client in this case. So here it is the same. I can do a typo in the model. I can do a typo in the endpoint, or I can have parameters which are no more up to date. For instance, there I have the name query parameter, which is right. But I can have a first version or second version where I do a post with a payload. So it wouldn't be a get, but a post, things like that. And I still need to update this client and not just check it is get greeting is already done and it is up to date. So the first time, generally, you do it right because you initialize the client. But when you need to update it, the risk is higher. So with this example, we can go back to our previous formula. So don't take too much. Don't look too much the formulas. What's interesting is the cost of our overall dev for this simple task, a simple hello world, is the sum of the dev cost and the update cost. So overall for this task, it's the development of the endpoint plus the update of the wiki plus the update of the OpenAPI plus the update of the TypeScript client. So with some arbitrary figures, it would look like 3 for our development. That's what we said. And let's say other tasks are simple, so a cost of 1. We have an overall cost of 6. So what we see is the overall cost of the software is twice as much as the development cost. So it's a lot. So this overall gives an idea. So once again, don't use the values are true. It's just to give an overall idea. Because indeed, if the task is very simple, the development task is very simple, the update task will take more weight in the overall evaluation because the update tasks are generally not very costly, but you can't reduce them much because you need to go on the wiki to edit the wiki, to write something. You can't reduce that. So smallest the dev task will be, highest the update cost will be. One other thing to note is that you'll do it for each dev task. So you need to multiply the update cost for each update you do. And the last side note is that it's a very simple model with only, let's say, technical task evaluation. If you add human interaction, let's say you need to ask the ops team to do some action, you need to add the cost of the action indeed, but also a human factor for the communication. And this one can be very high in the overall cost. So if we keep the simple model we had just before, the linear one, more or less, we see that the cost of the overall software in red quickly comes very high compared to the cost of the dev only. And what we want to do with living code is to tend to align the red curve on the blue curve. So the conclusion is we must automate repetitive tasks when we can. So if we want to compare the reuse versus do-it-yourself option to set up a living code project, we need to compare more or less the cost to find a tool and integrate the tool versus the cost to develop a tool. That's more or less the question about this choice. So reusing is generally about finding a tool, if you don't know it already, finding the way to configure it, and potentially doing some customization if possible. It's not always possible. And then you run the tool on the CI, and that's fine. So overall, the cost is the sum of finding it, integrating it, and potentially customizing it. Doing a custom tool, the cost is the cost to understand the work to do, the cost to find the technology stack to do the development, and finally the cost to actually develop the tool. So just to try to illustrate these two evaluation, we can see that the cost of reusing can be very low, if you have an exactly matching tool for your use case and you are a senior dev. So I put senior dev to say you know what to do without reading too much doc or spending too much time, and junior dev to say you don't know yet about this work, so you need to learn a bit. So if you are a senior dev and your tool is matching exactly what you want to do, it will be cheap. So let's say 2 in arbitrary unit. Whereas the do-it-yourself will be a bit more, 3 or 4. But if you need to make your setup evolving and your tool is not designed to be evolutive or customizable, the cost can be very high. So it can go to 5 if you are a senior dev, to I put 100 if you are a junior dev, because you can lose a lot of time learning a lot of things to understand you can't do it actually. Whereas if you want to do it yourself, the cost will more or less stay the same. That's the cost of an update. That's why it's lower than the initial setup, because you actually do it yourself. So you can always do it. You will never be blocked, and it's generally cheaper after some time. So that's the main difference between reusing and doing it yourself. The initial cost of a custom solution is higher, but after it's cheaper. And whereas reusing a tool can be the opposite. So if we use a very linear model about the previous evaluation, we can see that reusing a tool is good if you have a few iterations about this tool. So basically, if you set it up and don't touch it anymore, it will be better to reuse. But as soon as you have updates to do to this part of your delivery, you will need to do something yourself to customize it, and the do-it-yourself solution will be cheaper anyway. And it's true for both junior and senior cases. The main difference is when is it more interesting to have a custom solution. So if you are a senior, generally, it's more interesting earlier. And junior, you need a bit more time to learn and fully masterize the solution. But at the end, it will be more interesting anyway. So it was a linear model. In practice, the model looks like something like that. So basically, you do a setup, so you pay an initial cost. Then it works automatically for multiple features, and after some time, you need to do a small update again, etc. And at some point, after a few updates, the reuse solution will be more expensive than the do-it-yourself solution. So basically, that's one criteria to pick one of both solutions. How many updates will you need to do, and how long your project will be maintained, and this part of the delivery will be part of your software delivery. So yeah, so when you need to choose between reusing and doing a custom solution, you need to take into consideration the project duration. If it is just a proof of concept or something you do for a demo, don't set. So either reuse something if you know something doing it for you, or do it manually. It's just a one-shot thing. You don't need to spend time coding something yourself because the initial cost will be a bit high. But if the project is a long-term project, ensure to have a solution you can maintain, and we will not cost a lot in time. So likely do something yourself. The developer knowledge is important as well. If you have only a junior team, or the team is new to a technology, maybe start by reusing something. And at some point, you can move to something custom if needed. If you have a tech lead or a senior developer, you can just start from scratch. It will be generally interesting. Then you have also the team knowledge target. So what I mean is, if you want your team to fully understand their stack, what they deploy, and how it works, the do-it-yourself option is very, very interesting because they will need to go through the technology constraint the team is using, basically. Whereas if you reuse, okay, it will look it works, but the team will not understand always what it does. And finally, a small point about the risk mitigation. If you reuse, it encapsulates a lot of things. So for build time, it's more or less generally okay. For runtime, it's another thing. So I'll give you a very simple example. You can re-implement a HTTP server easily today. You import netty, and in a few lines, it's done. But the risk to do it wrong is very high. So you can miss chunking. You can create vulnerabilities, like enable DDoS or things like that. So the risk is very high. So that's likely something you don't want to do. So once again, for build time, the risk is generally low. So the do-it-yourself option is very relevant. For runtime, maybe step back and ensure you know what it implies. So generally, when it does not expose outside the software anything, so it's not a HTTP server, it's not a broker, it's not a Kafka topic or whatever, it's safe. But when you expose anything, maybe reuse something. Okay, so now we know we want to do living code, and we know why. Let's see how we can do it in Java. So very quickly, the target there is to ensure we can develop a do-it-yourself option as any code. It's code. It's not delivered code in production, but it's code. So we want to have completion because we will write it in Java indeed. We want to be able to run it easily. We want to have IDE support. So I'm thinking about IntelliJ, NetBeans, or Eclipse dependencies management to have the completion typically. You want to be able to use a standard mechanism to get dependencies. So for instance, if you want to use, let's say, command stacks or whatever, you want to be able to import it easily without having to do a lot of scripts or whatever. Generally, you want it to be isolated from your main project. So it means you don't want to import this build code in your project dependencies. And optionally, you want to write tests because it can help the development in some cases. One important thing is, okay, you will write code you want to run on your project, but you also need to ensure the code can run on your project. What I mean is, if you write Java code, but you can't run it in your Maven build or Gradle build, it's pointless. So what is interesting there is Maven and Gradle will support to run a main or a runnable, basically Java code. But at some point, if you have too much, let's say too much code and too much feature in your generator, you can move to write a Maven plugin, a Mojo, or a Gradle task to be more native to the build and have access to internals of the build. I'm thinking about Maven dependencies, for instance, if you want to generate some reports about dependencies. So here is an example. So we have a Maven project, a standard Maven project. So we have, let's say, a core module, which is the main code which will go to the production. And we added a tools module, which is a simple Maven project with a POM. So I can have dependencies. My IDE will be able to load this module as any module. And I can write my code in source main Java as any module. So it's just a new module I add for the living code. So indeed, the tools module can be a tree. I can have a tools parent and tools, let's say Docker tools, OpenAPI tools, etc. If I want to make it modular. It generally depends the stack you are using. If you are using a lot of conflicting dependencies, you will need to split it. Otherwise, a single module is fine. And for companies with standards, if you develop regarding standards of your company, blueprints, you can extract this tools module in a shared module for the company generally. So then the trick to execute Java code, which is not a Maven plugin or a native build plugin, let's say, will be to import the tools project in the project you want to generate something. So let's say I import the tools project in the core project in scope provided because I don't want it to be transitive. I can also add exclusion on all transitive dependencies because the goal to import the dependency is just to ensure Maven is aware of the reactor. So it's building tools before core in this case. So it's just about the ordering. So you can exclude all dependencies using a wildcard in artifact ID and group ID. And then to execute the code, we will use Maven exec plugin, for example, or Maven scripting plugin, defining executions. So for instance, the first one, which will be executed after the main classes are compiled. And an interesting thing with Maven is you can pass arguments from the Maven context. So here I'm using the build directory, which is passed as an argument. So at the end, my main, so reflection-free classes in this example, will take a first arg, which which is interpolated from Maven context and will represent the output I want. So this way, I have almost the full Maven power using just plain Java code I can run with a main or even from my IDE to test it. The two small tricks about it is I'm putting tools project as dependencies of the plugin, and I ask the plugin to include the dependencies. This way, the plugin will run with all the class paths I need to execute my tools main. Another side note is setting up these two properties. So basically, ignoring daemon thread enables to use fork join pool if you want to execute concurrently a few things. Otherwise, you'll get warnings and some delay at shutdown. Okay, so I'll just give you a quick example we use at UPIC. So at UPIC, we have a small open source project you can find on our GitHub, which is called Bundlebee. It's a very light package manager, a bit like Helm chart, but it's done in Java, and the concept is a bit different and does not need a specific infrastructure typically. So in Bundlebee, you define a manifest in JSON, which defines alveoli. So that's an alveolus is a feature, an application. So here it's Zipkin typically, and I can list a few descriptors. So what's interesting here is the description of a feature is in JSON, can be in YAML. The main usage is a command line interface or a Maven plugin. And we have some reusable alveolus. So basically, you can import just with a single line, a Zipkin, a Grafana, things like that. So this project needs a lot of living documentation because we don't want to maintain all that manually. So typically, for the command line interface, we want to generate the help on the command line indeed, but also the documentation of the help, which is an index of the commands and one page per command. For the Maven plugin, it's the same, an index of the Maven plugins, the mojo, and one page per goal. For the JSON configuration, we want the user to be able to write the JSON file with completion. So we need to generate a JSON schema. And once again, we don't want to maintain it manually. We just want to maintain the POJO. We bind the JSON on. So we will generate the JSON schema. For the provided alveoli, so reusable part of application, we want to browse them to generate their documentation. So what's their name? Do they have open ports? Do they have configuration? Things like that. Yeah. And overall, the documentation will be a mix between manually written document content and generated content. So here is what we are using for that. So we have a UPIC tool Maven plugin. So it's basically just a Maven plugin able to generate an ASCII doctor website from ASCII doc source in the source tree, but with a small nice feature, which is to be able to execute pre-actions. And we can see we have actions which are specific to a project. We can see it's UPIC Bundlebee, so specific to Bundlebee project, or generic action, Maven plugins, JSON schema, which can be used for any project. So here we can see the mix between reusable and do-it-yourself solution. So the pre-action will be executed with some knowledge about Maven and the documentation before rendering the website, which enable the pre-action to generate content for the website. So here, very quickly, typically, we will have a generator to extract the global conf of the CLI and dump it in a ASCII doc file. For each alveolus as well, it will generate the documentation associated. For the command line interface as well, and for the JSON schema, we will generate it from the class representing our schema in JSON to be able to import it and have completion, and in ASCII doc, so textual version, to have a documentation, something human readable, let's say. And here is the result. So we have the main page, which is, so the index is generated from the content. In the content, you say, I am a page appearing on the index. So the index page on the top left is already generated. On the top right, you have a command page generated documentation from the command. So the command, it's a standard command. You inject options you support, and we generate this human readable form from that. On the bottom left, you can see the JSON schema in JSON, and on the bottom right, the JSON schema in textual form. And on the bottom, in the middle, you can see the Maven generation. So what is important here is we covered all the scope of the tool. So Maven, command line interface, configuration with the JSON schema, documentation with the website. So if we add a command now, we just run the build, and all that will be up to date automatically. So the cost will be the cost to develop the command, and not the cost to do all the small tasks, because we already paid it. So one important thing is when you go this way, so generation at build time, you need to ensure you test it. So yeah, you can write unit test, but the most important is to ensure it is executed when you do a pull request or push code on your CI, because it can break anytime. Basically, if you have a JSON schema and it is working well for Pojo, if you add let's say a list or a map, it can break if your code does not tolerate it. Or if you are using JAX-RS and using the response wrapper, you want to unwrap a response. You don't want response to appear because it does not mean anything in an open API or a JSON schema. So you need to ensure it works as expected. So ensure your generation is always executed for each build. It will avoid surprises. What you should not do is to run it only for releases, because yeah, it's a bit longer to execute this generation each time. But if you execute only for releases, it will likely fail for releases and it will block your release. Or you will bypass it and will end up doing the updates manually, which is something you don't want. So ensure it is always executed. So integrate it in your build, bind it to phases for Maven, and run it. So generally, it's just a matter of running a Maven command on your CI. So it should be easy to be executed. So what's interesting is also to integrate with an ecosystem. So what you can do, if you have a SDK or something which will be consumed by your consumer, so let's say a JavaScript application, a PHP application, or whatever, is to serve them what they understand. So if it is a JavaScript application, serve them the SDK as a NPM package in a HTTP client. If it is for Python, serve them a pip package. If it is for PHP, serve them a composer package. For Java, Maven registry bundle, etc. It's just static files in your HTTPS server. So ensure to finish the generation. So what I mean is, we saw earlier we created a TypeScript client for the greeting endpoint. It's not the end of the generation. The end of the generation is to bundle it as a NPM package and put it in a HTTP server. And you can do it adding a continuous deployment phase to your CI. So generally on main or master branch. But ensure to go through this last step of the generation. This way it is end-to-end automated. And indeed, you can also deploy to the cloud. the SDK to, let's say, an official repository for this SDK and things like that. So we do the same for the main code. We deploy automatically to the cloud the application. We auto deploy it with a canary strategy or whatever. We can do the same for all the living code part. Basically, the goal is to have a living ecosystem, and you just focus on the code and the value you add. So this is a very quick example we use at UPIC. Basically, we generate SDK for JavaScript, Python for one of our products. And we also generate a JSON schema to configure this product. It's not bundle, it's another one in this case. And we put everything in jar, in meta-inf resources, so which is the directory you can put in a jar since Servlet 3.0 to serve it. So it's like putting it in Dockbase. It's a static content. And you can see we have npm registry embedded for the SDK of the product called microget, and a pip package as well embedded. So this way, Python client, JavaScript client can directly fetch the package and start coding. We do the same for the JSON schema. So this way, you go in the configuration file, you add schema and the URL this resource is served from, and you have completion in your IDE. So it really smoothens the user experience to have this. It avoids a lot of manual tasks and communication where you can get issues at each level. So I think it's the last slide. So just to give you an overview of what we are using at UPIC. So it's just really to give you some pointers if you have no idea. So we are using a lot Miniseed Goal. That's the Maven plugin I showed before. It can be used with Gradle, by the way. It enables us to generate documentation for all our libraries and generate all the content we need before properly without having to combine Maven plugin, because the alternative will be to have maybe JBake plugin with a lot of executions. We created a plugin to do it all at once because we do it very often. Indeed, we are using ASCII Doctor to convert the ASCII doc files to HTML and PDF, which is a nice thing about ASCII Doctor. You can create offline version of your documentation thanks to ASCII Doctor PDF. For the JSON handling, we are using Apache Johnson through JSONB standard. That's what we are using for all OpenAPI and JSON schema generation. For everything which is about continuous deployment on Git, so GitHub or GitLab, we are using JGit, which is a simple binding. For everything which is related to APIs, we are using Java 11. The HTTP client is more than fine for that. You can even do concurrent calls very easily. We also support FTP deployments. So typically in pre-production or staging environment, we don't deploy to GitHub pages. We deploy to a simple FTP, and we are using CommentNet for that. To scan annotations, we are using Xbin. So basically, I said earlier, it's important the endpoint is using annotation, because if it is using code, so for instance, if you know commands CLI, you will code your options. It's not scannable. So it will be very hard to be able to generate content from that. Whereas if you have annotations in Java, you can go read the java.class, that's what does Xbin, and find classes from there. And this way, typically in the example, the previous example we had add config property. We can find all the classes in our application with config property and convert the config property to ASCII doc in our case. So it's very important to use annotation-driven development when you want a living code or living documentation. For SSH, we are using JSCH. So typically, it's used for a benchmarking tool. We auto-deploy at build time machine on Amazon, and we upload the benchmark scenario using this tool. And to build Docker images, we are using a Jib. It's a Google library creating OCI images, so Docker images basically. And so you can use the Jib Maven plugin. It works very well. It just has a small drawback. It does not support a CDS for Java. So you can't optimize the class loading and reduce the startup basically of your application. So we've wrapped the Docker creation, Docker image creation in a small utility. So it's a main, you do it yourself. So we are using Jib to create a base image without CDS. When we run some command in the image, and it enables us to generate the CDS archive, and then we create a new image from this generated file, and we have an image with CDS support enabled. So this way we boot way faster. So if I remember correctly, we were starting in 1.5 seconds, something like that, and now we are starting in half a second, I think, with CDS enabled. So overall, what you have to keep in mind is Living code is custom code with some transformation, with simple build integration, and with a deployment support. And that's it for me. I don't know if you have a question.
Yeah, thank you so much, Romain. Thank you for your presentation. I'm sure that our audience has enjoyed it. And by the way, already, and they definitely enjoyed your your slides, because somebody of yours already asking, how can you? Is it available? Are the slides going to be available after the presentation, or can you actually share them with our viewers? How it's possible? Is it possible?
Yeah, sure. I saw there is a space on Geekle to put the slides. I didn't dig yet, but I'll do it after. Yeah.
Thank you so much. I'm sure that question for Carmen, and there is additional question for Carmen, which I would like to show you. How often do you upgrade libraries to new versions, and does this create any issues?
Yeah, so basically we are using, I don't recall the name, but Sonatype did the plugin based on their database of issues. It's OSS index, something like that. So we are running it on the CI regularly. So each time we push, and once a day, something like that. So if there is a vulnerability, we have a notification, and then we upgrade the library. In terms of issues, so we are mainly in the do-it-yourself option, and the stack is mainly Apache. And there are very, very few breaking change there. If you compare it to, so yeah, don't laugh, but to Google and Guava, we don't have this kind of things. So we don't have much issues because we paid the cost to do to use the stack we masterize and own. You can get surprises when you are using something from the ecosystem, which is either managed by a single man. I'm thinking to Jackson. It is widely used, but it's mainly a one-man project. Or handled by a company which has different target. So yeah, choosing the library is important. Choosing a big vendor or big foundation, open source foundation, is a quality sign. So if you pick Apache or even Eclipse, it's not that bad.
Thank you, Romain. And by the way, I'm not the only one who is very grateful here for your presentation, because I'm really can see a lot in our comment section that they're very grateful for the presentation. They definitely will follow it. And moreover, just in case for you to remind, as far as we're going to have upcoming QA Summit, there is a chance for you to win a ticket just asking some of the very interesting questions to our speaker, Romain. So Romain, please tell me, is it possible, and how is it possible, when is the time to switch from the reuse tool to a custom solution?
Yeah, so you have two moments. The first one will be you just can't do it with a reuse tool. So yeah, for instance, we were using a plugin. It's called TypeScript Maven plugin, something like that. So it's taking a Java model and generating TypeScript binding for this Java model. And it was not supporting some of the feature we were using in our model. It was open source and standard feature, but it was not supporting it. We had two options at that time. The first one was to contribute to the plugin. So we did for a few. And the second option was to use a custom solution. And if the cost to update the tool and go through the process of doing a pull request, get the new feature, get it approved the way you need, and not the way the maintainer wants or thinks it's better, if the cost is too high at some point, you'll switch. So basically, the question is not do you want to switch or something like that, but more you start to pay too much to maintain it, so you switch to pay less after some time.
Like, but is it like possible? And is there a point to switch back from the custom solution to reuse tool?
Sure. In particular, in companies, so often what will happen is the company will have nothing. A team will do something with exec, custom code, things like that. If the team communicates to other teams, they will say, "Oh, it's great. I want to do the same." And at some point, the architect team or a transversal team will do a Maven plugin with this feature, and the teams will move to this new plugin, doing it specifically for the company. So it's it can be done, and once again to reduce the cost and unify the overall practice across the company.
Thank you, Romain. Quick question from Sujis, and please, quick reminder as well that we have additionally only 5 minutes because the time, like we are live this time, of course, as always, and the majority of our presentations are live. That's why we have to be in time. Just in case, questions from Sujit, and which Java version this library compatible with? This is question for Romain. Request for you, please be very quick with asking questions. Thank you.
Yeah, generally, all I showed in the slides are Java 11 compatible.
Thank you so much. Next question. Can generation be used with upstream or downstream projects to reduce integration cost?
Yeah, that's generally one of the goals of the SDK generation. Typically, when you generate, so you have a backend and a frontend, you will generate the binding for the frontend from the backend. It will enable the frontend to break if anything changes or is unexpected, and reduce the time you realize it. So it will break, but immediately, and you will fix it. It will cost a bit compared to doing all the development with a broken setup, but which runs, and realize it late and have to spend the weekend fixing it to deploy on Sunday. So yeah, it reduces the cost generally, and you can combine the builds on the CI and Jenkins or whatever to make them chained.
Thank you, Romain. A quick question from Tom. How would you decide which version of Java to use from Java 11?
I think so. Java is moving fast now, and for a short period of time.
Sorry, after Java 11. Quick.
Yeah, I think it will be mainly LTS because the version between are not supported for long enough. It's like 6 months of support, so it's pointless.
Thank you so much, Romain, once again. And again, our audience is really grateful. Romain has shared also his context at the end of the presentation. So please definitely follow him. And if you have additional questions, please address him via social media. Thank you so much once again. Really great to have you here at our Java Summit. And hopefully we'll see you at our next events as well.
Yeah, sure.
Thank you. And we are moving forward because, as I told you, lots of presentations are ahead. This is only the first day. And as you know, we're going to have 2 days of the most interesting cases when we're talking about Java. And today, within our Java Summit, let me also introduce you our next speaker, who is going to be here today. And in this case, please give it up, as they say, to Alexander Rielsen, and he's developer advocate for Elastic. He'll tell you more: 2 steps forward, 1 step backward compatibility and Elasticsearch. More is to come, so please, as they say, stay tuned.
Welcome everyone. I'm Alex, working at Elastic, and the next 45 minutes will be about backwards compatibility in software and how we can make sure that software is backwards compatible, how we can aid users to upgrade their software to make sure they're on the latest release, and we will take a closer look at Elasticsearch, what steps are taken within Elasticsearch and the Elastic Stack in order to achieve that. If you have any questions, feel free to ping me on Twitter anytime. So, what's today's goal? Today's goal is not only to show things within Elasticsearch, but it really is about thinking about your own services and how you can provide backwards compatibility guarantees and help users upgrade. I will just use Elasticsearch as an example because that is the code base I'm most familiar with. So just in case you don't know, this kind of sets the image of why Elasticsearch in particular needs to be backwards compatible and why we have to think constantly about this. You can see on the right side that there is the Elastic Stack consisting of Elasticsearch, Kibana, Beats, and Logstash. And on top of that, there are 3 solutions which are basically based on the whole stack and are specializations for enterprise search, observability, and security. And of course, we're also running the stack ourselves and offer it as a service within Elastic Cloud, which means we always have to think about making sure that you can upgrade seamlessly. And Elasticsearch is sitting right there at the heart of the stack because it's storing all the data. You can query it and it returns the data from queries. Kibana is the management and monitoring on top of Elasticsearch, and of course there are helping tools to ingest data into the Elastic Stack with Beats and Logstash. So Elasticsearch itself is a search engine. It's a full-text search engine, so you can type in a term and get back the results. You can do analytics with it, you can use it for geo searches, you can combine all of those 3 if you want. And it's supposed to be near real time, so the time between adding new data and making it available for search is as low as possible. Elasticsearch is distributed, so it can run as a single node or as a cluster with hundreds of nodes if you really need to. So it's scalable, it allows you to scale out, but you can also scale up just utilizing bigger hardware. It's supposed to be highly available. Of course, this doesn't refer to a single node. It's more about if you have a cluster and the single node within that cluster fails, the best case will be that the user doesn't even notice. And that also comes in combination with the resiliency that the system itself figures out if there's a node outage and starts moving this kind of data around. So the cluster itself has to communicate a lot, and that is also important for backwards compatibility, also because you cannot just upgrade a cluster with many, many nodes and shut everything down, bring everything up. And we'll talk about that later as well. The interface is HTTP and JSON, so HTTP being the protocol that many developers know, JSON being an object notation that many developers are aware of. So what is backward compatibility? I just want to make sure that we kind of have the same definition of this. And why do we need it? So that might probably be the first step we should take. And one of the things why you need it is because you want to run different versions of the same software in parallel. You want to make sure that you can upgrade a system or a distributed system like an Elasticsearch cluster without any downtime. And you also would like to reduce the dependencies between clients and servers. So if you have an Elasticsearch version like a 7, 10 something, you want to make sure that you can communicate with an older or within your client with it without having to worry that this doesn't work. And I think this is a often underlooked part of backwards compatibility. Even systems that only talk to each other rarely or have this one single request, they also have to make sure they can talk to each other even if the data format or the structure changes. And what is complex about keeping all of this backwards compatible? Let's take a look at the different deployment models first, because I think this simplifies a lot. And the best case that can happen to you is if you provide software as a service to others. So you basically hide the whole implementation behind that. You may be providing HTTP endpoints and certain software like Elasticsearch as a service, but how it's run internally, how you upgrade internally, is not so much of anyone's concern. And that simplifies the whole deployment and upgrading model a lot. If you just offer an API and not so much software as a service, the backwards compatibility guarantees are okay. Many implementations choose this by different URLs for different versions. Amazon, for example, had the date timestamp in there when the API was basically released, and that might be a good way. And the worst thing is actually on-prem software. If users are able to download your software, they are responsible for upgrading. And that might mean that you need to provide them a path with upgrading, but you don't know how the software is deployed. You're lacking a lot of details, so you have to build a very reliable and fail-safe way of upgrading software. So why should users upgrade? What are common reasons? I think the most important reason from my perspective is always security. If there's a problem with your software and you can do something insecure like accessing files or data you're not supposed to access, crash a service, drafting in denial of service, or taking over the host, then those are really valid reasons to upgrade, and also to upgrade as soon as possible. The other part are bug fixes. If your user is using software and something is not working as expected and you release a bug fix, you want to make sure that the user can easily install this bug fix. Then, of course, functionality is a great reason to upgrade. If you add new features and that solves a business problem for the user, then upgrading makes a ton of sense. If the user gets free performance, so you're starting to utilize your resources faster, or in the case of Elasticsearch, a query gets 20% faster, then this might be a really good reason for someone to upgrade as well, because at the end it might save them a lot of money. And the main question here is regarding the motivation. Is it more voluntary or is it forced? A security upgrade to me is more of a forced thing, because you want to make sure that your systems are up to date, whereas functionality is more of a voluntary motivation, where you want to make sure you are able to use a feature in the future. Performance might be a little bit of both. Maybe you have to cut costs and then an upgrade is needed. But it also means that if people are not forced to do it, they may just defer it and they will probably never do it. And that is something where there needs to be some sort of intrinsic motivation for users to upgrade as well. And then the next question is, also for your own software, is what blocks users from upgrading? What are the blockers from upgrading? And of course, if you just want to have one big category, it would be changes that break the existing behavior, backwards compatible breaking changes. So maybe you need to do work before you upgrade. Maybe there needs to be done work during the upgrade. Maybe there needs to be done work post the upgrade. And if this work is bigger than the expected gains, people will just not upgrade. And there are many more subtle possibilities. In the case of Elasticsearch, it could be a change in the protocol, for example, how a query is written, that something is not supported anymore and you have to make sure to upgrade all of your clients first. It might be functional changes, that a feature gets removed that you really relied on. It might be behavioral changes, that you cannot read old data because it's too old and there's certain compatibility guarantees that will break with your next major version upgrade. And the way Elasticsearch is doing this is that, for example, we try to go with semantic versioning. So there are 3 version numbers: the major, the minor, and the patch number. If there's a new minor version, we will not release new patch versions of the older minor version. There's always a major version below the existing stable one that also gets maintained, though there are a couple of rules around that for us. One of the rules is also that every version gets bug fixes, but new features are always only going to be applied to minor versions. So if you have 7.9.3 released and you add a new feature to it, it will occur in 7.10, which also implies that you have rather regular release cycles for minor releases in your system. And lastly, if you want to break backwards compatibility, this can only be done in a new major version. So if there's a backwards compatibility changing behavior between 7.10 and 8, that is okay. It will never happen between 7.9 and 7.10 in this example. So this brings us to the question, how to prepare and ease smooth upgrades. Like, what can we do as a developer of a piece of software to make it as easy as possible for the user to upgrade, to basically take away all the anxiety, pain, or bad experiences that happened previously. And there are different kinds of upgrades. I will talk more about the on-prem upgrades here. I will not talk about the software as a service use case or the API use case. That we'll briefly touch later. But for Elasticsearch, we just can imagine that many people run this on-premise. The upgrade path is very different if you use Elasticsearch as a service using Elastic Cloud, of course. So there are different kinds of upgrades. You could tell users, look, you have to bring down the whole cluster, the whole software, replace it, and then restart it again. You could also go a little bit different and tell users in a distributed system, at least, that they can do something called a rolling upgrade, where basically you have a version, you upgrade to a new version, and then you do this for each node until all of the nodes are in the new version. The biggest advantage here is that this is probably without downtime. And the other part of upgrades are always the clients communicating with your systems. Are the clients able to communicate with the old version and with the new version, or do you need to upgrade to a client first that is capable of communicating with those two versions? If you have to bring down your clients as well as your servers, then suddenly your upgrade will become really, really complex. Also, what kind of compatibility guarantees do you want to offer? And again, those kind of guarantees need to be seen from very different angles. For example, if you store data, you need to make sure that whenever you release a new version, it is able to read data from an older version. But should it be able to read data from a version from 6 years ago? Or is it just good enough to be able to read the data from a previous major version? This is the way Elasticsearch has taken right now, because the underlying library that is writing the data, Apache Lucene, is having these guarantees at the moment. So when you write data with Elasticsearch 7 something, you will be able to read this data with Elasticsearch 8, but you might not be able to read the data with Elasticsearch 9. So this is kind of a first guarantee, but this is just the data on disk. And this is not talking about configuration options, or any of those. Also, we need to take care of node-to-node communication. So Elasticsearch uses its own serialization protocol, and that must work with a different version. So two nodes with different versions still need to be able to talk with each other. This might not be needed if you choose to pick your own generalized protocols on top of HTTP, but the moment you're dealing with payloads, you will have to make sure that those are compatible with different versions. Again, one of the tricks here is there's no need to support all previous versions. The basic idea here is that you take the latest version of the major, like for example, for now it's the latest 6.8 version, will always be able to talk with the latest 7 point something version. So if you want to do an upgrade from two major versions, you have to make sure you're on the latest old major version to be able to update to the newest new major version. How does it look like? This is the example for node-to-node communication in the source. You can basically see here, this is a custom class for reading data. And you can read different kinds of data there, like booleans or variable longs. So you don't need the number of bytes a long needs. When you read data, it can be shorter if the number is rather small. But the interesting part is down here. So we know the version of the stream input. We know that the other side of the stream input, which is a node, has a certain version, and only if this version is able to understand what we want to write right now, we also write it or read it from the stream input. In this example, we read data from another node. The next step is how to prepare and present backwards incompatible changes. I just mentioned if you want to introduce this kind of changes, you always should do this within a major version. But if you do, you still have to tell your users, look, we're going to change something, and it's likely that you will have to change your existing configuration. And this is absolutely crucial to give the user confidence in the upgrade. So you need to come up with ways to notify your users, to tell them, look, if you upgrade, this is going to be a problem. And for Elasticsearch, we came up with a mechanism of deprecation. So if we know that something will not be the same in the next major version, we want to make sure that we warn the user about this. So there's a so-called deprecation log, there's a deprecation index, there's a deprecation response header. And the basic idea here is whatever is within this deprecation, you will have the chance to fix this in your current version so that when you upgrade, there doesn't need to be any work to be done. So you can do all of the preparing work before you upgrade, and then during the upgrade and after the upgrade, you're not supposed to have any problems. This is one of the reasons why the deprecations are already occurring one major version earlier. So if we change something that is backwards incompatible in Elasticsearch version 7, we will add those deprecations in Elasticsearch version 6 and let the user know, look, there's going to be something that changes. So this is a common example that we changed in Elasticsearch 7, where we changed the number of default shards. So when a user creates a new index and doesn't specify the number of shards, we will tell the user in Elasticsearch 6, look, in the next major version, Elasticsearch 7, which has been released some time ago, you will have a different default behavior. So if you want to keep this behavior, please make the configuration explicit. And this is basically how it looks like. When you create a new index and you don't specify the number of shards, there will be an additional HTTP response header telling you that the default number of shards, like this is a first warning header here, will change from 5 to 1 really soon. We pretty much do exactly the same in Kibana. Kibana has a small tool called DevTools, which is really useful, or a console where you can write index statements, but it also features like autocomplete. So it's really, really useful. And also there, we will expose this information that in the next major version, there will be a difference. And lastly, there's a log file on the Elasticsearch site. So whenever a user is executing an action that will change in the next major version, this is logged in the deprecation log file. Well, the problem here is that a log file is not to be read, right? Like if you just write things in log files, people will just not look it up. So they will probably never notice that they use a feature that is about to be deprecated in the next major release. We also cannot assume that all of the users are using Kibana. We also cannot assume that a consumer of Elasticsearch, like a tool indexing data into it, is reading those headers and reporting them back to the person which is administering Elasticsearch. So we may expose this information, but maybe to the wrong people, or the people don't look at it. And this is a problem, right? Because if you're not aware of upgrade issues, you will start your upgrade and then you're getting mad because nothing is working as expected. So we have to come up with better ways to notify users about changes and making sure everyone is aware of that. And one of the things that we did for Elasticsearch 7 and that we will also do for future versions is to have a dedicated upgrade assistant in Kibana. And this is really useful because this upgrade assistant is basically going through a number of checks for Elasticsearch and its setup, and can also do the same for Kibana, to just say, oh yeah, your settings are okay, or your settings are not okay, you will need to change something in order to have a smooth upgrade experience. So as you can see here, there's a cluster tab at the top of the upgrade assistant, and it's already warning you that a certain configuration setting is required in the future in production mode. And it links to the documentation, it mentions the nodes that are impacted, And also for every index in the system, it goes through the index configuration, which is called the index mapping in Elasticsearch. And the upgrader system will tell you, look, something is going to be different. You might have a problem. If you want to fix this, go to the documentation. There's also one short sentence, which will try to quickly explain what the issue is. Also, it's warning you to create a backup of your indexes. So just to make sure that everything works, or if the upgrade would not work, that you always have a snapshot that you can quickly restore from. So what else can the upgrade assistant do? The upgrade assistant also helps you to reindex old indices. I mentioned earlier that in the case of Elasticsearch, Elasticsearch is only able to read indices from one major version back. So if you have an index that you created with Elasticsearch 6, you upgrade to 7, everything's fine. Then you upgrade to 8, and you're potentially not able to read the index created with Elasticsearch 6. In order to fix this, you can just reindex old indices, which then means they are written on Elasticsearch 7 and the upgrade will not be a problem. What you should do is, when you reindex or when you also potentially change mappings of internal indices, that you pause the services during that time that need to access or write to these indices. Also, the upgrade assistant replaces the index templates, and if there's a reindex required for an internal service that only Elasticsearch is using, then those services are stopped automatically. We also just saw the possibly incompatible mappings in user indices that you get warned about. And the last part is that so-called set of deprecation checks is actually run, and we want to take a look at that one in detail as well. There are different kinds of deprecation checks. So this one is checking for so-called cluster settings. So settings that are configured cluster-wide, and it basically checks the configuration if there's anything that probably changes in the next major version. The same applies for node settings. There are certain settings that have probably been removed or renamed. Many of those have been removed, or for example, insecure TLS protocols got disabled. So this check checks if you're still using any of those. The same happens for every index. There's another list of checks that are basically run through, like using an old and deprecated date format. I will talk about that in a couple of minutes. And for machine learning, the same happens. And those checks can be run from the upgrade assistant as well. The thing is, these deprecation checks are only a partial solution, because what they check is first Elasticsearch only, and it's only the configuration. But if someone is sending you queries that contain maybe a part of a query that will be deprecated in the future, then you can't see this right now when you're running those deprecation checks. So what can we do to inform about deprecated queries? The idea here, or solution to this, is to introduce something called stack-wide deprecations. And the basic idea is that those deprecations should not be written into a log file in the case of Elasticsearch, but written into an index. And that every component which can access Elasticsearch can also write this information to a log. And the upgrade assistants can just query an index and tell you, look, the following components are using features that are probably outdated. And this is a really nice solution to get a whole overview of all the components within your stack where you need and change configurations. Yeah, this is just a side note coming from software engineering. Most of you probably know this. Testing is important, and if you claim that you support something like a rolling upgrade and a full cluster restart and running in a mixed environment for a short amount of time where basically different nodes with different versions are working together, then you have to test this. Elasticsearch has quite an extensive test suite to actually run these kind of setups and make sure it works as expected. But just a reminder, if you offer features, if you document them, make sure they are also automatically tested. Let's take a look at a couple of examples, how we dealt with backwards compatible and incompatible changes. And the first example is the switch from Joda to Java time. Joda time used to be the de facto date library for a long time, but I think since Java 8, there's an own Java time package, which is written by the same author. And the Joda time library only supports millisecond resolution, which is okay for many, many use cases. But if you go to industrial manufacturing, you really need to get down to nanosecond resolution when you store dates. And also Joda time is kind of in maintenance mode. It only gets updates for the time zone database. So JDK and Joda time are different beasts, even though the author, for example, is exactly the same. But of course, he took a couple of learnings from Joda and applied it to Java time so that it's not the same. And this is just one example that can be really confusing. If you use the pattern YYY, the date pattern, which resembles the 4-digit year, it's treated differently because on the one hand, it's a year-based date. On the other hand, it's a week-based date. And this means that if you apply this to the last day of 2019, you actually end up with 2 different years being returned, depending if you get back the week-based or the date-based year. So this means you cannot use the same time formats across your product, and you need to come up with a good plan to actually make sure that users are not using the old formats. So Elasticsearch 6 uses Joda time for date formats. But if certain Joda date formats are used that are supposed or that are known to be troublesome and change their behavior, there's a deprecation warning emitted in 6.8. Also, there was a second format introduced, which allowed you to specify Java time formats already in Elasticsearch 6. And this means you could configure everything in Elasticsearch 6 to work as expected. And when you upgrade to Elasticsearch 7, those fields are basically used as well. And then over time in Elasticsearch 7, you could basically switch the default formats to use Java time instead of Joda time. And also emit a deprecation warning if date with the new prefix was used, so that everyone goes back of using the old prefixes. And then in older versions, you can drop support, and at some point you can remove the Joda dependency. Another example is the removal of types from indices. So types were basically an additional meta field in Elasticsearch if you want, but if you used types in terms of very different documents indexed in the same index, the index data structure would not be as optimized as we hoped. And so we wanted to remove types from indices over time. And in Elasticsearch 6, indices could only have a single type. However, in Elasticsearch 6, you still want to be able to read old Elasticsearch 5 indices. What you still would like to prevent is that new indices cannot be created with more than one type. So this is not possible with Elasticsearch 6 anymore. And also in Elasticsearch 6, you don't need to specify a type. There's a so-called pseudo type. And since Elasticsearch 7, indices do not have any types, but they are still APIs, which refer to the underscore doc pseudo type in the URL. And this is something that you would like to have changed as well in the future to get rid of that. And you can see here that this whole type removal takes 3 major versions, which are years of duration between the 5.0 release and the 8.0 release. So this takes a lot of work to do something that looks small on the outside, but is ensured to not break anything. Yeah, another thing is the version compatibility. So you want to make sure that every client from a certain version can communicate with Elasticsearch. And if you change the API, this client should still work. And a major version upgrade right now could break certain endpoints or the request structure, being a backwards incompatible change. However, upgrading all the clients in the correct order might be impossible. Imagine that you have users of your system where you're not responsible for the upgrade cycle. That might be a problem in there. And the first candidate for being really REST API version compatible, so that even older clients can communicate with Elasticsearch, is the compatibility for types. This is something that is being worked on right now. I also want to talk about a couple of strategy of how you can basically check in your own system if there's a deprecation issue or not. And for Java, in the Java client, there's a really nice trick where you can set the so-called strict deprecation mode. And this results in an exception being thrown and a failure and the response not being processed if there's one of those deprecation warning headers returned. And while you may not want to put this into production, it might make a lot of sense to actually put this into CI. So if you have enough tests and all of your tests cover most of your life scenarios, your CI will suddenly start to fail if you use a certain Elasticsearch version where something is deprecated. So you can fix it in your application, and then you know everything will work in production as well. Another indexing strategy, or a strategy here, is to use something called reindex from remote, because if you still have a really old cluster lying around, like Elasticsearch 2, and you want to upgrade to the latest 7 version, you would need 2 full reindexing steps from your data to go from 2 to 5, from 5 to 6, from 6 to 7, just to get the data into your system. And that means you would spend a lot of CPU cycles, a lot of memory, a lot of resources simply on this reindexing. And that is rather heavy. Another idea would be to use the reindex from remote feature from Elasticsearch to basically pull the data over HTTP and then just index it and take the original JSON data. So this is a one-time indexing cost. You could do things like scripting if you need to change the structure of the documents. I mean, if you upgrade really old systems, there's often the case that you also need to upgrade the data structure along with it. So this is possible, and this would save you from this kind of double index problem. There's another strategy, and this is about time series data. So something like logs, for example. And the assumption here is that if you have an old cluster with old time series data, that this time series data grows out over time. So if the data gets old enough, it probably gets deleted. And instead of reindexing this data, there could be an alternative that you just spin up a second cluster and index the current time series data into the second cluster. So now you end up with 2 different clusters, one old cluster with old data, one new cluster with new data. And when you need to query it, you can use a feature called cross-cluster search in Elasticsearch to just query both clusters as if they were one. This might be an easier solution than updating all of your products partially. You could also just do a switch step by step from the old cluster to the new cluster with your ingestion pipelines. Yeah, one interesting feature of cross-cluster search is that it allows you to query 3 different major versions. So you could query one major version up. So if you have cross-cluster search configured on Elasticsearch 6, you could query Elasticsearch 7 and Elasticsearch 5, spanning a lot of different major versions in there. And of course, coming back to our assumption from the beginning, as this is time series data, at some point you can probably shut down the old cluster and you will only end up with a new cluster because the data has aged out. Yeah, this is a thing where Elasticsearch had to take a drastic step and measure to remove functionality. And this is delete by query. I just want to mention this explicitly because sometimes you have to remove functionality in your application. And this is a very hard change because it is not backwards compatible, right? You just remove something and then it's gone and your users can't use it anymore. But sometimes this might be necessary. And in this case, we have the removal of the delete by query functionality, which is a really nice functionality. You can specify a query and all of the documents matching that query get deleted. However, the implementation from a long time ago, I think it's 5 years or something like that already, maybe even more, could lead to different data between the shard copies. So shard copy should be a one-to-one copy of the data, but the functionality how it was implemented could end up with different data. And this was an absolute no-go for Elasticsearch. So what basically happened here is, because we really valued the data consistency, we had to remove this feature in its current implementation. So the functionality got pretty much removed immediately. And the user reaction, of course, was like, this worked perfectly fine for me. Why did you delete it? Now I have to rewrite it myself. And back then, it was actually true. So what we did is we documented the steps to achieve this in a safe way using the existing APIs, but of course on the user side. So you had to write some code. And over the next major version, we added the infrastructure to basically run long-running tasks in the background. And with this, we could do the exact steps that we documented to achieve this in a safe way. We just implemented this within Elasticsearch and implemented delete by query on top of using long-running tasks. So you basically could poll this task, get the status, and so forth. And so even though it took a whole major version to get the infrastructure in place, we re-added the functionality in a safe way, but it was gone for a certain amount of time. So let's get to the summary. We're almost done here. One important part is for your application, for any application, if you publish stuff on the internet and others can use it and download it, and you do not provide any backwards compatibility, you will have a system in maintenance mode forever, right? This would mean you need to provide maintenance modes for every major version, keep patch cycles around, and really don't want to do that because this becomes prohibitively expensive over time. Think about preparation, like how can you tell your users that you will change features, that you will add features or remove features, that they need to change something on their side. And Elasticsearch picked the deprecation warnings. They were okay at the beginning. We now have figured out that we need to do this stack-wide and change this behavior. But you need to notify your users about upcoming changes so that not in the moment they're doing the upgrade, they're basically running into all of the problems. If you have a migration path, maybe you can allow for parallel operations in your tooling. Things like rolling upgrades are great. Maybe you also have something like a Kubernetes cluster where you can just start a new version of your software and then migrate everything over. That might work as well in the same size, given that the customer has the needed resources. Document breaking changes very well. This is the most crucial part. Like Elasticsearch has a really huge breaking changes document for every major version. That is absolutely crucial, and people need to read it first. So you have to make sure that people took a look at that. And don't try to create a sprint of removing things over a marathon. That is important. If you change behavior and you said to yourself that you only want to change behavior between major versions, sometimes going through the full circle just takes more than a single major version, and then so be it, and stick with it and deal with that. Yeah, if you remove functionality, like be explicit, help about it, talk about the reasons for that. Also, adding functionality is the thing, right? The thing with adding functionality is it's easy to add functionality. It's easy to write a code. The expensive part, again, is the maintenance, right? The moment you add functionality in your system, you own this functionality, no matter who wrote it, no matter who created a pull request. It's not a feature, and if you don't add it, there's no feature, but there are also no future backwards compatibility issues. That's just something you need to keep in mind as well. And talk to your users, like go to your users, ask them like what was your biggest pain point upgrading from version 2 to version 5 and so forth. And you will always get back feedback. Sometimes it's snarky, sometimes it's less snarky, but it usually is right. So go ask your users and figure out what the biggest problems are and fix those. And of course, if you're running as a service, even if you're running something like Elasticsearch as a service, you can go further with this, right? You can help a lot in the background to get everything done and then offer one-click upgrades so users only have to prepare their own applications instead of the software as a service. Especially for Elasticsearch, this can save so much time that it's a really good idea to make the upgrade experience as easy as possible. It's also really a good unique selling point. The last question I have for you is, can you quantify the cost for keeping something in your system, for staying backwards compatible for some features in your own software? And I don't have a concrete answer to that one. Like it's really hard to quantify making sure that your software is still compatible. One of the reasons is there's rarely a maintenance team for software. It's usually that all of the developers are doing it together. So just figuring out the costs spent in terms of hours is really hard to quantify. Also, the cost of support contact that you probably lose if you stop being backwards compatible is really hard to quantify. But maybe you have good ideas to go down with quantification of this and come up with a good idea of how to make sure you can make this more transparent in your own product and in your own company. That's it. I just want to say thank you for listening. Highly appreciate you being there. If you have further questions, you can drop me an email. You can ping me on Twitter. I'm happy to answer anything. If you want to know more, I will also share the presentation, have included a couple of links. If you want to know more about the Elastic Stack, there are ongoing meetups all over the world, most likely virtual nowadays, of course. If you have a specific question about that, there's also our Discuss forum for all the different products and solutions. And that's it. Thanks a lot for listening, and see you next time.
Thank you so much, Alexander. Actually, and welcome once again. How are you doing, Alex?
Hi there. I'm doing fine. Thank you.
Thank you so much for your presentation. And by the way, I can again see that a lot of our viewers were expecting for your presentation. That's why they are very grateful for it. And definitely right now you have a great chance to talk to Alexander and ask him questions. Moreover, as I mentioned previously to you, you'll have the chance to win the tickets to one of our future events, and probably you're waiting for a lot of people as well, awaiting QA Summit, which will be happening really, really soon. But before we move forward, actually, Alexander, you mentioned it would be additional questions from me. You mentioned, of course, when we are talking about Java, it's very important to stay up with the latest version. So right now we can see the latest Java version is like 16, if I'm not mistaken. But still a lot of developers, they're staying on the version 8 or like 10 or even 8. So what do you think, what challenges do they see to like, so they choose not to upgrade? Or on the other hand, what challenges they can see if they do not upgrade?
Yeah, I think it's a good question, and it also ties into how Elasticsearch is doing it. So I will tackle that from this angle. And Elasticsearch ships always with its own Java version, and this allows us to stay up to date with the latest ones. Be sure that we use a Java version that is supported. I mean, one of the big reasons people should upgrade is always there's so many performance fixes and stability fixes in the JDK that it's really hard to justify to stay on Java 8 or Java 11, and also they fall out of the support really, really soon. I know that there are very good reasons, because like some companies say we only support this one version, but I think coming up with benchmarks or similar things makes a lot of sense. And for Elasticsearch, we solved this problem by shipping a JDK within the Elasticsearch package. So the moment you download Elasticsearch, we have a JDK for you. Again, there might be corporate rules to not run this, so you can run it with your own. But this way, we know which version of the JDK it's usually run with. We know that this is tested on our own CI, and we can be pretty sure it's stable. And I think that's a good way. On the other hand, for application developers, which kind of get this set from the outside, it's really hard to switch. But I think there are extremely compelling reasons to try and go with the latest version, even if it again costs some more maintenance.
I see. What about like security issues? When we're talking about this, probably one of the things which like you may explain more in details from like in technicalities. When we're talking about bugs, what are like the main bugs you may actually come across? You may challenge if, for example, you do not upgrade, because this is actually one of the things which I observe as well when we're talking about the programming language for developing blockchain technologies. So in this case, if you're not using the latest versions, probably you may have, even if it happens, to be honest, a lot of bugs with the newest versions as well, if they are not tried out for a long time, if they are not tested well. But at the end of the day, if I'm not mistaken, like one of the biggest problems, and here we're not talking about like different programming languages, these are bugs. So what types do programmers usually face, and how it's possible, like maybe the easiest way to overcome them with the latest versions and vice versus newest versions?
Yeah, I think like if like the most common bugs you face are security issues, I think you have a very different problem and should fix kind of more of your process and development strategies first. So I think most of the bugs also within Elasticsearch are probably from a functionality perspective, that someone runs a query, expects something else to be returned, for example, but like it's not what is expected. And those can be fixed. And the major strategy from my perspective is like bugs will always happen. There's no need to blame anyone. It's just like release early, release often. Like Elasticsearch usually has a new major version every few months, a new minor version every few months, like from 7.12 to 7.13 or something. But there are always patch releases. And of course, we have kind of a modus, if there are security bugs, we release faster because we want to make sure like every security issue gets solved as soon as possible for our users. But the majority of the bugs from my perspectives are always these kind of little functionality bugs. I think like the major ones we didn't have, or we rarely face something like data corruption or anything like that, which was really bad, really severe. And the other are usually just things which are not working as expected. And then we just go on and fix it. And we have a massive CI infrastructure. It's really big. It runs like several thousand runs a day, which catches a lot of those nasty bugs that we just hope don't occur in production. That's an important part. So this is one of the biggest strategies for us as well. Like CI is crucial and important.
Thank you, Alexander. Actually, you mentioned about data corruption. Please, can you dwell upon the examples which were there, which you can name, and which might be the most memorable right now for you?
For me, it was this delete by query part that I also mentioned in the presentation, where we have this premise that if we have data on one node and we have a so-called copy, a shard copy on another node, this data is supposed to be the same. And with the certain running of a command and a couple of very complex conditions, those things could run out of sync. And that was so bad for us that it was better for us to remove this functionality instead of doing anything else, because data safety simply comes first when you're a data store, or when you're storing any kind of data. Like you want to make sure you write it and you read it again. It's also the same after you stop the service or start it again. And this was kind of our, at least for me in the last 6-7 years, the one thing where we just had to act and had to remove a feature, which is something we very rarely do. But data safety is one of the most important things for Elasticsearch.
Of course, maybe this is one of the reasons why actually we've seen the development of such decentralized database, which is right now immutable. So you cannot like change data so easily, maybe. There is. Actually, also talking about Elasticsearch, because if I'm not mistaken, version 7.12 is the latest stable release of Elasticsearch, and now it's available for deployment via Elasticsearch service on Elastic Cloud. So could you tell more about to our audience about its features and specify as well on the feature of security as well?
Yes.
Security features as well.
Yes. So in terms of security, we have to differentiate between two things, because of course we have kind of a security product where you basically can run an agent on every of your local notebooks across your whole enterprise, and we kind of hopefully figure out if there's any threat going on, any malware being installed. That is security as a product. But of course, the one thing we always have to pay attention to is also that our products are secure as well. So this is something we also pay really high attention to, that if you install it and you enable the security feature, that they work as expected. And from a feature perspective, I think one of the really interesting features is the ability now that we are able to search data that is stored on repositories like S3 or the Google Cloud Storage. So you don't even need to load it into Elasticsearch anymore. You can just write a snapshot to those big stores, which are much cheaper in terms of cost than storing this on a hard disk, and still be able to search across this data, albeit a little bit slower. But this way you can store up to petabytes of data once you're willing to wait a little longer. And I think this is a huge game changer, because you could just write a lot of data, store it on S3, and still be able to search it. And that's, for me, the by far biggest feature for 7.12.
Thank you so much. Alexander, actually, we would love to have you more. The only thing that right now we have additional next presentation coming. Again, please, because still maybe there are some delays in our comment section, I'm asking everyone of our audience who's watching us right now and who has questions to Alexander, as far as you've seen his contact details, definitely find him social media. We're really grateful for being here. Definitely, hopefully we'll see you as well at our future events. Alexander Rilson, once again for Java Summit 2020. See you next time.
Thank you, and greetings from Munich.
Thank you so much. Bye-bye. We are moving forward, and as I promised you, today we're going to have additional lots of interesting presentations, and all the time from my part, I'm also all the time also very happy when I have the opportunity as well to invite ladies to speak, because today and right now we're going to have Kamila Oliveira, who is actually a backend developer at AMI Digital, and she'll talk about clean architecture, clean code, refactoring, tests. What does it change in my code? I think it's really interesting. So please stay tuned, as they say. Definitely an area to follow, definitely an area to watch, and definitely lots of interesting things coming up. So stay with us.
Hi, everyone. Hi everyone, I am Kamila Santos, and today we talk about clean architecture, clean code, refactoring, and tests, and what does this change in my code in my application. First, who I am backend developer at AMI Digital. I am also Microsoft MVP and Developer Technologies, book co-author, community co-organizer, and content creator at my Instagram, Kamila Code. So what are we going to talk about today? We're going to cover some topics. They are clean code, code smells, tests, clean architecture, and... So what is clean code? Clean code is simple and easy to follow, with isolated scope, easy to be tested, and well self-documented. As Martin Fowler says, any fool can write code that a computer can understand, but good programmers write code that humans can understand. And what are the principles, some rules of clean code? Clean code must be consistent, must follow the SCOUT rules that says that always leave the code better than you found it. Must follow RASAP that says refactor as soon as possible. In the refactoring topic of this presentation, we're going to talk more about this. Keys that says keep it simple, stupid. Usernames that reveal the intention, not A, B, full, or bar. Use a pronunciable and searchable name, a name that you always remind this name. For example, you always remind for find when you think a get method, and other examples. Don't define names with what you find most beautiful or cute. Follow the patterns and other rules. Choose a word by idea. Don't use find, and the other time use search for the same concept. Clean code is obvious for other developers. Other developers must understand your code, not on you. And clean code doesn't contain duplicated code. And we have the completely opposite of clean code, that's called code smells. Code smells has some categories. We're going to talk a few of them. And the first are bloaters. Bloaters are code, methods, and classes that have grown too much, accumulate over time as the program evolves. The first type of bloater is large class. That's the class that contains main lines of code, methods, and fields. The second is primitive obsession that uses string constants as field names and constants for code information, instead of using constants. Long parameter lists, there are more than 4 parameters for methods. Data clumps, that is parts of code that contain identical group of variables such as parameters or external configs that used many times in the code and many times they're written again and again in the code. Object orientation abusers that incorrect or incomplete application of OOP principles. And the first is switch statements. That's very complex switch statements are a sequence of if statements. Alternative classes with different interfaces, that 2 or more classes perform identical functions but have different method names and different interface. Change preventers, and if you need to change something in one place of your code, you have to make many changes in another place. And also, if you change something, you can break all of your applications. And we have other type of code smells that are called dispensables. That is something unnecessary and meaningless, the absence of which would make the code more efficient and easier to understand and cleaner. Some examples of the dispensable code smells are duplicated code, comments, and dead code. Other type of code smells are called couplers. Couplers contribute to excessive coupling between classes or show what happens if coupling is replaced by excessive delegation. And how to resolve this? One of solutions is making refactoring. And what's refactoring? Refactoring is the process of changing a software system in a way that does not change external behavior but has an improved internal structure, improving your performance, your code, and other factors. One of the causes of the necessary of refactoring is technical debt that consists of additional rework costs caused by choosing the easiest and fastest solution instead of using the best solution that will take longer time. And some causes of technical debt are lack of well-defined development standards and patterns, or lack of knowledge on the part of the team. Other cause of technical debt is postpone writing tests until later and never write. Other is business pressure, short lead time, lack of communication in the team, and think about improving the code later and never come back and improve this code. So we already know what is refactoring, what is technical debt. So now we're going to know when to refactor. When to refactor as soon as possible. During a code review, when your coworker make a comment in your pull request or merge request, you can make a refactoring. When adding a feature, and you can see a way to improve this code. When fixing a bug, when you go through the code and see the possibility of it being improved and you can invest time in it. And how to refactor a code. The new code needs to be cleaner than the previous one. The new code should be better performing than the previous one. New functionalities shouldn't be created during refactoring, just improve the code. Don't change your functionalities. And refactoring has some techniques, and we're going to talk about a few of them. Simplifying method calls. This technique makes methods calls simpler and easier to use. Modify the interfaces for interaction. Composing methods. In this category, we remove code duplication, simplifies methods, and prepare applications for other refactoring. Composes methods is a first technique of refactoring. And first you make a apply the composing method, and after use other refactoring techniques. So first you go to remove code duplication, simplify methods, and prepare the application. So we have the organizing data category of refactoring techniques that helps with data handling and untangling of excessive class associations. Another category of refactoring techniques is moving features between objects that teach how safely move features between classes, hide implementation details, and create new classes. Simplifying conditional expression that reduce and improve conditional expression, for example, 10 or more ifs in sequence or a switch statement with more complex choices. Composing methods. In composing methods category, we have a technique that is extract method. And where is the problem? The problem, for example, is a method with more than one responsibility, which can be extracted for a new method. It's applied for methods and for classes too, but this method or this class don't follow the single responsibility principle from the solid principles that says that one method or class must to have one and just one responsibility. So this method makes many things in one method or in our class, and it don't follow the single responsibility principle. So the problem we have in this example. We have a method public void print flow that calls method print safe, and in the same method they return the name, the value, and the pages for the impression. The solution, we make a method print safe that just call the print details method that go into another method and return the name, the values, and the pages. So we just separate the responsibilities. So the print flow just call the print save the impression, and after call the print details in another method, following the single responsibility principle from solid principles. Another technique is organizing data. An example, replace number with symbolic constants, a very common example. Problem, you have a code that can be represented by a constant, but starting off using a constant, you are using a number or a string many times in the code, and starting off use a constant for simplifying and reducing the code. For example, we have this method calculate potential energy that receive two double parameters, mass value and height value, and return the multiplication for mass, rate value, and this value, 90.81. The solution. We make a constant called gravitational constants with this value, and in the method calculate potential energy, we just receive the constants that always have the same value. For this, it's called the constants. So, we already talked about in this presentation about clean code, about code smells, about refactoring, how refactoring, when refactoring, about technical debt, and now we're going to talk about another very interesting topic, tests. We're going to cover some concepts of tests, but we're going to talk mainly about JUnit and unit tests, and view some examples of unit tests. So, the first concept is test switch. What is a test switch? Test switch is a collection of test cases or specs designed to test a program for a specific behavior. Test switches are usually divided according to the functionality of the system or the type of test performed. A test case shows the path taken by a model, use case, or functionality within the project. Unit tests test each code functionality separately, each unit of it. JUnit. JUnit is a platform for building and executing tests. JUnit platform. And the function of JUnit platform is discover and test execution in the JVM, that is Java Virtual Machine. JUnit platform exposes the test engine interface which defines the execution contract for any testing tool on the JUnit platform. JUnit Jupyter contains new features for building testing using JUnit and provides test engine implementation for running tests written with the unit Jupyter. JUnit Vintage provides a test engine for running tests written in JUnit 3 or 4, but use JUnit 5. So, what is Asserts? Asserts is a useful method for determining the pass or fail status of a test case. Declaration methods are provided by the org.JUnit assert class that extends the Java lang object class. There are several types of assert, like Boolean, null, is a special form of syntactic metadata that can be added to the Java source code for better readability and code structure. So we have some examples of assert, assert true and assert false, assert null, assert not null, and assert equals that compare to expected and actual value. So we have another example of unit test. Here we have a test on an API that we use the web test client, that is a reactive form to call APIs, that we make a get in this endpoint and see that the hero with the ID does exists and the body is correct. We have some best practice when we are writing unit tests. One of these best practices is standard test case names, for example, test, sample, source, create, order. I always try to make a statement for each test method. Establish minimum coverage per project or pull requests. Test only one unit of code at a time. Make each test independent of all others, so if one test fails, it don't mean that all of tests are failed, but just this one test breaks. Name your tests cleanly and consistently. And next, make a project with 2 projects for this presentation. So the first example I want to show for you is this example of JUnit. And we have some classes on this. We're going to show this. But we have the business package that have the item business services that have some methods, for example, retrieve hard-coded item and retrieve all items. Some business implements that set some data source, calculate a sum, and calculate some using data source. Let me see another package. We have the controller. We have 2 controllers. The first is a hello world controller. It's a very simple example. In this hello world controller, we have a get mapping endpoint that returns the hello global sum. And we also have the item controller that calls the items business service and have 2 endpoints. The first is a dump item that will just return the item with ID 1, the name global sum, the price 0, and the quantity 100. Another is item from service that will return the item from the service dot hard-coded. Will return the hard-coder for the business service. And the third are all items from the database that will go in the database and will return all items that have in the database. In the data package, we have some files, the item repository, and some data source. In the model package, we have the item that contains the fields the item must have. The first is the ID, that is your primary key, the name, the price, the quantity, and the value. And we have some resources there. The configuration from A2 database and data SQL, that is the demi data from some values in our database with just 3 items. And the test package, that is the focus for this demo, we have some packages. The first is the assert. In the package assert, we have the assert.jtest class that have some methods. The first is assert that just verify that the list of numbers contains 12 and 15, and verify this value A, B, C, D, E contains BCD, e termina com CDE. Let's run these tests and see what if pass. Just let's wait a moment. It's building the application. So the test from this file was passed. And we can see here, passed. Just let's break this test. CDEE. Let's see if now the test fails. The answer that I talked in the slides here. It's building the project again. Let's see what the error. So now the test was failed. The expected is ABCDE to end with CDEE. And here we can see the detail. Yes, so let's return for the correct version and run again, just to verify. And after we're going to see the other tests in this project. All right, so let's see the JSON after test. And we have mocked actual response that have the ID 4, name spring, price 0, and quantity 100. And we have true JSON answer, strict true, exact match except for X space. And another is JSON answer strict false. Another without escape character, just a JSON without this escape character. Let's run this class test. We'll build the project again. Our test was passed. So let's break this test now. Let me use 6 and here price 8. Let me run again. Let's see if this test broke. Yes, what expected. The test was broke, and the JUnit shows what expected and what got. So it's very simple to understand what was the error and how to make the corrections. So let's return to the correction version and run again just to verify. Okay, all right. So now JSON path tests. We have a string response from service with some values, and we have to verify the length. We have to verify the contents exactly and what exists in the second. Yeah, second, correct. On the second item from this list. Let's run this test. JSON path test. In the import, you can say what is used. So here I am using the assert J. That have this assert that and another assert true, assert not null, assert equals, and others. The test was success. Let's break the test now. So I went in the 30. Let's break the test now. The test was not broke. What's wrong? Oh, there is the second value, not the second item. So I need to change this to Java. Let's try it again to break the test. The test was passed again. Okay. Oh, here is just reading the value, not asserting. Okay, we not broke the test. So let's change this for 4, and now we're going to break the test. I hope. Let's run again. Yes, the test was broken. Let's turn to the correct version again. So now let's see the business tests. We have some business tests. The tests in the classes is retrieve all items basic. So we have item 2, item 2, price 10 and quantity 10, and item 3, item 3, price 20, and quantity 20. And I need to expect this. Let me run this test and see what happened. The test was success. Let's break the test. So here I want that the value increased by for 15 and here for 25. Let's break the test. This value does not match again. The test is running again. Let's see if the test was break. Yes. So let's change the value here for 150, and here for what's value. Oh, does not match. Let's run again to break just one of these. And we change it here for 500. Okay, we got success with this test. Let's run another test. List mock tests. We just verify, then a mock you have size basic, verify 5 is equals 5. Assert equals, another type that assert. Let's run one by one. Okay. Mock. Let's try to change this for, 10. Let's see what returns. Okay, it's broken. So now let's see. Let's change for 10 here. And after we run again this, let's do the second. So mock size, we return 5, return 10. Okay. So let's try to run this. Okay. Here, the expected result that return different values. So let's change this for 10. Let's see what's happened. Broke it, yes. Let's change this for 5. Okay. This ignore. Let me see if I really want to ignore this test. Let's run this test. Yeah, don't broke. When mock gets 0, then return Java, start equals Java, expected null. Okay. Start equals can be simple. Start null. I just make a refactoring live now. So let's run again. Let me see. Okay, don't break. Let's break now. Change this for summit, global summit. All right, let's run again. In this project, I really want to explore all the type of tests asserts, and for this reason, I'm showing all files, all tests, and breaking the tests, and refactoring when necessary, just for show all the universe of options you have to test your applications. But have a lot of more options beyond that I'm showing for you in the presentation. Right, let's change this for global summit too. And let's run again. Let's run this test. And Let me see. The test passed. Another run with parameters. Okay. Return with generic parameters. Mock get any int, return Java. Let me see. Let me see if it's real or if it is a break test. Okay, so let's break. Let's run again. As expected, the test fails. Let's make correct again. Next, verification basics. String value 2, at least once, at most, at never. Let me see the results of this test. Okay, right. So let's break again. So min number of invocations and int at last ones. Let's change some values. Expect 0, okay. Is equal from another. At most, I already have at most already. And let's keep this. I have always. No. Forgot this. And get to 3. Let me see if I change this, if I break this test. All these times, at least once, I'll make part of Mockito. That is another library, very used in the unit test. In the unit tests and another type of tests. Okay. Argument capturing, mock Andy, and argument captor. Argument captor also from Mockito. Let's run this test. You can see there are many types of assert, many types to verify and apply mocks with Mockito, and many types of tests with JUnit. It's a very, very interesting topic. And again. Let me run it again. Let's see if we break this or no. Let's wait. As expected, break. All right. Okay. Let me see another. Not this. Fine. What? Refactor. Okay. Let me see another file. Some business mock test. For example, we have a data source mock that retrieves all data and return a new int with 1, 2, and 3. I need to assert equals expected 6. Let's see if it will pass or fail. Let me see. Okay, pass. Because I already had 3 and I added 3 more. Okay. With an empty value. Okay, assert, when, assert equals. All of these make part of Mockito and JUnit assert. Let's test. I will test controller for the last test. Let's try the repository test. A test to find all data in the repository. Let's run this and see the result. Let's wait a moment. It's building the application. Let's wait some minutes. And the test passed. We have 3. Let's break 9. Let's see what happens. It's running the application. Consulting the database. Let's see the result. Break. Let's see what's happened. Actual 3, but expected 9, or no. What I can do? I can change this for 3 again, and success. Assert equals that the item with ID 1 has the name Java. Let's see if it's real. How to verify this? those items in this test. So ID1, the name is Java. Okay, correct. It will be success. In this test, let's break it. Let's make the change in the database first, see what's happened. Let's change this for coffee. And let's run again and see what's happened. Let's wait some minutes or seconds. Wait a moment and see what's happened. Break the test. Let's see why. Expected Java, but actual coffee. Let's change for the correct value this here, because if not, I will break all the tests. So let's see now the controller tests. The first item controller test. The first, I will get the dummy item URL and see the result. I expected that return the one item with ID1, the name global summit, the price 0, and the quantity 100. Let's see what's happened. The controller test, I will break many times this test as well. We're going to see here. Let's wait a moment. Right, success. Let's break. First, let's change the endpoint. If the test does not find the endpoint, the test will fail. Let's see. Let's wait a second. Is up in the application. Fail, right. Let's see. Request URL. Not found. Okay, right. Let's turn now to, let's change. I expected that is not found, quad 00. Let's see. If just with this, oh no. The test will pass. Is complete for me. Yeah, not found. Let's run again and see the result. Let's wait a moment and see what's happened with this test. Breaky. Why? JSON value broken. Okay, it's not work. Let's turn to is okay. And check now for 2. It will break again. Let's wait a moment. And see what's happened. Break, all right. So let's run the second test in this file. Retrieve all items from database. Let's see what's happened. Got success. Let's break. I want to change this from another price. The price will be 50. Let me run again. Will break, right? Yes. Expected 15, but got 10. Okay. Retrieve all items from database with no items. Okay, let's see what happened. Pass. I want to have another result here. Replace with collections empty. Let's see. Another refactoring. Let's see if I have the same result about the refactoring. the same result about refactoring. Now let's see the hello world controller test. It will call the hello global summit controller and expected the response global summit. Let's see if it works. Okay, let's change the response from the controller to break the test. Hello global summit for Java devs'21. And let's run array again and see the result. Let's wait some seconds. Break the test as expected. Let's see. I was expected hello global summit, but got hello global summit for Java devs. Let's change the test now and see what's happened. Let's run again and see the result. All right, let me return to the presentation. So now let's talk about clean architecture, the last topic of this presentation. What is clean architecture? Clean architecture tries to provide a way to organize the code so that it encapsulates the business logic and remains separate from the rest of the application and can't be accessed directly. The advantage of clean architecture is independent of framework, is testable, independent of UI, and independent of database. Let's see a very simple example of a type of implementation of clean architecture. Let's close these files. All right. So in this very simple example, I have three modules. The first is the client module that contains the request and the response from the endpoints at my API. In the domain package, I have the domain objects such like database and others. And the service, we have all the business logic for the hours application. And we have the controller package, gateway, translator, and use case. In the use case package, we have all the business logic and the implementation of functionalities of our application. Translators. To each layer, let me return to the slide. To each layer, I need to integrate with other. I need to make a translator, or I can make an output and input. You can use another name. But here I am using the translators. So I have a translator to request from domain, to database to domain, and to database, and to domain to database. In gateway, I have the configuration from access database, from queries, from call another services, and in controllers we have the endpoints. It's a very simple way to use the clean architecture. And what is the conclusion of the clean architecture, of clean code, code smells, tests, refactoring, and all the topics I cover in this presentation? About clean architecture first, it helps to better separate the responsibilities of the application. The negative point is that there is a much larger number of files. As you can see here, we have many packages and many files. And it requires a certain amount of learning time to understand what each module or package is for. This can also occur with other architectures and design patterns. It's worth evaluation what will improve in the application and if the team understands how to apply this. About tests. Implementing test culture can be complicated, mainly because it increases the development time, including the tests, but it's one more way to always guarantee the functioning of the business rules on the system. In addition to the techniques mentioned here of refactoring, there are several other techniques that help a lot. For those who have the culture of TDD, that is test-driven development, Refactoring is already part of the development cycle, so it's easier to remember this stage in development. And having unit tests also have new people who join to the project to understand the business rules and find bugs more easily. It's a type of a documentation of project. And that's all, folks. Thank you very much. And add me on social networks on the link above to keep in touch and answer questions about the presentation or talk about technologies. Bye-bye.
Thank you so much, Kamila, and really nice to have you here, and really nice to have our next speaker. Before we'll go there, just very quick reminder to our attendees, because we first of all want to thank you. We're very grateful for your comments, for your questions on YouTube and Pine, and of course, one additional questions which if you have one additional request which I have for you, if you have questions, for example, for Kamila, we will have her for Q&A together with our next speaker, and I'm really excited, really glad that today we're having a really nice women's company. Just a bit intrigued, but before we'll go there, just quickly, I'll remind you, as far as we told you, we really value, first of all, your comments, your interaction when you're active, when you want to participate. So we decided not to only do a giveaway of tickets, not only for your best questions, so definitely prepare Q&A with Kamila and our next speaker in a few minutes, but also what you need to do. So we are having right now a giveaway of tickets to someone who will post on Twitter some picture, and they will tag our official account of Geekle.us, Geekle official, and write about what did you like the most about our event, topic, or speaker. So this will be like your feedback. Definitely share it on Twitter. Once again, tag Geekle, and in that case, we'll choose 5 winners, and they will get 3 free tickets for our next events. I think this is one of the additional really great events. This is one of the great news. And as I told you, and as I'm really excited right now to have, because this section is about ladies general, ladies in tech. So in that case, let me introduce you, Shelley Lambert. Really, really great to have you here. Shelley Lambert, technical leader at Eclipse Adoption, Red Hat, and she'll tell you about, she will be dismantling technical debt and Hubris questions. Shelley, first of all, how do you do?
I'm doing very well, thank you. How are you?
I'm doing great as well. To be honest, I honestly really like when I can see right now more and more ladies in IT, and I'm really excited when I can see like with Kamila in the first right now when I see you. And as I mentioned like previously, this section is only about ladies. Our next Q&A only will be about ladies. So Shelley, I'll ask you as well because I'm sure, and I can see also in our comments that I can see that ladies are also watching us. Mm-hmm. So maybe your message as well to someone who's thinking, oh, this is only a men's game. Maybe you'll deliver some message which make girls be more brave entering the IT space.
Right. Thank you. And this topic that I'm talking about is a little bit about personalities in this IT space.
Oh, that's interesting. That's exciting. I'm sure that this will be one of the most exciting things to listen today.
Yes, perhaps. No, I'm not sure about that, but I do want to encourage everyone who is watching today to listen to all the voices that they're hearing around them, not just a subset of the voices, because the more people we have working on solving problems, the better.
That's for sure. If I may also help you to share your presentation as well, Shelley, help me. The only thing that I need to see it as well on the platform so I could share it with the audience as well. Mm-hmm. But this is really exciting, as I told you, like this is something similar which I'm right now observing, because I'm really in blockchain space right now. So I can see that right now throughout the years, like since 2017 right now till 2020, more and more women, and I'm really excited all the time with the developers. So thank you so much. The floor is yours. We'll see you soon. Please, as I mentioned to you previously, dear attendees, prepare your questions for Shelley and Kamila in approximately 40 minutes. We'll be back, and you'll have a question. You will have a chance to have interesting Q&A. Thank you.
Excellent. Well, thank you very much. And yeah, we'll just dive right into the presentation today called Dismantling Technical Debt and Hubris. And we are talking about case studies and pulling from our experience. And to be sure, I've been in software industry for a few decades and have seen a lot of things, and I've seen patterns, and we're going to talk a little bit about those patterns and how we can manage our work better. So technical debt and hubris, what am I talking about when I say that? Technical debt is really a situation you can get into when you want to move quickly and you make a choice to do something that is fast, but maybe not the best solution. And over time, that can accumulate and potentially cause problems. But it is a choice, and it's not good or bad in each choice you make. But it should be known. And hubris is really the notion of when people or you have maybe too much technical ego, and you think that your solution or your way might be best without hearing all of the other people around you. So how are we going to approach this in general? The method behind the madness. Essentially, we have to say, I like to break the work out into 4 activities. Whenever I think about working on a project or a large piece of planning, I think about 4 different modes of working: a maintenance mode, a development transformation mode, an innovation mode, and then for me, especially working at a large open source project, an open source readiness mode. But this could apply even if you weren't working in open source. And then, of course, you have to have a way to measure your success or measure how you're doing. So we'll talk about that today. And first, to think about your work and the work that I'm drawing from as this case study, there's a lot of noise that comes in. So we are talking about requests from others, from other teams, from perhaps your the people you report to, the customers that pay you. A lot of different requests come in, and a lot of them often conflict with each other. So at first, it all sounds like noise, and it's hard to necessarily know what to do there. If you've got 2 requests and they're both conflicting with each other, how do you handle that? How do you make sense of this noise? But before I dive into the approach, I want to just take a quick look at some of the context that I'm coming out of and some of the statistics I'm coming out of. At the open source project that I work at and help lead, we have over 250 million downloads to date. We have a rapidly growing install base. We run around 93 million tests per release that need to be triaged. So it's a massive scale project. And we are trying to always keep up and grow and transform, but we also have to keep up with the release schedule that we have, which is a fairly rapid cadence. And I'll say for us, based on some numbers that were marked back in March of 2020, we are in a 2nd place position in terms of the number of things we release, and our fellow vendors doing a similar or same type of work. We're positioned in number 2 as of March 2020, and for Java 8 or JDK 8, that's now doubled as of November 2020, and for JDK 11, that our position is essentially multiplied by a factor of 8. So we are seeing that rapid growth. Let's talk about then, well, geez, if you're running that quickly and you're having to produce and keep along your release cadence, but you also are making choices along the way, making choices where you have to go quickly and you know you better get back to something because you did something in a quick way, but not necessarily the way you wanted in the first place, then you have to make sense of the noise. And these are the 4 modes I was talking about. So the maintenance mode in my example is actually that we run a lot of legacy tests for Java, and Java is over 25 years old now. So some of these tests date back a long way, although they are still valid and they still find issues when we run them against a JDK. So we don't want to throw them away, but it does mean we either have to keep them running or modernize them. So this is a maintenance activity. We have to be fixing defects. We have to be maintaining and improving tests, simplifying things. And when we can, assessing and culling, getting rid of tests if we are able to, if we have measured that we can. In terms of the new tests that we're adding and the new features coming into Java, every release there's something new. That means that we are picking up new tests, we're writing new tests, and that development transformation mode is looking at how we transform what we do so we improve what we do, how we work. So under this category, some of the activities would be, looking at how to reduce a defect escape rate, using change-based testing so that we're looking at what changed and being more clever in terms of what we test. And of course, that keeping up with new features. Every few months, we have a new release that we have to make sure we're current with. So tests do have to evolve alongside the product they're testing. Innovation mode is, of course, one of the more fun modes to be working in. It's the new ways of testing, then taking new tech, taking new approaches to how we do things. So whether that's a combinatorial test design approach to assess and model the testing and reduce the number of tests while increasing the functional coverage, or whether we are doing defect injection or applying some form of machine learning. This is a lot of working with, collaborating with, reading, research, taking that learning and applying it in prototypes and then bringing it into the production of what we do. And finally, the open source readiness mode, just the notion of being open and transparent, the notion of trying to use more open source tools so we leverage what is available to us from the open source community. And I'll talk a little bit about this in more detail later, but there are benefits to doing this even if you aren't working at an open source project, because maintaining your own set of proprietary tools is not necessarily the right thing to do. And it can drag you down and mean you'll have less time for some of the fun stuff that you maybe want to do in your project. The other thing I'd like to say about this for us is the open and transparent piece is putting what we were doing in the spotlight. So whereas our tests in the past have been run behind closed doors, they haven't been open sourced, they haven't been first-class citizens that could be inspected and looked at by the world, preparing for bringing them into the open and making sure they weren't absolute terrible, crappy tests was a lot of effort. and that's still a work in progress in some cases when we're looking at some of the legacy tests from a few decades ago. And so just as a note, what that work involves for us is when we look at the legacy tests, it turns out that everyone in the world wants to write their own test framework, even though a lot of the test frameworks share common set of features and maybe they could have been collapsed into a smaller set, or we could have all converged on one framework. That's not what happened, and for a number of reasons, that would not be what happened. In some cases, tests predate a modern test framework, so they were built upon handmade proprietary test frameworks. In other cases, people decided that one framework didn't have the features that they wanted or was missing one feature, and rather than contribute to the test framework that was missing the one feature, they decided to write an entire framework for themselves. So there were various reasons why we are in this position now of having to manage all of these test frameworks, the TestNG, command line tester, JTReg, STF, JUnit, SBT. And for perf, don't get me started, each one has kind of their own way of running tests and then producing output. And of course, the Java test for the compliance suite. And each one of those means that you have to learn a new command line set. And when we wanted to change how we worked, we wanted to be able to automate all of these in the same way. We had to approach it slightly differently. But the problem here, and as I've mentioned, with too many frameworks, is it makes automation far more complex than you'd want it to be. In terms of wanting to auto-exclude or re-include, you have to write your automation to handle all of those different cases. Reporting is all different, so there's no common way to report. If you wanted to create auto triage tools, then you're looking at a lot of complex code. Not to mention that when you want to teach a new person who's coming onto the team, oh, by the way, you have to learn 20 different frameworks and their command line sets and how to use each one. That learning curve is painful and very annoying. Plus, then each one of those frameworks hopefully has documentation, although if they are in-house proprietary frameworks, often they do not. So teaching and learning and onboarding is very difficult. So we decided we would consolidate these frameworks, and we would create a thin layer, or I like to call it a veneer, called TestKit Gen, so that it would handle the differences between all of the frameworks, and my new command lines that I could use were much, much simpler. So you can see that instead of the previous long sentence of things that I'd have to put, it's been simplified down to one single make target. When we are also looking at this, we said, if we want to handle this, that TestKit Gen piece is our layer 1, and it's going to be quite feature rich, because that way anyone could run tests on their laptop directly. They wouldn't have to have any extra pieces installed. They wouldn't have to have a CI system installed just to be able to run tests. And in my experience, we were in a situation where we were kind of pinned to a particular proprietary CI system at one point, and it took about 1.5 years to kind of disentangle us from that. And having learned that lesson, having been cast into that story, I don't want to return to that. And this is why now we break our automation out into these 3 layers. And on the very top of that layer, and I will briefly talk about it, we've added something called a results summary service, or a way to have different services that could monitor multiple CI servers. So again, allowing what we were doing to be more portable across different things. So the message that I'm trying to say from this slide isn't you're going to go and pick up a lot of our tools. The message here was thinking about, in terms of automation and what you're doing, where you want the features to be, what you need users of your application to be able to do, and how that workflow looks. So the maintenance mode then, and I like this quote from the How Google Test Software book, stuff was always broken, the code was broken, the tests were broken, and the team was broken. I knew what it meant to be buried under quality and technical debt, where every innovative idea was squashed, lest it risk breaking the fragile product it depended on. This is a terrible thing. If you get to the situation where your team or your project has made so many quick choices, shortcuts, decisions that were hacks, that you get to the point you can no longer move, because if you change one thing, everything falls over. That's the horrible story of when you let technical debt accumulate. And working in this mode, especially if you've gotten to that point, is demotivating. It's absolutely a killer. And that's why it has to be worked into your plan to say that it has to be worked into your plan to say, we're going to do a little bit of this each iteration, so that it never accumulates to the point where you can't move. And you want to minimize your effort in this area. So there's a lot of assessment, removal, fixing of defects, but you're taking it in little bites with each iteration rather than waiting until you get to the point where you're broken and then having to recover from that. All right, the development transformation mode. The quote I think about in this mode is, the secret of change is to focus all of your energy not on fighting the old, but on building the new. So maintenance mode was fighting the old. We spend a tiny bit of time there each iteration so we don't drown. But a lot of our effort and focus is on how we do things better. So thinking about, if you're planning your iteration, 10% of the work items maybe are maintenance mode, but a whole lot more are in this development transformation mode. And under this category for us, this might be looking at how do we reduce, before tests are even written, how do we reduce the number of frameworks we require, reducing after an existing pool of tests. So once we have our tests, how do we reduce the number of tests we run as PR build by looking at what changed? These are the kind of things, looking at your system and thinking about ways it can be refined. And the important part of this mode in whatever you're doing in your projects would be, how do you remove friction? When you look at the tasks that everyone has to do, what tasks take the most work, are most frustrating, have the most barriers, and how can you change that so that things take less time per change and they're less error prone. And finally, this could also be addressing some long-standing legacy problems. So when you are assessing what you want to transform, you're often looking at the old stuff and saying, this is killing us. And this is killing the most set of people in the project, so it takes priority. Innovation mode. This is, of course, one of the most fun modes to be in. This is where you get to think of brand new ways and prototype things for trying out. And innovation really is creativity with a job to do. So it should be focused, again, on the things that you have to accomplish, rather than, oh, I'm going to go over here and solve a completely unrelated problem. But it can still be very playful and ideally is very playful, with no strong commitment that you must be successful here. You'll the approach we've taken in this space is prototype something quickly, see if it's at all solving the problem, and failing early or quitting early if it's not the path, if it doesn't appear to be what we want. So in this case, that innovation mode, we've developed that thin veneer that I talked about to make things look and feel the same. We are doing continuous refinement, and we've developed that top layer of our automation cake called the test results summary service, which allows us to have visualizations of that massive set of 93 million tests that are running. How do you quickly look at them and cope with that much test data? All right, and finally, the open source readiness mode. This is for us in an open source community, how we create community involvement around our quality assurance project. And it's one of the best things you can do for a project. And this is a nice quote from the Building Open Source QA Communities of Beautiful Testing. And I'll share the references after the talk. But essentially, creating a core set of people that are working on the QA piece, and then building that out to growing the community and getting more and more ideas from a broader and more diverse set of people means that we will be better. This is for sure the observation that I take away from how we have worked. This is also, as part of this mode, the choice to use open source tools to avoid proprietary in-house tools, and looking at test code as public ready. So it's a first-class citizen right alongside product code. We should be thinking about this in the same way, with the same rigor and the same design processes as we do a product code. Now, I said we would talk about how we measure success. Well, there's lots of success metrics you can use. I've listed a few of them here, and we can kind of talk a little bit about some of them in each of the modes. So I'm hoping this will give you an understanding of, well, if you're thinking about having a maintenance mode, or thinking about looking at the legacy stuff of your project, how do you measure if you're improving your project when you're working in this mode and trying to accomplish things in this mode of activity? So it might be that you're able to reduce the size of a test defect queue. You look at the number of frameworks you're trying to manage. Could you reduce those? And so we can go through each of that. And I actually am going to encourage you to think about each one of these metrics, or take one out of them. Which direction is best for these metrics? So if I say in development transformation mode, the number of defect escapes. So this is how many defects went out into the field to our consumers and customers. Should that metric be going up or down? And I'll leave it to you to guess at that. So obviously, in that case, it should be going down. Same for, let's look at innovation. Can we come up with ways to reduce the number of intermittent defects? So in Java, as we know, we've got just-in-time compilers. We've got a lot of very sophisticated code in a JDK that when we go to test it, we find that, oh, sometimes there are test failures, but they only happen intermittently. Can we come up with ways to increase the reproducibility of a defect so that it can be found and fixed? So I encourage you to think about that for each of the tasks that you do. How do I measure what is the right thing to do and the right thing to measure? Am I going in the right direction here? And then I think for open source readiness, as we are trying to build a community, increasing the number of different contributors to our project is definitely one of the goals we're focused on. Not the only one, of course, but All right, so I won't spend too long here, but I do want to say that the maintenance mode success metrics, as I talked about, that could be reducing the size of the defect queue. It could be reduce, how many steps are required to do a common task. If I want to exclude a test, can I do it quickly and easily with one step? And I will tell a little bit of a war story here. In a proprietary system I had been working in, at one point it had gotten so convoluted, and this is kind of what prompted us to pull ourselves out of this proprietary system altogether. But it took, you had to have 5 different projects checked out and touch 8 different files in order to be able to exclude a test out of the automation system. So that is onerous and not something that's easily taught to someone else, and certainly error prone. So these are things that you could look at as you're trying to assess and fix your situation. And then the number of frameworks to manage. So in my case, we had a scenario where every different developer adding a new feature also decided to add a new framework, all loosely based on JUnit, but with their own different behaviors, and none of the 20 different frameworks behaved exactly the same. So we spent a period of several months taking back the night, if you will, on this one, and saying, okay, 20 frameworks is too ridiculous to be a thing. We are going to try to collapse that down to 5. That was our interim approach. We can't go from 20 to 1. It's a little bit too painful, but we could get from 20 to 5. And that was a good first giant step for us to be able to take ourselves out of that paralysis where everything was broken, or we felt broken and it was too painful to even work in this scenario. And we got to the place where we had less things to maintain, and we got to the place where there were a few less proprietary solutions in our story. And then that could take us further into using open source tools. But it couldn't all be accomplished in one step. And I said, there's no time for war stories. I've loosely touched on a few, but I'll also say you can ask me later, and if you want to hear me swear, or I'll try to bleep myself, then we'll go there. All right, so development transformation success metrics. These are, as I've already mentioned, the number of defect escapes, and I want to talk a little bit about that, of how we look at that. Maybe the speed and ease to add and execute tests. But here, essentially, when I say defect escape and escape analysis, I'm talking about it in terms of defects that could be found during development. I'm talking about assessing when a consumer or someone actually reports something. You can then go back and do an analysis to say, hey, when should we have found this? When was our first chance to have found this? If it could have been found in a code review, if it could have been found only as part of a performance test, if it could have been, it really could have only been found at a customer site because they have a very special setup. And then when was something found? So whether that was found as part of a system level test or during the development phase, and what type was it? So this is also very interesting because it talks perhaps a little bit about the urgency, but then you can start to see patterns and think about your innovation mode. So was the problem type that was reported a crash? Was it just merely a functional issue? Was it a hang? All of these things you can take and measure, and then make a plan for how you improve your system and your world. And then the other example to say of how we are transforming is when we look at that test kit gen layer, that veneer that we created to make things look and feel the same. In that space, what we did was standardize output. So if each different framework was producing a different type of output, we forced all frameworks, or we took all of that output and shoved it into a very simple test anywhere protocol output so that we had a standard output that could be used by automation. And we have ways now of reproducing and rerunning failures. We have ways that we are able to capture where all the test material came from. So in this piece that we were trying to transform what we did, we ended up bringing a lot of interesting innovation as well, because as we took each step forward, we saw new ways of improving our world. And I won't stop for a demo at the moment. I want to make sure I make it in time. If we have time at the end, I can. The innovation success metrics now, these really, as we want to look at, if I'm doing a prototype to try to see if a certain approach might help us. So we've done a lot of interesting experiments with machine learning and deep learning. Each one of those prototypes should have one or more goals. Ideally, not too many goals that you're trying to boil the ocean, but a set of goals that you can measure. So as we were working on a project called DeepSmith, where we want to have a deep learning model that can write some fuzz testing for us. Obviously, in that case, what we are looking at is how do we verify a compiler, a just-in-time compiler? How do we actually find defects in a compiler by generating fuzzers? And if we are able to successfully generate fuzzers, can we either reduce the number of intermittent defects or make them more findable? So these are things that we've done. And I think for the deep learning piece as well, we have another one where we're looking at how do we auto triage? Can we train a model to look at test results and decide what was the issue, the core issue, or at least what category was it in? So can we reduce our triage time with some of these prototypes? So it's important to note, because if I work on this project and it doesn't help reduce the triage time, then really that should get parked and we should be moving on to something else. All right, so just a quick look at that last one, the deep aquatic. That was essentially taking information and continuously improving the model so that we could see if our way of approaching auto triage can be improved. We're actually in the middle of this, and we'll continue to work on it for the next few months to see if it's going to be something we proceed with. Undecided yet, but an important thing for us to try. It also gives the team hope that there are ways to improve. And okay, finally, the open source readiness success metrics. This could be how many contributors, active contributors you have, the number of forks and clones, number of issues reported by external parties. This is a good one because that means people are using your stuff, but also caring enough that they want to report an issue. So as much as that might be stressful that new issues are coming in, it's a sign that people are trying to use your stuff and care enough to let you know that something could be improved or they're encountering difficulties. And then, of course, in this also, the speed and ease of adding tests keeps coming up as a theme as a metric in each of our success or in each of our modes. And the reason that's so important is if it's easy to add tests, if it's easy to test, more people will test. And I'll say finally, the summary or at the end of all of this, what I will say, the tips for success, if you're thinking about how you work in your own projects on your own stories, is that you have to be proactive and reduce technical debt continuously. Otherwise, you're going to be suffering a lot. You're going to get to the point where it's accumulated and you have a restriction of movement where you aren't able to change anything because everything's so fragile. So actively putting this into your iteration plans, actively picking up and working on a piece each iteration to reduce the debt, that's a very key part of being successful in a project. I will say also other tips for success. There are always going to be people who are naysayers, I'll call them that. People who, before you even try or get a prototype built, will start telling you, no, that's not going to work. That's not going to work. And you should probably ignore them, at least unless they're deeply trusted by you. There's nothing that will hurt to try a brief trial or prototype. That some piece of working code is much more informative than someone giving you their opinion on what may or may not work. Even if it's an experienced person who may have themselves tried it, there are lessons for new people to learn from trying things, getting their hands dirty, trying things themselves. Obviously, don't sink thousands of hours of time into it, but learn by doing and not by hearing that something isn't possible, so you're not even going to try stuff. And making sense of the noise, that is when people are asking you for 40 different things. How do you prioritize which one to do next? You're going to use a little bit of your own judgment. You're going to use a little bit of a project has a set of criteria by which they prioritize things. For example, we might prioritize things based on our stakeholders and their feedback over something else. We might put anything that's related to security up at the very top of the priority list, and all other things would fall below that. So everyone has to look at that set of criteria for your own project and decide how you make sense of the noise and prioritize your work. And so the recognize the egos in the room, that tip for success is really saying there are going to be people in every project that you work with that are pretty sure that their solution is the only way. They're pretty sure that they need to write their own test framework. They need to create something brand new, even though there's 4 other things that do exactly the same thing. You may or may not be in a position in your project to push back against that. I will say metrics and facts and gathering data are your friend here. It is hard to argue against a set of numbers and metrics that you have that show there could be a better way, or this other thing isn't doing the thing that you think it should be. And then measure and adjust. The notion isn't that you solve your problem and that's it and you walk away. QA and test verification, software verification needs to remain active and vibrant. You can't let it go stale. Just as product code is always evolving, so should a QA program. And finally, I guess this is a very general statement, but remember your mission. Sometimes with all of the noise swirling around you and people giving you inputs, you may lose sight of what you're trying to accomplish. have a mission statement for your work, and revisit it as you are going through your week, through your iterations, through your planning, to make sure, hey, this thing that we're doing, this one item in our iteration this week, where does that fit in our overall goals? Or is this something completely different? And make sure you're assessing that as you plan. And I'm going to say, in my head, the phrase I use is stop the stupid. So it doesn't mean, I think what it really just means is use common sense. And when you see something that doesn't make sense, speak up to it and see if you can redirect into something that makes more sense. And this is an ongoing process for everyone, I'm sure, but those are my pieces of advice.
Thank you so much once again, Shelley Lambert. And today, actually, you have a chance to ask her questions. Moreover, as I mentioned previously, right now we're going to have like only women's panel discussion. So I can already see some questions which you addressed, Kamila. Please, very short request. Please type in to whom exactly are you addressing your questions, to Shelley or to Kamila or to both. Moreover, I just really want quickly, while Kamila will be joining us shortly, I hope that she hears me and she will join us very soon. Meanwhile, our dear attendees, as I mentioned to you previously, you have right now the chance as well to win tickets, not only for your best question, but also for your feedback. One of the most exciting feedbacks, which we'll see on Twitter using tag geekle.us on our account Geekle Official, you'll have a chance actually to. You may give feedback about speaker, about the topic, about the event in general. And for this, we'll choose 5 winners who will get 3 tickets, I think, each. So we will, in that case, we'll be talking about 15 tickets only for feedback. Within the questions, we'll decide how much. Okay, so can I again check, Kamila, can you hear us and can you join us right now? So can I, for example, Kamila, are you here? Oh, hi. How are you?
Hi.
How are you doing?
I'm fine. Hi. I'm
It's
fine.
really-
And you?
Thank you so much. I'm doing great. As I mentioned this previously, I'm really enjoying to have this women's company in IT world. Like in my case, I'm right now mostly working in the blockchain space, but again, coming back to IT events, for me, it's really exciting. And again, seeing more and more women for me is actually really exciting as well. So additional question, Kamila, while you were presenting, there were questions for you. So I'll redirect them right now. So which is the better idea, to override equals method to compare whole object, or write in multiple assert equals?
I think it's better to override. Let me see. Override equals method instead of compare writing multiple assert equals.
Mm-hmm. Thank you so much. Once again, right now, again, question to Shelley. What is the short definition for technical debt?
Yeah, I think the short definition for technical debt is the place you arrive at based on the choices you make. So if
is it always bad? I mean, does it have all the time bad connotation, or can it be?
No, that's the interesting thing is I personally don't think it is always bad. Because if you want to move quickly, and you're you're trying to be agile, you will make choices, and sometimes those choices mean that you should come back and fix them later. So that's the debt. You're saying, I'm going to take a little bit out of my account here and to move forward quickly, and that the cost is that I'm going to have to go back and fix something or improve it. So it's a good way to get faster ahead, especially if you're trying to race to get something out there to the market or to the world. But it shouldn't ever be forgotten, because it's still debt. That wasn't a short one answer, though. Sorry.
Nevertheless, it's still not a problem. You can actually dwell upon it. And Kamila, if you want to add something, because I can see that you're nodding, you may add something, for example. Because as I said, I'm asking right now our audience address. Maybe you have specific questions addressed to some of our specific speaker like Shelley or directly to Kamila, but you may address some of the questions to both of them, I'm sure. So Kamila, did you want to add here something? I'm just asking, maybe because you were nodding, or is it like, or you just agree with Shelley? Does it mean?
I agree.
I see. So, ladies, actually, very quickly, we'll be coming back to technical questions. But honestly, again, what this is mostly philosophical, and actually partially also based on Shelley's presentation, which is not to have a look at somebody's, so to speak, criticism, and all the time just moving forward and just see what you want to see in your work, in like kind of to reach your at the end goal, to reach your mission. Can you tell us, and maybe in this case you would also again inspire other ladies to enter this IT space, what challenges did you have to overcome at your age, at your beginning stage, let's call it like this, that you can right now share it with others, so it will be for them easier to get used to, like, and to be really successful developers, to become really successful developers?
I'm going to let Kamila answer that one first.
Okay. Never give up, and study a lot, and participate from some meetups and community for women in tech, and make friends in women technology, and participate from some conference and meet other women tech like me, like Shelley.
Oh, that's for sure.
It's my advice.
I really support you, Kamila. Just really quickly, Shelley, I'll just add, because we have women on tech community as well here in Ukraine, and as well I'm a part of it, and I'm really proud of it. And also I'm a part of blockchain ladies community. It's more on the blockchain side. So tell us again more about the communities which you are attending, because honestly, for me, this is the visiting different meetups, events, conferences. It's really what really helped me to get to know about the topic I was interested in.
Yeah. You want to go, Kamila?
Yeah.
Camilla or Shelley, it's up to you.
I'm going to say that I do attend some conferences. I do. I often try to join. I try to keep an active learning plan for myself, so I will attend people's workshops or things like that. So those are, for me, nice ways, because in a conference setting, that's a lot of people all at once. It's not necessarily my preferred way of getting to know people. I like the chance to work with people. And then once I do work with people, I stay in touch with them. So I have a group called the Poorly Organized Coffee Club of all previous women software developers I've ever worked with. And now we meet virtually because we're spread across Canada and the world. But I do like to connect with them every few months. Yeah.
So is it based in the UK, or is it somewhere else, or is it virtual in this case? So you're just joining like in front of the computers with a cup of coffee?
Nowadays just in front of the computer. But in the past, a lot of us are based in Canada, in Ottawa, Canada. So we might try to find a new place to buy a sandwich or something and go for lunch. So those are things that I like to do. And the interesting thing there is it's not with a specific agenda. I actually find it uncomfortable to go to things where there's okay, we're going to talk about women in tech. Because really it shouldn't need to be called out specifically. It is, we are working in tech, and what are you working on, and what challenges are you facing? It doesn't, I'm interested in what all of my former colleagues are working on, whether they're men or women. But this is a fun group because we talk we have a similar style of speaking and listening.
Awesome. Kamila, did you want to add something right now?
I am part of 2 groups at Women Tech that call it Womenmakers Code, that all technologies and data science, UX, UI, and other things. And there's Java girls that are mainly for Java developers and women's Java developers.
Nice.
Thank you. Actually, let's go back really quickly again to technical questions. And again, for your technical questions, dear audience, you'll get the chance to win the ticket to one of our future events. One of them, I'll tell you about more details very soon, very shortly. But before that, is the onion architecture an application of the concepts of clean architecture? This is the question, if I'm not mistaken, to Kamila.
Yes. I haven't worked with an architecture yet, but I think they are very similar. There are only some difference of the way of separation of responsibilities, but I think Onion architecture is near to hexagonal architecture, but I don't know in depth what the difference. But I think it's more simple than clean architecture.
Thank you so much. Quick question, maybe not only quick, to Shelley. Please, can you dwell upon on the adoptium? And do I pronounce it correctly? Maybe it should be pronounced.
Yeah, no, you're pronouncing it correctly. Yeah, we recently announced our working group. So our project was called Adopt OpenJDK, and because we grew so quickly, we are now moving into the Eclipse Foundation and being renamed Eclipse Adoptium. So keeping the word adopt in the front, because that really is kind of what we're trying to do, is have more people adopt our stuff and more people kind of adopting OpenJDK and Java.
Oh, I see. That's interesting.
Yeah.
Moreover, there was also mentioning about AHOY.
Yes.
Also, please share with us.
Aquavit.
Yeah.
So
I was interested whether it's
the Adoptium Quality Assurance project. So we have a set of testing repos under that project, and the VIT is for vitality. So Aqua being the quality assurance program, and VIT being keep it vital. So making sure that what we're doing always stays fresh, and that's why those modes of how we work is so important, because we can't just turn the crank and keep things running and be in maintenance mode. We have to innovate. We have to transform, and hopefully we can have other people adopt what we're doing, so that when they're thinking about quality assurance for their Java programs and applications, they're also having an example to follow.
Thank you. A quick question, right? Maybe not quick as well, to Kamila from our Emmy. So what is the difference between entire architecture and 3-tier architecture?
I think 3-tier architecture, we just use the 3 layers, if I'm not forgot the model view and controller. And then tier architecture, I think, is infinite layers, something like clean architecture or hexagonal architecture. I'm not sure of this.
Dear audience, if you have additional questions, please write them down. But we are running out of time. Maybe just additional one question. But actually, you made actually really valid points today when we were talking about every job which we're doing has to be vital. It has to be like we should like it. Just quick question at the end. Can you say that right now you're working on your dream project, or do you have something under your sleeve which you can share or not in the future?
Do I get to answer that one? I very much, I very much love what I'm doing. There are days that are hard where things fall over and everything's challenging. But yes, I get to do a lot of interesting things and collaborate with a lot of wonderful people, very smart people, and I very much enjoy what I'm doing. So it is a pretty good dream job, and we do have some collaborations coming up in this next year that are going to be super exciting.
Oh, we should definitely follow the news. So please subscribe to Shelley's account.
There you go.
You've shared, if I'm not mistaken, all the context and at the end of your presentation. Yes.
Yeah.
Sure. Okay, Kamila.
I'm working with very cool projects actually, and I'm working with Clean Architecture also. But outside of the company universe, I make some contributions for the community, especially about Webflux and Reactive programming. And if someone has to add me on social media, they are on my presentation also, and I can put on the chat later.
Definitely. Additional questions we right now have from Poland. How often should code review be performed in the team to keep the code clean? With regards from Gal.
I think in all pull requests is a good practice, or in a pair programming if you made pair programming, or in other times. But actually, I make in each pull request and make for my pull request also. And in the end of some sprints that we work with the agile methodologies, and after it's unit test or refactoring, we make code review.
Thank you. Thank you so much. If we don't have any more questions, but I think we should run off because we should go ahead because very soon, and we'll proceed how ladies audience here, because I'm going to have next moderator as well, a lady, and she'll proceed with her speakers. For the time of being, I really want to say thank you to Kamila, Shelley. That was really exciting, and as I said before, it's really inspiring for other ladies, maybe young ladies who may be watching us right now, or maybe they will find you on social media and they may follow you and find out about how like you're becoming and become such talented and also experienced developers who are working on their famous and they are like really the projects which they're really enjoying. So thank you so much for your presentations. I hopefully see you soon at our next events. For the time being, I want to say thank you, and again definitely have a nice evening, have a nice night, day, whatever is the time at your place right now. Thank you so much.
Thanks very much, Maria.
Thank you so much. And just very quickly, before I'll give the floor to my colleague, Sarah, who will be joining us really shortly, I just want to say thank you again for watching us. Please stay tuned, as they say, because we still have lots of presentations ahead. But also, I just wanted, before that we'll go forward, don't forget to go on Twitter. Don't forget to leave your comments there, but also tag Geekle.us, and also you'll have a chance to win one of 15 tickets. As you remember, there will be 5 winners. They will get 3 tickets each. So in that case, it will be 15 tickets as far as I understand. But also, of course, there's a chance for you if you prepared best questions for our speakers who were, and for future speakers, you may have a chance to win a free ticket to our future event, which is going to be QA Global Summit 2021 in just a week's time. I believe that this is like, for me, it's really, for you, it will be really exciting because the topics are really interesting. The speakers just amazing. And moreover, you'll find out how to build a QA process from scratch. You'll find out how to achieve an ultimate balance between automated and manual testing. You also get a chance to find out what AI can offer to elevate your testing productivity. And only for 2 days, for our Java community, only 2 days, we offer special flash price for our events. So in that case, probably it won't be only QA. So the price of for the QA Summit from $259 drops to $99, and the number of tickets is limited to only 20. So 20 tickets will be sold at $99. So again, please check it. Definitely explore this opportunity if you want to. And of course, As also, stay tuned for more flash price announcement for React, Angular, Vue.js, Python, and cybersecurity summits. Thank you so much again for joining us today. I'm Maria Vovchok. I'll be joining you tomorrow, moderator at Geekle.us. I'm giving the floor right now to my colleague, Sarah. She'll be joining us. She'll be joining you really shortly. Right now, have a nice day. Thanks for watching and see you soon. Bye-bye.
Okay, hi everyone. I'm Zahra Darvishian, one of your today's moderator, and welcome to Global Summit for Java Devs 21. Okay, hope you enjoyed till now. And we have one of our speakers here, Mr. Deepuke Sasidharan. So let's have uh, let's have him here right now.
Hey everyone.
Hey
I hope
Deepu.
my audio is good.
Yeah, that's perfect. Thank you a lot. Let me introduce you to our audience. Actually, Mr. Deepu Sasidharan is a software designer by passion and profession, and he's also the co-lead of Java Hipster. And he's a polyglot programmer working with Java, JavaScript, Go, Rust, and so on. Yes, Deepu, am I right? Is any other
Yes.
languages you've been working with? You can add it here right now. Okay.
Yeah, whatever is thrown at me. I don't discriminate against languages.
Oh, and he's also okay. He's also a cloud technology advocate, and he's an open source software aficionado and a technology advocate by passion. And he has authored books on Java Hipster and writes frequently about Java, JavaScript, Go, Rust, cloud native, and so on. And today we have you here, and we're glad to see you here. And actually, Deepu has worked as a developer advocate on Adyen. Yes?
Yes.
Yes, great. So I'm so excited to hear today's speaking. And if anything needed, if you wanted to add anything on your biography or anything, I would be happy. In other case, I will leave here, and so you can start your speak. Thank you.
Hey. By the way, what about the presentation? Is it automatically? Okay. Yeah, that's good. Cool. Hey everyone. My name is Deepu Shashidharan, as I was introduced. Currently work for Adyen. We are a payment service provider, so do check it out. Check us out, and you can also check out my book if you are interested to learn more about full stack development or JHipster. Yeah, so let's get straight into the session, as we don't have a lot of time. I have to pack all this in 40 minutes. Istio. I don't know how many of you are familiar with Istio. So Istio is a service mesh for distributed application architectures, especially the ones that you would run on the cloud, especially with Kubernetes. So Istio was designed with Kubernetes in mind, from what I understand, and it plays so nice with Kubernetes that you might even think that it's part of Kubernetes. So it works that well with Kubernetes. So that's like a short introduction. So let's see what Istio can actually do. A lot. The important parts are service discovery. So it kind of can replace, Netflix Eureka console kind of services. It can do automatic load balancing. It can do routing, circuit breaking, retries, failover, fault injection. So these can replace, stuff like ribbon, historics, and so on. It can also do policy enforcement for access control. So you can do access control with that. You can do rate limiting, A/B testing, traffic splits, quota splits, and so on. Like you can do a lot with policy enforcements that Istio provides. It also automatically collects metrics, logs, and traces, and can stream that to your favorite metrics or metric aggregation service like Prometheus, Grafana, Zipkin, and stuff like that. It also provides out of the box secure service to service communication, so you can do MTLS with HTTP, HTTPS, gRPC, and so on. Let's quickly look into the Istio architecture as well. So Istio mainly has two more parts. So it's a data plane and the control plane. So the data plane is where your applications reside. So it is made up of Envoy proxies. So Envoy proxies are very high performance, lightweight proxy written in C++. And they are attached to each of your service as a sidecar. So the proxy lives in the same pod as your container, so that the proxy can actually control all incoming and outgoing traffic to your application that lives in the same pod. This is how Istio enables secure communication, telemetry, and all these stuff. The data plane also would contain the ingress controller and egress controller, so to handle incoming traffic and outgoing traffic. Then the brain of Istio is the control plane. This is where Istio's main moving parts like Pilot, which does service discovery, traffic management, resiliency, and Citadel that can do authentication, security, certificate management. Then there is Mixer that does policy checks and collects telemetry. They all live in the control plane. Then there is also Galley, which kind of manages configuration. So these are the main parts that lives in the control plane of Istio. So from the control plane, you can connect the collector telemetry to Grafana, Prometheus, Zipkin, Kiali, all these kind of Jaeger, all these kind of services. So that's a short introduction. By the way, just wanted to give a disclaimer. So this session is not a Istio workshop or a J Hipster workshop. This is more of a introductory session for you to discover how you can quickly build Istio applications on Kubernetes using J Hipster. So there's not going to be a lot of code explanations or stuff like that. This is mostly demos and just looking into what you can do out of the box. So let's go ahead and build this. You can also find this content in a blog format in this bit.ly link. So feel free to check that out if you want to follow along and if you want to try this out yourself. So before we start, we need certain prerequisites. So definitely you need a Kubernetes cluster. So I decided to go with GCP for that because I have free credits there thanks to Google for providing that. So I already created a project. I have enabled that project and linked that to my kubectl. I also have, I have created a cluster as well and linked that to my kubectl. So I have done all this step beforehand so that we can save some time, because otherwise this is going to take 10 minutes, which we don't have. So I already have this, so I'm going to show that. So I have kubectl get pods. So the JHipster namespace is not there yet, so it's empty. But I already have the cluster. For example, let's say nodes. So I already have the cluster ready. So let's go back to our presentation. Yeah, so I have the cluster ready there, and I have also installed Istio locally. So you can also install Istio locally if you're going to work with Istio, which means you can use Istio.ctl locally, as well as you can use the provided YAML files and manifests. I have also installed Istio to my GK cluster, which is extremely easy. Once you have Istio installed locally, you can just do Istio.ctl install and provide a profile, and it will install that to your kubectl cluster, whichever you have made the default. So once we have the cluster, there is one more important step, that is to get ingress gateway IP. So for example, here, let me kubectl get service. So we need to get the ingress gateway from the Istio system namespace. And this external IP is extremely important. So we'll come back to that later, but you need this. So we'll come back to that later, where it is needed. So let's just make a note of this IP. And I have also done a few additional steps. So I have also installed Grafana, Prometheus, Kiali, and Zipkin provided by Istio as add-on. So I have used the sample folder from the Istio installation. So if you have installed Istio, there will be a local folder for that version created in your home directory. So you can go into that folder and you'll find all these Kubernetes manifest under the add-ons folder. Some are in the extras folder like Zipkin here, so make a note of that. So I have installed all these as well. So we can see that here. So if I do a kubectl get pods Istio system, you can see that I have Grafana, I have Kiali, I have Prometheus, Zipkin, all that already installed here. So I have saved some time that with that. So let's get into, 1 second. Yeah, let's get into what we can do with Istio and Kubernetes. So this is kind of the architecture that we are trying to build today. There's going to be 4 microservices. One is going to act as our gateway. So that would be our gateway application, which will have the client side built in React. It will have user authentication and stuff like that. It will have some admin modules. It also has an envoy proxy attached to it. It will run on port 8080. Then we'll have 3 microservices running on port 81, 82, and 8083. So these are the product microservice, invoice service, and notification service. Again, they serve just REST endpoints, and all these services have their own databases attached to them. The gateway, product, and invoice has SQL databases. So in this particular case, we are using Postgres, and the notification microservice has MongoDB attached to it. So other than that, there is the ingress gateway, which routes all traffic to our microservices. And there is the Istio control plane, as we previously saw, that's going to gather all telemetry, and it's going to stream that telemetry to our monitoring, which is Grafana, Prometheus, Kiali, and Zipkin. So that's about the architecture. So now, how can we bootstrap this quickly, right? So of course, using JHipster. But before we go into that, for those of you who are not familiar with JHipster, maybe I'll take a minute to introduce JHipster. So it's quite popular on GitHub. It has a lot of installations, a lot of users and companies. So it's a quite healthy ecosystem that we have. So if you ask what you can do with JHipster, of course, you can fix your plumbing. It can order pizza for you. It can also, achieve world peace. Just kidding. But at some point, probably you'd go there. But yeah, realistically, you can create monolithic applications with JHipster. You can create complete microservice architectures like the one that we are going to do today. That's not just the architecture. You can also do different microservice architectures, with Console, for example, or Spring Cloud Gateway without Istio. A lot of other architectures are possible. Of course, you can create CRUD APIs with entity models. You can generate CI/CD pipelines. You can deploy to cloud or containers, and a lot more. So if I start going into the features of JHipster and what JHipster can do, that needs a separate session altogether. So you may ask, of course, a scaffolder, right? So the code quality is going to be bad. This is just going to be some repeated code that you generate. No, that's not the case. So, people who build JHipster, including myself, we are developers at HAD, and we built and we maintain these tools for our own use cases as well. So that means we really care about code quality and developer experience. So everything we do is developer experience oriented. We strive to provide as best code quality as possible. So that especially production grade code quality. So just look at our Sonar rating, and you'll see that we have much better Sonar rating than most other projects. So probably if you run Sonar rating on your own project, probably you'll fall behind what we provide out of the box in many cases. So best practices on any combination selector, that's our motto. If not, then that's a bug. Fully working CRUD applications out of the box. Again, when we provide an option, we want it to work out of the box. Production grade security using OAuth2 or JWT or Session, whichever you prefer. You only have to do business logic and UX design for your application. Everything else JHipster provides out of the box. And of course, JHipster supports a lot of technologies like different client sides, different server sides, different databases, cache providers, and so on. Whatever you can imagine, JHipster already supports that. So that's about introductions and stuff. So let's see how we are going to build this demo today. So for this demo, I'm going to use another feature of JHipster that's called JHipster Domain Language, or JDL for short. So you can find the JDL file that I'm going to use today in this specified link, bit.ly/istio JDL. So you can download the file and you can install JHipster and try it yourself. You can refer to JHipster JDL documentation in these links. We also provide Studio, where you can design your JDL visually, where you can see how the entities look and see how the entities look. You can see how the applications are structured and everything. So you can use the JDL Studio if you like to design, or you can use the VS Code plugin or Eclipse plugin that we provide as well. Okay. So just a quick note, I'm using JHipster v7.0 beta 1. We already released v7.0, the stable one, but there is a small bug that I found that makes it impossible to use reactive gateways to Istio, because in the latest version, we switched from Zul-based gateways to Spring Cloud reactive gateways. So there seems to be an issue that needs to be sorted out. So for the time being, I'm just going to stick to beta 1 version for this demo. But yeah, the issue should be fixed quite soon, so that with the next patch release, or it should be fixed with the next patch release. So let's look into the JDL itself. Where is it? Yeah. So for the JDL, there are a few parts. So it consists of an application declaration, and in this particular case, I have 4 applications declared. So we have our store, which is the gateway. It uses JWT authentication, Postgres database, Hazelcast, uses Gradle as build tool, and uses React as client-side framework. Then we have our microservices, which again, like a microservice application similar to this, JWT, Postgres, Hazelcast, Gradle, and everything. Note the different port. Here we are not providing port because 88 is a default port. And also here we are specifying that this application would use all entities. That is because this is the gateway. That means we need the client side to be generated in this application for all our microservices. So JHipster automatically knows that if it is a gateway, it will only do the client side and will skip the server side, because the server side will be generated by the microservice applications. So here we are specifying entities that belong to that particular service. Again, we have invoice, and the entities belong to that. Then we have notification service. Of course, it's going to be used MongoDB here. No cache, no Hibernate, different port, and its own entity. Then we have the entity declarations. So this is where we will declare JPA-ish, entities for our application. So basically, field name, field type, and validations for that particular field. You can also define enums as field types and define the enum right here. Once you have entities, you will define relationship for entities. So again, you can do one-to-one, one-to-many standard, JPA relationships. You can also have certain properties like, for example, if you want to enable service classes for entities, we can do that. We can enable pagination. So of course, you can refer to the JDL documentation in order to see all possible options available and all possible types and application options available. So I'm not going to go into the details of that. So we have entities defined for all our services here. And finally, after all the entities are defined, we also have a section which defines a deployment. So JDL is like a one-stop solution for your entire application architecture. So you can define your application, your entities, as well as your deployment, right? So for deployment, we are going to do a Kubernetes deployment for all our applications. And I'm going to use my personal Docker repository for that. We don't need service discovery because we are using Istio. So of course, we are using Istio here. And this is very important when you're using Istio, because Kubernetes service type has to be ingress for Istio to work. Otherwise, it's not going to work, because we need an ingress gateway. And of course, we are providing a custom namespace for the deployment and ingress domain. So this is where the IP that we saw here, the external IP, is required. So we need to provide the ingress domain that can map to this external IP so that we can route traffic. So since we are doing a demo, I'm going to use nip.io, which is a wildcard DNS service, which will redirect back to my local host. Which will redirect back to this particular IP. So I'm using the IP that we obtained from here, the external IP of our ingress Istio ingress gateway and using that as the ingress domain here. Of course, you can also do a local DNS mapping for that IP and use that, or if you have a domain name, you can map the IP to that and use that domain name. So that's up to you. In real cases, you'd be doing that using an actual domain and mapping the IP. So that's about the JDL part. So we saw these. Yeah. So it's finally time for us to go ahead and create our application. So let's begin. I want to be mindful of the time, so I want to go a bit quick here. So let's create. So there is nothing here, just the Istio file. The JDL file, as you can see. So I'm going to run jhipster JDL and give the path, and I'm going to fork. So to speed up using parallel creation. So we run this, and it's going to take a few minutes for everything to be created. In the meantime, we can already start looking at the code that is being created. We can quickly go through that. So this is the folder. So as you can see, it has already started creating applications. So we have the store application, all the Gradle files required. So everything, again, production grade setup. That means whatever you would actually want to do in production, it would be there. But of course, if you're just generating this and checking this out, you might think that there is a lot of code, a lot of boilerplate. But in an actual application, when you go to production, you probably would end up needing all this. That's why we have all that from the beginning. Webpack configuration for your client side, all the metadata files here, your build.gradle file here. And in SRC, you'll see, of course, tests. All tests are also generated for everything. Integration tests and unit tests for everything is already there. On the main folder, you'll see Docker-related stuff. So you'll find Docker files for everything that you would need to run this locally, like your database, monitoring setup, JHipster control setup, which is a very useful utility for microservices, etc. And especially also the application YAML for your app itself. You also have a web app, which is a React web app here. Not going to go into details of that. And of course, your Java folder with your configurations, your domain, repositories using Spring Data, security services for your entities, and of course the REST endpoints for your entities. So this is all generated. And as you can see, it is generated for the microservices. And in microservices, the only difference is that you don't see a web app folder. So everything else is going to be a bit more lighter, of course. And the Kubernetes part is still not done. So it is still doing the... so it has finished all the microservices, and it is now installing our store application. And it's going to create Kubernetes files for this. So since it has already built our microservices, what I'm going to do is I'm going to actually start the build to save some time. So I'm going to go into cd product, and I'm going to run Gradle build. I don't want to waste a lot of time because we don't have a lot of time. So I'm going to run Gradle w boot jar, and I'm going to use gib because we use gib to do Docker builds. So I'm going to also do a gib build for the service so that it is built and uploaded to my Docker repository. So this one command builds your application for production profile, as you can see here, and then uploads that, then builds a Docker file for that, and pushes that directly to the repository that you have configured, your Docker repo. So I'm going to push it to mine under product. I'm also going to push the other services. I need to go into the folder first. So cd invoice Gradle w. Very important to change to the right image path. Otherwise, we'll end up corrupting other images. So I'm also going to do the same for notification. Need to go into notification first. Notification. And I'm going to do notification. So these builds have started, and as you can see here, our execution have also completed. So that means it has created the Kubernetes stuff, and it also prints some useful commands for you to proceed further. For example, it prints what command you can run in order to do your builds. It prints how you can manually build the Docker images and upload. Or so this is if you want to build separately and push separately, and of course this is if you want to do everything in one step, like how I am doing. So up to you, you can use whatever you want. So once you're done, it also prints how to deploy to Kubernetes. We'll see that in a second. Of course, you can do the deployment either directly using just kubectl, or you can also do the deployment based on customize. So we also provide a customized setting right out of the box. So let these when these builds are happening, let's quickly look at what is generated for Kubernetes. Close this. Yeah. So okay, where is it? Yeah. So it has created certain folders. As you can see, there is one folder for each application. So there is a deployment spec, Kubernetes deployment spec for your application. There is a Istio destination rule for that. Of course, deployment spec and whatever secrets and stuff required for your database. The Kubernetes service description for the application, and Istio virtual service for the application, since we are going to use Istio. So this is how Istio makes sure that it can communicate with the application and stuff like that. So all your traffic is going to go through Istio. And of course, secrets and stuff that is required for the application. The same is repeated for every application. And for the store, since it is our gateway, it also has some additional files like destination rules and the gateway YAML. So the gateway YAML is how Istio knows how to route your application. So this is how it's going to do the routing based on URL path. So when it finds this in the URL path, it's going to route that to that particular application and so on. And the default application is going to be store. And yeah, everything else is quite similar. So this is the additional thing. The gateway YAML is additional thing, since this is our gateway. And of course, there is some patch files provided if you want to use that, and Istio specific configuration for Grafana, Kiali, and Zipkin. So since Hipster already provides this, it makes easier to connect our application to telemetry. So you're going to see that I'm not going to do anything special to connect our telemetry. I just installed telemetry as I showed you earlier in the in our Istio system namespace. All Grafana, Prometheus, and everything is already there. And I just created this, and I'm going to deploy this, and then everything should work out of the box automatically. So that is what a Hipster provides, all out of the box configurations. So that's about our. So all these builds are completed. I'm also going to do the store build now. This is the final one, and the store build is going to be the longest because it has the client-side stuff. Oh, sorry, CD store. So since it has the client-side stuff, this build is going to be quite a bit longer than this. This happened in 1 minute and 56 seconds, 2 minutes approximately for all these services, and this probably is going to take like 4 to 5 minutes because the front end takes. Yeah, these days the front end takes longer than the back end to build. So yeah, that's the full stack development world that we are in. So while this builds, I'm going to be mindful of the time. So we have 20 more minutes, I believe. Yes, we have 20 more minutes, I believe, and going to go through some slides again. So again, we saw that we built and pushing the images. So the next step would be to deploy this to our GKE cluster. So as I showed earlier, we already created a GKE cluster. So let's look into that directly here. So we have a GKE cluster, and you can see that it already has the Istio workloads already here, but our application stuff is not here. So once we do the kubectl apply from this, our application is going to get deployed. So we can do that in a second. Okay, let's quickly see if our build is completed. Nope, it's still running Webpack production build. Again, since it's a production build, it's going to take longer than a dev build because it's not going to do JavaScript minification, optimization, and all that good stuff, which actually you need in production. Though it takes a bit more time, you actually need those in production for better performance and faster loading. So, okay. In the meantime, probably we can also have a quick look at policies and stuff. So let's see here. So we have some policies here, like for example, we have some traffic policy defined in our destination rule. So this is where you could define, like load balancing. You can define your A/B testing stuff policies here, your what do you call, like rate limiting policies and stuff like that. So this is where you can do all that stuff with Istio. And even if you're not using Istio, and if you go with the default Hipster architecture, where say for example, if you do the same, where is it? So if you do the same application, and if you just disable Istio here, and instead provide a service discovery, for example, console, for example, if you provide console as a service discovery, for example, then Hipster is going to generate everything that works out of the box with console in mind, right? So it's going to do all that automatically for you. Let's see. Yes, our build is successful. So I'm going to go ahead and start our, I think we don't need these anymore. So I'm going to close these and just keep these. Okay, and I'm going to start my deployment here. So kubectl, I'm going to use the script provider. So as you can see here, Hipster provided a very handy script to start the deployments. Of course, you can also do the same stuff manually, but this is quite handy, especially for demos. It's quite nice. It also creates a namespace. It provides the customization of setup for you, using customize. It also provides a scaffold configuration to start with. So everything is already there. Okay, I need to go into the Kubernetes folder, Kubernetes, and run kubectl apply force. So it's going to, as you can see, it's creating the namespace. It is, I'm going to blow this up a little bit so that it is much more visible. It's created the secret and everything. It's creating destination rules, deployments, virtual services, again for every application. And finally, it's also uploading the Prometheus, Grafana, those kind of stuff. So it's all there, and it also prints useful endpoints for you to start accessing. But before that, let's see if our pods are up. So our pods are coming online. As you can see, some of the pods have already passed one of the readiness check. I think it is waiting for the liveliness check. So as soon as our store application passes both tests, we can start accessing. So let's click this already. And it's not there yet because the application hasn't started yet. So give it a few more seconds. So as you can see, our invoice application has already started. I'm quickly going to see if there are comments and stuff. Okay, not many. Thanks for all the highs. Hi, everyone. Sorry, it's quite hard to focus on both because I really don't have enough time to finish everything I want to. I even had to cut down a lot of my originally planned slides to fit in this time. But make sure to check out my blog that I mentioned here. So if you are joining in between, you can kind of let me go back here. You can go to this link and you will find the same content in a blog format, which you can easily follow along. So feel free to do that. So seems like our services are up. So I'm going to do a quick demo. So I'm going to refresh this page and see, voila, our gateway is up. So we can sign in using the default username, which is admin, and the default password is also admin. Of course, change these in production. That's how it's supposed to be. No. Yeah, Chrome is going to complain if you use admin as your password, of course. So we have all our entities here. So customer entity, which is in the gateway application. So nothing special here. But the product and product category comes from our product microservice. So let's quickly check if this works. Let's try to create something and see if it works. Yes, it has created the entity. That means the connections are working properly. You can view the entity, you can edit. So all the basic Hipster stuff. So Hipster provides solid CRUD for your entities. And let's also look at our invoice service. So shipment is from invoice. Yes, seems to be able to connect. If it cannot connect, you will see a error pop up here. And of course, notification, which is MongoDB. So if you create something here, it's going to have a UUID instead of a statically generated number ID like we saw there. So you can see UUID because it's a MongoDB entity, and this one has a UUID because it's a basic SQL based entity. Of course, JHipster also provides user management, metrics, extremely useful. It can also give you thread dumps and stuff like that, stack trace and stuff. JVM metrics, garbage collection metrics, HTTP metrics, specific endpoint performance metrics, cache, and database metrics. You also get health checks endpoints, which you can use for readiness check, liveness checks, and so on. You can also use this for policy enforcements and stuff if required. And configuration, which shows all the configuration that the current app is running with, and logs for this current app. Of course, this only shows all this stuff for the gateway application. If you want to see the same stuff for the microservices, then you can run Hipster control center. There is a Docker file provided already in the application here, for example. You already have a Docker file for Hipster control center. So you can run this, and it will automatically connect to all of your applications and provide similar screens for all of your applications. So this logs are also live. That means you can change log levels live, even in production if you want. And of course, basic account and setting screens. So let's look at more interesting stuff. For example, okay, I'm going to go to slide. Yes, we saw this. Telemetry. So let's look at all the telemetry stuff that is automatically being happening. So this is quite easy to do. You can use istio-ctl and use the dashboard command to invoke any of this, or you can also use any of this, IP that is, sorry, any of this URL that is printed here. For example, I'm going to do, okay, Grafana now. So it's going to load up the Grafana page for us. Yes, and let's look at dashboards. Home, manage, Istio. So let's look at our service dashboard, for example. So service dashboard is very interesting for us. Of course, there are many other dashboards, like, for example, you have, yeah. So you also have controls plane dashboard, mesh dashboard, performance dashboard, and other stuff. But what we are interested in is service dashboard for the moment. So here, data source is Prometheus. And let's say look at our store, and you can already see metrics collected from our store application. So there is request duration stuff, yeah, like client workload metrics and everything. So, excuse me. You can see that for other applications, for example, the database, it hasn't collected much for the database yet. Let's see, product. Okay, that's again the database. Yeah, product service. I can see you can metrics for that, and you can even see metrics for Grafana and stuff like that. So you can see all that metrics being gathered. Let's also look at Kiali, for example, or Zipkin. Yeah, let's look at Zipkin also. No, let's look at Kiali. So I'm going to use istio-ctl for this and run Kiali. So that's going to create a tunnel and open up Kiali for us. So as you can see, we can see our application graph here. So as you can already see, this is our application graph. Our store is already communicating with invoice, notification, product, and they are all communicating with their databases and stuff. So as you use your application more and more, Kiali would start forming more connections and everything. So it'll give you a representation of how your things are communicating. You can see applications here. You can see your workloads, services, and of course, Istio configuration, which you can also go in and edit and reload if you like. So that's Kiali. So let's look at Zipkin as well. Yeah, when there is a dash, the URL highlighting doesn't seem to work on my console. So with Zipkin, let's service name. Let's see product, for example, or store, and let's search. So it's going to give you all the traces that for the request that you have made. So if we go here, it shows you that we made a request that went through the Ingress gateway, then to the store application. Then from there, it went to the notification application. So this is quite useful for tracing issues and tracing failures and stuff. So all this is provided out of the box. So we saw the telemetry part. Yeah, so that's about the telemetry part. So now we have done installation. We have seen how the application works. We have seen how telemetry stuff works out of the box. So remember, all this is out of the box with Hipster and Istio. I have not done any customization. As you saw, I just created a JDL file. I generated the applications, and I just deployed it to Kubernetes. And out of the box, you are getting all this. So imagine the same when you are actually building a microservice architecture, because of course, this is not going to be a replacement for your development team, right? This is just going to help you get started. So you can do all this. So I did all this in less than 30 minutes, right? So imagine being able to do all this for your initial architecture in even if it takes a few days, right? You have a solid base to get started, and you only have to worry about UX design, business logic, and any special use cases that you have. Everything else is already there. So let's see if Istio is worth the hype. So of course, the advantages are that it is Kubernetes native, so it works much better with Kubernetes. It reduces the responsibility for developers. That means it takes care of service discovery, security, and all this stuff. So you don't have to maintain any code for these complex parts. That means you don't have to, integrate Eureka client for your application, or set up a Eureka config, Eureka server and config server and stuff like that. You don't have to set up Zul. You don't have to integrate Zul and write code for that and stuff like that. All that responsibility is taken away from you. So it means you can spend more time working on your business logic. You can go to market earlier and stuff like that. It also helps you with generally required things in our software development world, like A/B testing, canary releases, and a lot more. Of course, you can do some of these directly with Kubernetes, but with Istio, it becomes even more flexible and even much more nicer. Of course, there are a lot more small things that Istio provides. Those are advantages, like, of course, secure communication and stuff like that. But all these advantages are not without any disadvantages. So major disadvantages that I could see are Istio is still fairly new compared to other stable things like console or whatever you are used to. It uses slightly more resources because every container that you deploy needs to have Envoy proxy attached. You need to run the Istio specific services on your cluster. You probably need to run more stuff for your telemetry setup and all these things. So slightly more resource usage could also mean higher running cost in the long term, especially. And another disadvantages of relying on policies a lot is that business logic related policies might be trickier. For example, if you have a rate limiting that is heavily tied to your business logic, for example, you want to fetch few database, data from your database, and then do some complex business logic in order to determine rate limiting, then that could be trickier. It's possible, but it's going to be much more trickier to do with policies. So you might end up spending more time writing such policies. So these are the disadvantages that I could see. Of course, in the end, Istio just provides building blocks to build distributed microservices in a more Kubernetes native way, right? And it takes the complexity and responsibility of maintaining these moving parts and this microservice infrastructure away from your development team. This means you do not have to worry a lot about maintaining the code and can focus more on business logic, and because Istio is going to take care of service discovery, tracing, and all these things, right? I think we are going towards a future where all the code that you need to write is all becoming business logic and UX or whatever, those kind of code, whereas all those boilerplates and those kind of things are being taken care of by other services. So in this particular example, Istio takes care of a lot of boilerplate that you normally have to do, which doesn't have to do anything with your business logic away from you. So you can focus more on business logic. And in a way, Hipster also does the same. It takes away a lot of boilerplate from you and it generates all that CRUD and the admin part and the user management, security, all these things for you. And you can focus more on UX and business logic. So Istio and Hipster in that way works quite well. The combination gives you even more flexibility in order to take away all this complexity away from you. While this is great, it's definitely not a silver bullet, right? Keep in mind that Istio is fairly new, and also there are other battle-tested solutions like Console, or even the now slowly fading away Eureka is even more battle-tested, in my opinion. So another thing to keep in mind is that resource requirements. So based on your use case, you might end up needing more resources. So for example, this the exact same setup, if I do without Istio, I can run it in a so let me show you here. So here I had to use is it? Yeah, so I had to use N1 standard 2 type machine for this cluster, whereas when I was doing the exact same microservice without Istio, I could run it in N1 standard 1, I believe, or the whatever was the lower version. So that was not possible to do with Istio. So you have to keep that in mind. Of course, doesn't mean that that is also because the default setup that comes out of Hipster for Istio is not extremely tuned for resource optimization or whatever. It has some same defaults, but you can probably further tune it to reduce that resource usage, and you might even be able to get it running in the same CPU type that a lower CPU type. That is possible, but probably you'd have to do all those things. So in a real world use case, it means the advantages of not having to maintain the complex parts of your infra versus having to pay for slightly more resources might be a decision that you have to take based on your priorities and goals as a team, right? So it's not something that I can say, hey, this is for you, this is for you. It's up to you and your team to decide if it is worth considering all the advantages and disadvantages. So I think we are towards the end. I think I'm still 2 minutes on the time. So to recap, yes, Istio allows you to do all these that is required in a microservice architecture. So basically, it provides everything that you would normally need in a microservice architecture out of the box, and even more. So thank you everyone for tuning into this talk, and I hope this helped you to discover Istio or to discover Hipster and to see how you can get started with these. So if you are already doing microservices, probably you can look into this to see if this is useful for you in the future, or if you're planning to build microservices and deciding on architecture, it could be a thing that you can take a look at. Of course, Hipster can help you there. Istio can help you there. Of course, you don't have to use Hipster for Istio. You can also use Istio on its own. It still gives all that advantages. That's about it. If you are interested in Hipster, you can go to its website and read more about it. You can go to the GitHub organization. We are a completely free and open source organization. We run on open collective donations and stuff, and contributors. Of course, we have an awesome community, so feel free to join the community. If you have an issue, if you have a feature request, feel free to go to our GitHub and open pull requests or feature requests. You can tweet or follow us on Twitter. You can ask questions on Stack Overflow. You can even do all the application generation directly from a UI. You don't have to install Hipster. You can go to Hipster online, which is start.jhipster.tech. in order to do that, all these directly from a web UI, and the code will be committed to the GitHub repository that you provide. So that's it. Thank you. And if you want to learn more about Hipster or full stack development, Kubernetes, Istio, you can also get a copy of my book. I have covered everything in my book, from getting started with a monolithic application to converting that to a microservice, converting that to a cloud native service, converting that to an Istio based one, and everything. I have covered everything there. So feel free to take a look, and thank you. I think this is where I can take. I think I have 5 minutes for questions, because unfortunately I won't be able to do the QA session that is after the next talk. I won't be able to do that due to other commitments. So this is where I can take some questions. Zahara, you're muted.
Thanks a lot, Deepu. Sorry about my mutation. Thanks a lot because of a clear and great explanation and presentation. And your audience, in case of having any comments or any questions, you have the chance to leave comments. I can ask from Deepu. And thanks a lot, first of all, because let me ask question from myself. Dear Deepu, what are the other microservices architecture does Hipster support actually? Let me have my own question here. Yes. Let's go on.
Yeah. So the default microservice architecture that Hipster used to provide was based on Netflix OSS. That is until Hipster V version 6. I think the last release in version 6 was a month ago. So in version 6, we still provide Netflix OSS based microservice architecture as a default. So that means you have Eureka and Spring config server as a as something that we call Hipster registry, which takes care of service discovery, routing, all this stuff. And you have Zul on your gateway. You have Netflix Hystrix, you have Ribbon, and all these things. But with Hipster V7, which was released a few weeks ago, we have retired the Netflix-based stack, because honestly, the stack is not maintained that much anymore. It is becoming a bit obsolete these days, because there are a lot more newer things like Istio and stuff. So we have retired that stack, and we have completely switched to a Spring cloud-based solution, which means we have a reactive Spring Cloud gateway by default, and we use Hipster control center as the instead of Hipster registry, which still uses Eureka for discovery, but it can also do other forms of discovery, not just it. So it supports Eureka, it supports URL-based discovery and other stuff. So it supports multiple options. So that is the default that we are providing these days. And you can also build a console-based microservice architecture, and then, of course, Istio-based architecture. So these are the options that we currently provide.
Thanks a lot. I have other questions too, but I think that I'm afraid we're running out of time. So just one more question. It would be great that if you can answer it in short, and I will have it here, is that how does Istio help with security?
So as I mentioned earlier, the envoy proxy, which sits as a sidecar to each of your container within the pods, it controls all incoming traffic and outgoing traffic from your pod. So that means your actual container is not exposed at all. Everything is exposed via envoy proxy. So that adds a huge layer of security compared to how you would normally do. So envoy and along with the policies and stuff that Istio provides, you will be able to control security to a granular level, and envoy also helps you to do service-to-service communication. Even service-to-service communication goes via envoy, so that you can enable MTLS for that communication over gRPC, HTTP, or whatever. So it makes the entire setup much more secure than a normal Kubernetes setup. So that's how it provides more security. I think there are probably one or two questions on chat.
Thanks a lot.
So I don't know. Yeah, I think there are a few questions on the chat.
Yes, we have. Yes, I'm gonna show it to you. The question from Alex is, where do you validate tokens? In the Hipster gateway or in Istio gateway?
Okay, I'm going to assume you're talking about JWT tokens. So if it is that, it is done in the Hipster gateway. So because Istio gateway just
Hipster
routes the
gateway
traffic.
or
So
just
yeah,
one?
Hipster gateway still takes care of being your security layer. So if you use OAuth, then of course you'll use something like Keycloak or Okta to do that. But in this particular case,
Okay.
Hipster gateway does that. So there is another
Yes,
question.
and the other question, yes, it's about the frameworks. Nuno, I think, is asking that which backend framework can be used? Spring, Java, Vertex, Quarkus.
Yeah, so Hipster by default provides a Spring Boot based backend, but you can also use Hipster blueprints to switch to a Kotlin Spring Boot based one instead of Java, or a Quarkus one, or a Micronaut one, or even .NET, Node.js, and possibly Golang in the future. So there are multiple options. Of course, we don't have Vertex yet, but I believe there is a blueprint for Java W as well, based on Jakarta W. How to develop microservices using Kubernetes?
Yes.
Yeah, that's a very wide question.
Let me show them and you can answer.
Yeah, I don't think this I can
if you
answer
can,
in 2 minutes.
if you can sum it up in short or not. Okay.
Yeah, this is a very wide question, and I think I would say if you are new to this, get started with Hipster. Yeah, get started with Hipster. It can help you to get started, because otherwise it's a long topic that I cannot cover now. So
okay,
I think
thanks a lot.
that's it. Yeah, thank you. Thanks everyone for having me, and hope it was useful. Thank you. Bye.
Thank you. Have a nice evening. Bye. Okay, everyone. And I hope you're enjoying till now from the conference. And for the next speaker, we have a senior principal software engineer from Red Hat named Clement Scoffier. Actually, he's a Java champion and also acts as a reactive architect at Red Hat. And before joining Red Hat, Clement has several professional lives, from academic positions to management. He contributes to projects, products touching many domains and technologies such as OSG, mobile, continuous delivery, and DevOps. Clement has always been interested in software engineering, distributed systems, and event-driven architectures. And more recently, he focused on reactive systems, cloud natives, applications, and Kubernetes. And Clement is an active contributor to many open source projects, such as Apertureflix, Eclipse, Vertex, SmallRide, Mutiny, and Quarkus. So let's see his speaking and presentation on the subject, the Quarkus reactive journey.
Clement Scoffier, I'm working at Red Hat, and today I'm going to present how we have infused Reactive in Quarkus and why we did it, what are the benefits of doing such kind of things, and where are we standing today. But first, what's Quarkus? Quarkus is a stack to write Java applications that are truly cloud native. It's been tailored for microservices and serverless, but not only. You can write a monolith with Quarkus without any issue. What makes Quarkus different from the more traditional framework is how it creates the application and how it started. A traditional Java application or application server like Wi-Fi or Vertex, any Java application generally, you do something at build time, so Maven clean package, you get a Fajar, a WAR, whatever, you deploy it or you start it, and then at runtime, the application will start locating resources like configuration file, do class path scanning to find annotated classes and methods and so on, build a kind of a model of the configuration, and then start the management, like starting threads, starting HTTP servers, and so on. And it will do that for every framework your application uses. Quarkus do it a little bit differently. It does all this at build time. It means that at build time, we are going to locate the configuration, do the class path scanning, build this meta model and the configuration, and infuse all this inside the resulting package. Inside our package that we are building, we will have all the code that is necessary to start your framework. So at runtime, no need to redo all these applications. We can just start the threads and everything has been already tailored and read and compiled inside your package. So by doing this, we start way faster because, well, as you can see, we do a lot less things at runtime when we start the application. It also brings nice memory benefits because you don't need to bring an XML parser, for example. Class path scanning introduce a lot of class loading, which we don't need to do anymore. So it reduces the memory, it reduces the startup time. So it really makes it very efficient for the cloud to increase deployment density, to enable serverless with Java, and so on. Quarkus is not only this, it's based on 4 pillars. The first one is developer joy. We are going to see in the various demos that we are going to do today. It has a very nice hot reload mechanism. It's really, you're really efficient when you're building something with Quarkus. Supersonic subatomic Java. We already see this build time pipelines. That's not only this build time pipeline bring you less memory and faster startup, but doing this pipeline, we can also collect a lot of metadata about this application and tailored, or at least do all the fine-grained tuning of a native compiler. So that means that you can compile your Quarkus application into a native executable by doing fine-grained tuning. This fine-grained tuning is done for you by Quarkus. So you get very optimized native executable. So you get even more memory benefits, even smaller startup time. A lot of the libraries and API we use in Quarkus are standards and libraries we all use for years, like Hibernate, like JAX-RS, like Spring, like Vertex, and like Camel. We're also innovating a lot. We are going to see this because we're innovating a lot in the reactive space. But you more or less already have years of experience with Quarkus. Finally, and that's going to be the topic of today, Quarkus unifies reactive and imperative. And what I'm going to explain in this presentation is how we have done this, why and how. So our journey to reach the point we are right now. But first, why reactive? Well, because of distributed systems. Most of the applications we are building today are distributed systems. Cloud application, Kubernetes, containers, most of them are distributed systems. While the cloud or containers is how we build distributed systems, because you can create services, new VMs in a couple of seconds, it doesn't really help so much the complete, on the big pictures, in the sense that all those ephemeral resources, need to be handled by your application. So we are adding burdens to our applications because this dynamic availability is hard to handle. So while all these infrastructure layers have been improved over years and provide very nice features, it's only half of the story. The second half is your applications. And that's where we need to tune things and make application right to live in such kind of dynamic distributed system. Also, the usage has changed. While 10 years ago, things was quite quiet, let's say, around our systems. We have users, but not that much. Because of internet, because of the revolution we have around IoT, mobile, and even the web, we get a lot more users, a lot more requests, and your distributed systems get a lot more stress. So, thanks to this, or because of this, the chance of failures becomes, well, very high. And while we always say that a distributed system is a system that failed, it becomes very, very true today. And we need to handle such kind of uncertainty and fragility. We need to improve that. Another thing we have seen over the past few years is the explosion on the number of events. While initially it was a lot of RPC and commands, event-driven becomes almost the norm today. Events coming from the IoT, events pushed to mobile, events coming from machine learnings. A lot of things are events, and we need to write applications that consume those events, produce events, and this efficiently. So where does reactives come in? Well, there is several reactives. First, reactive systems, as defined by the reactive manifestos, propose a new architectural style focusing on responsiveness. By using message-driven to exchange messages between your components, it brings you elasticity and resiliency, so you're building better distributed systems. You may have heard about reactive streams, which is a modern asynchronous non-blocking backpressure protocol. It's a great protocol when you have, in a push architectures, a slow consumer and fast producers. So how do you avoid overflowing part of your systems? Finally, reactive programming that has been popularized by modern UIs such as Angular, React, but also spreadsheets. Spreadsheets is all about reactive programming. Is a way to write asynchronous code or event-driven code. In the Java world, it's been popularized by reactive extensions such as AHOY Java and Reactor, but not only. And we will see how it plays a role in our reactive story. I want to come back to reactive systems, because reactive systems is really what you want to build. Better distributed systems. Distributed systems that can cope with the challenges and the uncertainty of cloud-native applications. It will use asynchronous message passing as a main way for components to interact, and by sending messages to a virtual address, well, it brings you elasticity and resilience. Elasticity because you can have multiple consumers behind a single address, and you can change that number over time. At runtime, you can adapt it. And resilience because if one of the consumer crash, you may have another one to take over, and also because message-oriented middleware have durability, retention, and acknowledgement mechanisms that make them fault tolerant. If you can handle your message, your request, the work you need to do, even under fluctuating load, and even when facing failures, you become responsive. So you build a better distributed systems. What we wanted in Quarkus is to provide an easy way to build such kind of systems. But we need to do that efficiently. And one of the aspects of reactive systems is how they leverage non-blocking I/O. In traditional Java applications, it uses blocking I/O, and we have a thread affinity between a request, an incoming request, and its management. So it's the same thread that is going to manage the request. How does that work? Well, when you get a request, you assign a thread, and if during the processing of that request you get some blocking I/O, like calling another service, writing into a log, or interacting with the database, the thread waits until it gets the answer. So the only way for you to handle multiple concurrent requests is to increase the number of threads and having worker threads. Unfortunately, each working thread is adding a memory overhead, a CPU overhead, and you limit your concurrency by the number of threads you pre-associate with your worker pool. So if you say that you have 100 threads, then you can only handle 100 concurrent users or requests, which was okay a few years ago, but with the loads we are seeing these days, is a bit too limited. One idea by using non-blocking I/O is to use an event loop mechanism that will handle multiple requests on a single thread. How? Well, you get a request, then the event loop starts executing that request, and as soon as this task cannot make progress anymore, it will release the thread and execute another task. What I mean by not making progress anymore, that means doing some I/O. And by doing this, it will schedule the I/O and say, well, when it's done, come back and execute the rest. So continue my execution. That's what we call continuation. So for example, if we take the red task here, the first one, it starts doing something and then it's blocked, not really blocked, but cannot make any progress. It enqueues this I/O interaction, like interacting with the database, and say, well, when you are back, continue with this second big thing that we are in the middle of this line, and so on. So it allows having a single thread handling many concurrent requests. That scales because you can handle a lot with a low level of memory and so on. So it brings you a way better usage of your resources, efficient usage of your memory and CPU. There is other benefits behind Reactive. First, as we will see, the development models that we are going to use, it's much more event-driven. It's made for this event-driven nature we are starting seeing on the cloud. So on event X, do Y. This will help doing IoT, mobile, but also improve the user satisfaction by improving your responsiveness. As we said, non-blocking I/O is going to reduce the amount of usage of resources you will need, so we'll use your resources efficiently, and that will, one, improve your scalability, so user responsiveness, user satisfactions, but also increase your deployment density. And that's a key aspect these days because deployment density means money. Means that you will be able to handle more, to deploy more application on the same set of resources. If you are using in-house Kubernetes or in-house data center, that means deploying more there, more application, more features. If you're on the cloud, that will reduce your monthly bill. Both are very important and both are key arguments for your executive level because that means money. But, well, you see it coming. Something is not that simple, right? So let's see this a little bit more into details. When you switch to Reactive, as we said, you switch to non-blocking I/O. So that means that you have a non-blocking I/O layer. In the Java world, it's most of the time it's native. Then you have your Reactive frameworks and you have your application codes. Everything runs on the I/O threads, which could be an event loop or generally an event loop, but yeah, it's these I/O threads. And you cannot block those I/O threads because you have only a few of them. If you start blocking one, well, the whole model collapses. If you block one of your I/O threads, it cannot do any other task at the same time. So instead of having the ability to concurrently execute under a multiple request, you don't do this anymore. So to avoid blocking, you need to write non-blocking code and asynchronous code. You understand why I put a bottle of Braam here? Because that gives you a lot of headaches, especially for developers that are not used to such kind of model. So, okay, but how can we really make this simpler, make this affordable for every developer? Not for only the rockstar, but really for everybody. And that's what we really wanted to do in Quarkus. That's what we mean by the unifications. That's the architecture of Quarkus. So we have our non-blocking I/O layer on the bottom, which is based on Eclipse Vertex. We have a set of extensions, which are providing the different features of Quarkus. And then we have a routing layer. And every interactions you do with the network will go through this non-blocking I/O layer, extensions, routing layer, and calling your application code. If Quarkus realizes that what is handling this request, this message is reactive, well, no need to switch and it will still use the I/O thread. If it realizes that it's a blocking code or imperative code, it will switch to a worker thread. So that means that we have both worlds in a single stack. But then you can say, hey, but that's a little bit a reactive anti-pattern, right? Well, yes, that's a little bit an anti-pattern from a reactive point of view, but it's a pragmatic pattern. Because that means that you don't have to switch to full reactive, or you can do the migration at your pace, you can decide if one endpoint is better to be reactive because it's called a lot and it's very expensive, or if you still need blocking code. So you can really decide what you want and put the cursor where you need and not big bang rewrites. We are going to see this into details now, and I'm going to show you a set of demos that explain how we have introduced Reactive into Quarkus and what are the benefits step by step. So that's what we are going to see now. And the introduction of Reactive in Quarkus has not been a simple, easy journey. Well, first, Quarkus was not designed to be reactive at the very, very beginning. We are going to see this. And then we had a few hurdles and we needed to improve it, but also extend the reactive landscape because we didn't find what we were really looking at. Initially, when the beginning of Quarkus, it was not reactive. It was really made for, let's say, old school CRUD applications. So REST and database, and it was, well, that was the first prototype, and that what was supported at that time. So very simple architecture here, blocking I/O, a set of extensions, a lot less to what we have today. It was Hibernate and REST-easy, more or less, and some application code, all blocking, all executed on the worker thread, access to the database on the I/O threads because it's blocking. So, yeah, well, old school applications, purely imperative. So here we have the very simple CRUD application developed with Quarkus in a regular imperative way. Here I have an entity, so it's a panache entity to make Hibernate and JPA a little bit easier to use. I'm going to represent pirates. They have a name. Keep things simple. I'll just have one field, not blank because I'm using Hibernate validation. I have this method to get a random pirate from my database, and that's it. So I also have CRUD facade, let's say a REST interface for this pirates that I have in my database. I have a simple get that get a random pirate, and then I can get one by ID, and I can add a pirate. So let's see how it looks like. So I have started my application here, and let's try to see if I can get a random one. So I got Dirty Danny, Captain Silverhook, or Barnacle Bill. They're all fictional. Obviously I can add one. It's pirate and name equals, let's say Neo. That's the name of my rabbit. Oops. Okay, so we got, we have the /n, but that should not be an issue. So I got my new pirate. I can get it. 158. And here it is. I got my pirate. So everything is simple here. And let's try to see if here I'm trying to print the current thread. We should get executor thread 1, which means that we are on a worker thread. So at that time, it was absolutely not reactive. No non-blocking I/O, no event loops were still dispatched on a worker thread. So it was maybe simpler to develop with, but lack of efficiency and scalability. So the question at that point is how we make Quarkus reactive. And the first step for us was to introduce Vertex in Quarkus. I was coming from the Vertex team, so for us it made a lot of sense to have Vertex play a big role in Quarkus. So at that time, we just did an extension, a specific Vertex extension handling a managed Vertex instance, And so the application code can have both traditional imperative code as well as vertex code and access to the vertex ecosystems. Interaction between both was possible thanks to this vertex event bus, which is how vertex application communicate, or different vertex components communicates. So thanks to this vertex extension, I can write a vertex component, so which is a bin in the application scope, which use this manage vertex instance. And thanks to this, I can use all the vertex APIs from Vertex Core, but also from the whole vertex ecosystem, such as Redis. And I can create HTTP servers and do like this. What I'm going to do here is get the last return a parrot name and store it in Redis and have an endpoint that provides this. Not very useful, but let's see. So here I can use the Vertex API to create an HTTP server, which on request will call my request handler here. We will see this in a few seconds, and start on the port 9999. Okay. As I said, Vertex component interacts using the event bus, and to ease the interaction with the event bus, here we have this consume events annotation, which means that I receive messages that are sent on the random parrot's address. I get a parrot, and when I get a parrot, I need to read it and need to store it in Redis. So I just wrote a method to do this. That's what I'm going to do here. Here I just use the client and Redis API I've created in my constructors, and this, as you can see, is a bare vertex model using callbacks. Callbacks are simple to understand, meaning that when I'm connected, I do this. So this is my continuation. The only issue that you need to handle failures too, and that leads to a little, well, code that can be a little bit complicated. That's the same thing I do with my request handler. I'm connecting to Redis and retrieve what I store at this key. So that's great, but I need to intercept or receive my parrots. It's what I would do in the parrot resources. Here I get a random parrot, and I will use the event bus, which is also a managed object I can inject. And I will just publish on the address, which is random parrot, my parrot. So you can see how an imperative components and reactive components can interact using this event bus, and how you can inject the event bus and use this at consume event. So let's see if this works. So now if I set a parrot, so that should be Susie McGraw. If I get that, here we go, we get Susie McGraw. If I get another one, Edwin Nomani Marbles, then I get Edwin Nomani Marbles. So having this second vertex ecosystem side by side with the imperative one was not great. So we needed a way to have a single word. And what we did first is to rebase all our HTTP stacks on top of the vertex one. So to do this, we are removing the blocking IO layer we had before, and we were using this non-blocking IO layer provided by Vertex, and use the Vertex HTTP server as a primary HTTP server in Quarkus. That means that our Vertex extension does not only provide a managed Vertex instance, but also a managed HTTP server and a managed web router on which we will register routes. So how can we handle both reactive and imperative paths with this? Well, as I explained, we have our routing layer, which is powered by the Vertex router. And depending on the type of endpoint that is called, we decide if we need to dispatch on a worker thread, or if we can stay on the IO threads and get all the reactive benefits, because in that case, you are reactive end-to-end. So let's go back to our Vertex component, but in this version, I don't only inject the Vertex, the managed instance of Vertex, I'm also injecting the managed router, which is our routing layer, which is shared between the reactive world and the imperative world. So if I register a new route here that intercept all get all routes with a get verb, and I, for example, I'll do something very simple like adding a header. Sorry. Let's say Hicks quote, and let's say Neo is her parrot. OK, and then because it's an interception layer, we need to say on next. This will be applied for both this imperative and reactive word. And here I have the second route that is doing exactly what I was doing before, so retrieving the last generated pirate's name from Redis. So let's see if it works. Let's generate a random one. Okay, that's going to be Pearl Bailey. Yeah, so first thing here is that you see that it's been intercepted and we got our headers injected. So it's already quite nice. And let's see if I can get /last. And we got Pearl Bailey. So that's pretty cool. Let's have a look on which threads we are called here. So if I call to get a random pirate, I got Opal Sea Wolf, and if we see here, we are, so the interceptors are called on the event loop, on the IO thread, while the endpoint itself still run on a worker thread. So the routing layer switch just to call that method. And obviously, if we call last, then everything is on the IO thread, even this, because this is a reactive endpoint. Having a single network stack is the first great step for Quarkus, but we also need to work on the development model and provide a development model that can be understood and used even by imperative developers that are not used too much with reactive, because sometimes I want to use some of the reactive feature from Quarkus to be efficient, to be scalable, to be more concurrent. So we need to provide something that they can use. Coming from the Vertex team, I had the chance to observe how different asynchronous development model has been used over the last 6 years. We have already seen callbacks in the previous demos, and yes, we can all understand that this is easy to use, but can lead to spaghetti code, so not necessarily maintainable. Using features on completion stage is limited to single result operations, and sometimes the API can be a little bit weird. Using coroutines like Kotlin or Loom is great. It completely hides this asynchronous aspect, but sometimes it's go too far where you are missing this event-driven code. So mapping event-driven process can be harder, and nothing is free. And if you have questions about Loom, I can answer in the Q&A questions. Finally, there is reactive programming like Eric Java, Reactor, and the one we are going to see, Mutiny, which provide a way to write asynchronous code using data streams. When we started looking at that and say, okay, that's what we need for Quarkus, we started looking at the existing reactive programming library, but the developer experience was not great. On the left side of this slide, you have an example of Eric Java code. And let's be clear, even if this code is functional and so no problem, it's working, you don't want to maintain this. And over the past 5 to 6 years, when I was going to an enterprise, to a company explaining reactive and how Vertex would fit their need, I get one primary comment that say, well, it's great. It really will fix a lot of our issues, but if only our top tier developer can implement and maintain this code, for us, economically speaking, it's a disaster. And I can hear that. I can understand that maintaining such kind of code over time is hard. Another problem with existing reactive programming libraries is that they use this pattern to have hundreds of methods on a single class. Even most sophisticated IDEs will be lost when proposing completions. Here you have an example using Eric's again, where you don't know which method you need to call. It's not navigable at all, and there is a lot of overloaded variants of every method. So you need to understand, learn, and know a lot of operators, hundreds of operators, to become efficient using these libraries. So we need something a lot easier for people that are not used to such kind of libraries. That's why we made Mutiny, a simple but effective reactive programming library. Mutiny provides two types, Uni for a single item of failure operation, so asynchronous operation, and multi for stream of events. Both are event-driven in the sense that the code is on item, on failure, on completion. On item do this, on failure recover with, and so on. We are going to see example in the live coding demos. In Quarkus, every reactive library API is exposed using Mutiny. And we had great feedback about these new APIs. Imperative developer, there is nothing negative when I say that, but developer not used to reactive that start telling me, well, we finally understand what it is. We can write reactive code. It really help us. That's great for us. That's really what we wanted to do, is providing a better user experience even for reactive. So let's see this in action now. So in this demo, we are going to implement the same mechanism we had before. So saving the last item in my database, in my Redis database, the last generated pirate names, but also retrieving from this Mutiny component. As I said, everything in Quarkus uses the Mutiny model for everything reactive. So here I inject a reactive Redis client which exposes a Mutiny API. So in my consume event here that I have here, so on random pirates, so every time that generated pirate names is sent, is generated, this is called, and I can just say client.set, this return a uni, and I would just subscribe, which is something we do in reactive programming, or nothing happen, it's lazy by default, so this triggers the operation, and when we are done, we just say, okay, it's done. So we have a second event handler here, which is to get last, where I get last. So I need to return the last one from Redis. And what I'm going to do here is to use my client and say get last. When this is done, when this emits an item, then I will transform it by just calling to string, because it's actually storing a string in Redis, and I would just return this. That will get my uni. So this didn't happen yet. We return a uni, so something from Mutiny. And if we go in my parent resource, here I have injected the Mutiny version of the event bus, so using the Mutiny API, which lets you do send and forget. Send a message, I don't care about anything else, but also send and request, which I will send a message and receive a result, which is what I'm going to do here. Request on last, on item, when I get my result, I will extract the payload, the body, sorry, and it can be null if we have nothing stored in Redis. So in that case, if null, I'm going to fail. And on failure, whatever it comes from, this failure or Redis failures or anything, I will recover with something like no something meaningful, as you can imagine. And then that's it. I will just return this. Oh yeah, and I need to send something here. I can send null. So why are you unhappy? Oh yeah. I need to say that it's a message, a string that is received here. And that's it. So now with this in place, if I get random pirates, it's inserted in Redis. Okay. And now if I do /last, it should retrieve it. So get it back by sending a message on the event bus. My Mutiny component get it, use reactive Redis API, retrieve it, send it back, boom. So as you can see in this code, in our JaxRS endpoint here, you can return uni directly. And that's asynchronous. So here I have a synchronous API, event transactional. Here I have an asynchronous endpoint. In that case, and we're going to see this in the next part of the presentation, it's still called on the workers thread, because we are in a regular Jack-serverless component. Something you can do too is to generate a random pirates using SSC, so a stream, so to return a multi, so a stream of pirates. And in that case, I will do return ticks on item. So on every item I want to generate a new pirate, so I will just transform it to get random pirates, and that's it. And now if I go back here, I do, what's the name, stream, I need to say that it's SSE, and we get every second a new generated pirate's name, and so on. So what we have seen here in this demo is that we can have both traditional imperative and reactive types from our endpoint, and we have the Mutiny API for everything. So that makes the two worlds a lot closer than it used to be. So what's next? We have our single reactive network stack. We have the Mutiny development model, providing a nice developer experience for both imperative and reactive. But as we have seen, even if you use Mutiny, sometimes you are called on the worker threads, and you don't want this. So we have worked and improved this lately with two new big additions to our reactive story, namely Hibernate Reactive and Rest Easy Reactive. Hibernate Reactive is Hibernate but using non-blocking reactive database clients, so providing asynchronous, non-blocking reactive APIs, Mutiny of course, and Rest Easy Reactive, which is an implementation of Rest Easy but on top of the event loop, and is well integrated with Mutiny too, so you have a consistent experience here and you are dispatched on the IO thread. In this next demo, we are going to see how we can use both as well as gRPC to have a complete end-to-end reactive story. Let's start with Hibernate Reactive and Panache, a layer on top of Hibernate and Hibernate Reactive that has interaction with Hibernate and JPA in general. Hibernate Reactive is an implementation of Hibernate on top of non-blocking reactive database driver that rely on this driver to make database interaction totally reactive and non-blocking, so efficient and scalable. Here you have an example of a ship resource because a pirate cannot be a pirate without a ship. It's extend Panache entity, which come from Hibernate Reactive in that case. And here, every operation you will do return a uni or a multi, which means that everything is going to be asynchronous and unblocking. Then we have our REST endpoint. In front of that, you see here I'm returning uni, obviously. So you say, but what's the difference with the code we have seen before? It's not the same REST Easy. Here, in this project, I'm using Rest Easy Reactive, which is an implementation of Rest Easy on top of our reactive core, which means that it's a non-blocking and asynchronous end-to-end, which provide great performance, concurrency, and so on. So what we see here is that we can get a random ship by returning a uni, and because Hibernate Reactive return a uni, and because we can provide a uni here, you just change them, and that's it. And here we can get a specific ship. So let's try this. Let's get a random one from our database. So I got Night Wind, and if I get the number 4, you will recognize it is a black pearl. So that's great. And when you do this, as you can see here, I've printed the thread name. You can see that we are running on the event loop. Because yes, in Rest Easy Reactive, as everything is reactive, we run on the IO thread. So no need to switch to a worker thread. Well, sometimes you really need to do it because some logic has to be blocking. Fortunately, we also support this ad blocking annotation that can be put on method or classes, which will offload the work to a worker thread. So if I get my black pearl, but using this blocking endpoint, we are called on this worker thread. So that's really great because you can have both reactive and imperative side by side, and you decide where you put the cursor again. And if you wonder about this code, that just get this one as a uni, and that's part of the Mutiny API. We await at most 5 seconds. The rest is very similar. You can add a ship, and you can get a stream of ship like we did before. So every second a new ship, and every second it called get a random ship, would go to the database and so on. Nothing is blocking everything on the IO thread. So very, very efficient. As I said, we also have gRPC support, so you can consume gRPC services using a Mutiny API and get and use it directly. You can also implement gRPC services using Mutiny. You can also use the default gRPC model, but we provide a Mutiny stub and implementation based, which make developing such kind of services a little bit easier, especially when you are dealing with streams. So here, if I want to call /quotes, I can just do that and get a random quote about parrots, obviously. That concludes our demo. So what we have seen here is how in the new version of Quarkus, everything is becoming more reactive, and that's just the beginning. There is plenty of other reactive features that are supported here. We have seen gRPC, Hibernate reactive, and REST-easy reactive, but there is a lot more in Quarkus. Are we done? Oh no, we are not done. What I just presented is where we are today, but there is a lot more reactive features that are available in Quarkus, and we are continuing our expansion of the reactive landscape. One thing I didn't mention in this talk is how we handle messaging, and more especially Kafka. We have something called reactive messaging that make developing event-driven microservices, event-driven applications very, very easy. It's our key component to build reactive systems. I have other presentations available online on YouTube where you can see how it can be used in Quarkus. And it's always the same thing. It's reactive first, but you can also write imperative code with that. Quarkus has a lot other reactive features. We have mentioned data with Hibernate reactive. We also have Mongo, Redis, and so on. We have seen gRPC, but we have a lot more protocols such as Kafka, MQP, MQTT, Apache Camel if you have any legacy system. We have a lot of web components, including mails, templates, GraphQL, and so on. And everything is based on this idea that we have reactive first, and on top of reactive, we can build both reactive and imperative in a consistent and efficient manner. That makes Quarkus a prominent actor in the reactive space, that make Quarkus applications highly efficient, very scalable, under high concurrency, and we are continuing our progress on these lines. That's all I have today. If you're interested by running these demos yourself, you can check them on this GitHub repository here. If you are interested by Quarkus, go to quarkus.io or code.quarkus.io to generate a project. You can interact with the team using Zulip. Follow us on Twitter using Quarkus.io, and if you want to contribute, if you have a question or find a bug, just go on our GitHub repository. Everything is open source, so you can contribute. And if you like what you have seen today, go to this repository and click on the star button. That is totally useless, but that makes us, the Quarkus team, very happy. I'm done. I hope you enjoy this time with me, and if you have any question, you can ask them during the Q&A session. Thank you.
Okay, thanks to Clement because for his appreciable presentation. And dear attendees, in case of having any question from Clement's actually presentation, you can go to his social media, Twitter or Instagram, with the idea of Clement's Pop, @Clement Pop. So maybe I can have one @Clement Pop. I will leave this in comments so everyone can see that. Yes, this was his ID. And exactly, everyone, I hope you are enjoying the conference right now. It's time for our next flash prize. Actually, this time is React.js Case Study Festival. Speakers from Facebook, Microsoft, Shopify, and many more great teams today will share their day-to-day development cases on React.js projects, actually accessibility in action, battle-proven tools in use with React.js, React.js components, and performance enhancement tips and tricks called up. And actually, the flash price for the QA Summit will be $99 instead of $159. And the number of tickets is limited to 20. More flash prices coming in the next block. So if you're interested in Angular, Vue.js, Python, or cybersecurity summits, don't miss our chance to get the best price. Actually, as we are going, I think that we have 5 minutes of break here. And actually, for another mention, please, first of all, thank you for commenting in YouTube and Pine. And that you like the tags. We really value that because all the teams, all the speakers, everyone here worked a lot for today's event and the tomorrow one. And we have a giveaway for among those who will post in Twitter and mention our official accounts, Geekle.us, @Geekle and write what you liked about the post, events, topics, speakers, and so. And there will be 5 winners, and they will get 3 tickets for free. So I think we're gonna have 3 or 4 minutes of breaks, and after that, we're gonna have our next speaker, Patroklos Papapetrou. Okay, attendees and dear attendees, hope you're doing well and enjoying. Actually, I want to introduce you the next speaker, and he's Patros. Let me have him to stream. Hey, Patroclus.
Hey, Zara.
You're on
Hey,
stage
nice to
right
meet you.
now. Nice
Thank
to
you
meet
so
you
much.
too. Thank you for attending here and being our speaker. I'm gonna introduce you for our attendees. Patroclus is the principal software engineer at Elastic and a software gardener, clean code evangelist, technical author, occasional speaker about code quality, soft skills, and Golang programming. And his subject is about the top 10 plus 1 essential soft skills for every developer. So thank you for having you. And if anything needed to add in your biography or anything else that you want to mention here.
That's fine. I will do my short introduction in a minute. Okay, that was great, but thank you so much.
Thank you. Keep on going. Thank you very much.
Okay, so I hope that you can see my screen. Let me start the presentation right now, and we can get started. So first of all, once again, thank you so much for having me here at Geekle conference. It's a bit weird to talk to your screen, although I'm sure that right now I'm not the only one. Usually doing pre-recorded sessions is not ideal, but now at least that someone is watching me, at least Sarah is watching my presentation, so it feels good. Yeah, today I'm gonna talk about the essential soft skills about developers. As I said, my name is Patroclus Papapetrou. I'm from Greece. You can follow me on Twitter, or you can find me on LinkedIn if you want to connect with me about anything. A few more things about me. The last 6 years, I'm working remotely for US companies, lately at Elastic as a principal software engineer. In general, I have more than 25 years experience in software engineering. I'm a father of 2 kids, and I'm very active in the local tech community, organizer of some local meetups and some of the biggest tech events in my home country, Greece. So let's get started. The first thing I want to talk about is why this talk. I mean, that specific topic was bugging me for some time, even before the pandemic, and now, especially this last year that we are living in a completely different world, several things has changed regarding our working environment and the skills that we, the developers, need to have to be even more successful than before. So briefly, probably we all have noticed these things. Remote working now is a necessity, not just like an optional. I believe that most of us are already working fully remotely. And I do believe that even if this madness is over, probably we will reach some kind of balance between remote working and working at the office. So remote working is here to stay, and it won't change back to the previous situation. This actually brings us some more challenges, like we are working now, since remote working, anyone can work in any company from all over the world. We are challenged to work in a multicultural environment, more diverse environments, people coming from different countries, different cultural ethics, different backgrounds, technical. So this requires us to be able to deal with different personalities and skills. One more thing that I have noticed the last couple of years is that during the hiring process of engineers, or at least this is how this should be done, the soft skills are valued a little bit more compared to how things were let's say 3 to 5 years ago, where there was no notion of soft skills. Again, my expectation is that this soft skills value will keep increasing the next years, and maybe at some point they will be equally valued with any technical skills required for a specific job description. And last but not least, definitely we are engineers. We are supposed to produce quality code, implement features, make computer systems work. But I strongly believe that it's not only that. We have to communicate with several people inside the team, outside the team, customers, work with other cross teams, negotiate with other people, present our technical solutions, describe some problems and other stuff. So it's not only about writing code. There are a bunch of stuff that we need to do during our day-by-day work. So why are we calling them soft? It's really funny. I don't like this term, but I had to use it to make clear that everyone understands what this is talking about. So soft skills, you can find a lot of, let's say, synonyms. I prefer calling them the work skills or essential skills or non-cognitive skills. To the contrary, hard skills are supposed to be all the technical skills, right? Like, knowing how to program in Java, or know how to configure infrastructure in AWS and stuff like that. I like the third bullet because it's very simple. Actually, soft skills is everything that we haven't been told about when we are students in universities or when we're actually learning about programming. I don't think that any one of us has attended any course about soft skills. Maybe things have changed, but at least people that have graduated at least 5 years ago, there was nothing about that in universities. And usually, although they are soft skills, we learn them the hard way, meaning that we need to start practicing them and learn them during our daily activities, which is even harder to learn them. So how many soft skills are out there, and can we master them all? So these are some pretty nice questions. I would say there are dozens, maybe even hundreds of soft skills, although most of them, they are somewhat some kind of variations. But clearly there are several of them. Do we need to master them all? Apparently no. And I mean, other than the pure, let's say, practical reasons, my experience has shown that not all companies are valuing the same all soft skills. So it's a bit like useless or not productive to start learning or reading about soft skills. However, and this is the purpose of this talk, I think that there are at least some soft skills that they are, let's say, essential, or we have a chance to apply them no matter which company we're working for, or even if we want to switch, let's say, careers and from engineers become something else. I think they have the same value. So let's get started. The first thing that I have in my mind about soft skills is self-disciplined, which can be also described with several variations like self-motivated or self-supervising, self-directed or self-monitoring. This actually applies mainly to remote engineers. I mean, it's super easy for someone that works from home to get distracted, right? I mean, there's nobody close to you. You can just easily switch back, just open a browser and watch your favorite Netflix series, or just spend an hour on Facebook or Instagram. It's super easy, and nobody can actually confirm that we are working or not. So I guess this can happen also to a traditional working environment, but I found this really special for remote engineers. And if you think about it for a minute, right now, I mean, I guess most of us, we are working from home because we are forced to. So this is not actually working from home. It is actually working from quarantine, which means that if you have a family, your family probably is living in the same house and they are locked down as well. So it's not that you have always a pretty quiet place to work. So being self-disciplined and keeping focus is really important for us as engineers. Why? Because definitely, if we can focus to our work, then we can focus to our important goals, and we can deliver things without working overtime. And again, it's super easy to work 12 hours a day if you're working from home, because it's very easy to lose track of time. And definitely, if we can deliver things without working overtime, then we can achieve better work-life balance, which is the number one, let's say, benefit of working from home. And last but not least, if you are self-motivated and you are achieving your goals without having someone to remind you, we can avoid micromanagement, which is already bad in a traditional environment, but it's becoming worse in remote environments. If someone is pinging you every couple of hours or couple of days, asking you about the progress of a specific item. So this one, I think it's one of the most important soft skills. The second one is about exchanging feedback. And exchanging apparently means that we are ready to give feedback, constructive feedback. We are ready to accept feedback from others. And not only that, we are actually seeking for feedback. We are asking people to give feedback about our work, okay? And if this sounds a little bit strange to you, just to let you know that we are constantly giving and receiving feedback every day in formal and non-formal ways. I assume that most of us, as we are engineers, and part of our development process requires to create some kind of pull request. Someone has to review the code and prove it or not. And then if there are some comments, we have to address them until it's ready to be pushed, commit to the main branch. So that simple flow, informal flow, it's a very commonly used way of getting it and setting feedback. Apparently, there are more formal processes like quarterly reviews or monthly reviews with our supervisors, okay? And this can be done in a one-to-one, face-to-face meeting, or like more formal in a piece of paper. And of course, this has to be done vice versa. I mean, not only supervisors should give feedback to engineers, but also engineers to supervisors. And again, it's really great if we can give some feedback to our colleagues in the same department, and even greater if you can get or give feedback to colleagues from other departments, because this is where actually we can show how we can deal with people that are not working with them during every day. Moving forward, empathy, which is a Greek word, and I like this soft skill. There are a couple of variations like emotional intelligence and compassion. This actually means it's the ability of an individual to understand their own emotions, which is critical. And then once we can understand our own emotions, then we can understand the emotions of other people, our colleagues. And once we achieve the goal to understand the emotions of others, then we reach the next step, which is actually communicate to others that we are understanding their emotions. That's whole cycle, it's a 3-step, let's say, cycle, is actually empathy. We definitely know that people have their own feelings. I mean, they can carry their personal problems to work. They might feel stressed, or they might have bad days. Everyone has stuff like that. If we can feel their pain, share the same emotions, and communicate to them, this definitely can increase trust between co-workers. apparently we should not be judgmental. I mean, we are not judging their state of mind or feelings. This might increase the team spirit. And why not? Maybe to put it in another layer, we can create a blameless culture. People are allowed to do mistakes. Like I said, everyone has their own bad days. So empathy is very important to me, and I think it's one of the hardest soft skills to achieve because it requires all these steps of understanding emotions and then setting our understanding. Next one, it's about persuasion or negotiation, and probably you might think, hey, I'm not going to be a politician. Why do I need to negotiate or persuade people? Well, think about it. When someone works, for several years in the same company, or they have a role with some fancy title, this doesn't come, with the privilege of forcing their opinion because of exactly this role or is in the company. Everyone should be able to present their own view, provide a list of arguments, technical details if they're required. And at the same time, negotiation means that we are able and we are also willing to accept questions, okay, that they are actually questioning our arguments, and we should be able to answer all the concerns. I mean, that's the idea. If you can answer all the concerns, then you'll be able to persuade someone. So negotiation is not like what you have in mind about political negotiation. It's about everyday work. Like everything is like a negotiation, right? I mean, from the time that we ask, okay, who wants to do this task, or who wants to write this user story, everything is like a negotiation, even as the smallest one. So reaching the middle of the list, this is one that I really like, and I'm trying to convince my kids to act like this from their early stage. So this is like eternal learner. Some variations or synonyms is like willingness to learn or desire to learn, and technology threat awareness. Probably you already know that we are living in a super fast and changing world, and technologies are emerging almost every week, every month. Programming languages and frameworks are changing almost every week. I'm sure that some of the things that we learned a couple of years ago might be completely useless today. Some programming languages are dying and they are born again. I mean, recall Python, it was 20 years ago, was super high, then it died, and then 5 years ago it's becoming cool again. But this soft skill has like a trap, and this is called like hype-driven developer. It's really easy for someone to try to keep up with everything that goes on in specific technology, try to learn everything here and there without diving in depth in some technologies. This is really a trap because in the end, we will actually know nothing, and all we will do is like cycling ourselves, chasing our own tail without actually gain anything useful for our knowledge. Last but not least, for this specific soft skill is, which is equally important with the other, let's say, variations, like the willingness to unlearn. Sometimes what we have learned in the past, now it's meaningless because something else has completely changed it. So if we are willing to completely unlearn, forget, in other words, what we used to do and learn new things, that's the key, I think, to eternal learning and become more successful in our careers. Delegation. Usually, if I'm doing this talk in a face-to-face in physical meetups or conferences, I ask people to stand up, and those that have said the last, let's say, week or month, no to someone who asked them to do something, okay? And I know that's usually not no more than half of the audience is actually standing up, and this is actually expected. To make it even harder, let's retrospect a bit and ask ourselves how many times we have accepted the task, although we know that we don't have the capacity to do that because we already have too much on our plates. Or how many times we didn't trust a coworker to do something because we can do it better or we can do it faster. These are very typical symptoms. I'm doing this all the time. I'm trying not to do it, but it's natural reaction of engineers. I don't know why, but this is it. It might sound that it is mainly important for team leads or I don't know, supervisor, people with some kind of seniority, but everyone have to learn and say no or delegate a task to someone else who might have more free time or might have a better skill set to achieve the same task, maybe faster and maybe better. Gathering all the tasks on our plates because we are the best and we can do everything, it sometimes can lead to the opposite direction, okay? Now, what about trust? Trust is really important, I would say. By trust, I mean, trusting your coworkers and also making your coworkers trust you. What I usually do is I'm starting with the assumption that, and you can do that trust is everywhere, okay? So by definition, you trust your coworkers and they trust you as well, okay? So if someone new member joins the team, you trust them, okay? And they trust you without question. That's the deal. Once we have established this kind of, let's say, philosophy, then we can focus on keeping alive this confidence, and we can build on top of it to create, more constructive and creative partnerships. But again, there's a trap in this soft skill. Usually, we are trusting people's willingness to do something, which is completely different on trusting the people's skills. So trusting means I trust that you can do it, not that you want to do it. Want to do something, it's completely different with can do something, okay? So keep that in mind when you are, if you want to apply and start trusting people, trust skills, not willingness, which is completely different. Talking about more like emotions and how we can improve our relationship with other people. Next one is about respect, which again comes apparently respect is very important. And now that, like I said, we are working on multicultural environments, we have several different individuals, different personalities, diverse communities, local ethics. It's even more important to give respect to people because you don't even know whether their background or from which kind of cultural environment they are coming. And once you give respect, the respect will come back to you, and the cycle apparently will never break unless someone breaks it for some reason. There are some variations like recognition, appreciation. So how to give respect and how to get respect. Always, this is a few tips that I'm following in my career practically. Always try to praise and give kudos to people in public. This might mean like a public Slack channel or any kind of message that we are provider we are using, or like in a video call, just mention someone, show your appreciation that someone helped you even to accomplish something. Even this help was like a very small like idea. Even in that case, just show your appreciation in public. On the other hand, again, if you want to say something negative to someone, again, respect him and apparently do it in private, okay? So prefer like a face-to-face meeting or a video call if you're working remotely, or, which is the last, let's say, solution, chat over a direct message private channel. Although I do prefer to do that face-to-face. It's much more better, and it will not hide any emotions and reactions, because usually when you write things, you can't express your actual emotions. So in any case, give kudos and praise people publicly to gain their respect, and again, show the respect to, well, when you have something to say negatively, say it in private. Now, moving to the last two soft skills, those are focusing on communication issues. And the first one is how we can listen, and then how we can talk. Apparently, we can all hear, but how many of us we are actually listening to other people? So be a listener is a soft skill, and the variations are active listening or attention to details. Here are a few tips how we can be a good listener and actually communicate that to our to the person that we're talking to. Usually, it's very practical to paraphrase other people's words to show that we are understanding what they are talking about. We can use also some nonverbal cues like eye contact or nodding our head, or like brief verbal affirmations like sure or thank you or I know or I understand. And when the other person finishes, then we can ask specific questions, maybe to seek some kind of clarification or ask open-ended questions. All this can help us build trust, because we are actually listening. We can help us make better decisions. And apparently, although it's not a direct, let's say, benefit, we can learn. I mean, listening to others, probably they have something to say that we haven't thought about, or they have learned something that they can share with us. One final tip about listening: when you are a group of people and you want to discuss about a problem, try to disclose your opinion at the end, waiting others to speak first, and this will actually prove that you are showing understanding to the others, and maybe your opinion is slightly changed listening to others, and maybe it's more complete. So try to talk, close to the end of this discussion, and wait others to talk first. You don't have to be the first one to talk. And now it's time to communicate. Apparently, there are several ways of communication. Some of them are used daily. I already talked about the body language. I mean, non-verbal communication can be facial expressions, the tone of voice, the body language, the posture, several, other gestures or eye contact. Okay, verbal communication can be done in various groups of people, like co-workers, like supervisors. We can talk to our customers, like now I'm a speaker and you're the audience, so this is another verbal communication, okay? And this can happen also in some other contexts, like training sessions or group meetings or interviews or performance reviews, things like that. Then we have some writing reports, but they are a completely formal way of communication that require a specific style. We can't use the same wording, but we're using verbal communication in writing reports or writing essays. And again, producing presentations or public speaking, it's another way of communicating things, and it's definitely completely different of when we're chatting about in like a group of people. So all these different ways of communication require have some challenges, and can be used in conjunction to build some trust, build some relationships, or present some our arguments and our opinion about the specific topic. Now it's time for the +1 soft skill, which is like the positive attitude. There are some, let's say, synonyms like energy or enthusiasm or a team player or being friendly, being patient, and have a nice sense of humor, although this is completely subjective. Now, why a positive attitude is a soft skill and why this is not the most important, but sometimes might be very crucial to be, I wouldn't say successful, but to make the difference. So it seems that a positive person is more likely to be listened, and that leads to the fact that they are more likely to be, understood, or their opinion might be more seriously considered. And that has the extension of they are more likely to be trusted, okay? Because this positive attitude create like some kind of a different way of relationships. And believe it or not, sometimes a positive person is more likely to be hired, and meaning that if we have, let's say, two candidates with exactly the same skill set and with exactly the same experience, and they have no significant difference regarding the technical requirements of the job, it seems that a positive person, someone who's like more friendly, has more energy, more enthusiasm, is more likely to be hired, okay? This can be, I have experienced that in both being as an interviewer or as a candidate. So it's really critical to have a positive attitude within the team. Friendliness, people usually, probably you have experienced that by yourselves. When someone, are you going to ask first? Apparently the technical guru, but if a technical guru is like unapproachable, he never speaks, or their reactions are not very friendly, then probably you will move to the next, let's say, friendliest person that has some technical skills, okay? And this can build like recognition for the person who's friendly. You can enjoy some additional relationships that you can build based on that positive attitude. Apparently, we can't have all these, let's say, variations. We can't all be friendly, patient, humorous, enthusiastic, but we can build and treat like this and behave like this from time to time. Nobody can force you to be friendly if you have a bad day, definitely, okay? But if we want to try to think what is the positive reaction that we can get from other people if we have ourselves a positive attitude, if we can try that some days that we are feeling good, then we can see that this has a lot of advantages, not only for this specific day or moment, but it will create a very positive attitude towards us by other colleagues. So this is it more or less about the soft skills that I believe that they are important. As I said, although the title is about software engineers, apparently you can figure out that this is, I didn't say anything about software engineers, about programming languages. This can be applied to any kind of professional, but taking into consideration that software engineers are not very famous for being social, I do believe that we have a lot of room for improvement on that area. Those engineers that can combine technical excellence, professionalism, and at least a very decent level of soft skills, they can have a brilliant career, whatever they do with their job. So this is it. I think we've got, 5 to 10 minutes for questions. So I'm going to give the ball to Zara, or I can answer any kind of questions that we might have by other than this.
Thanks a lot, Patroclus. Personally, I enjoyed your subject and presentation. I hope so it would be for audience. So attendees there, if you have any questions, you can address your questions here. You will comment and we're gonna ask from Patroclus. Personally, I had some questions for myself that you think, as your subject was 10 plus 1 soft skills for developers, you think that the last one that was positive attitude was the most important ones?
not the most important, but I think it's the one that we can apply easily day by day. I mean, this is actually how we behave to other people, even outside our work, right? So you can always be friendly, you can always be polite, you can always be patient to not only to your colleagues, but also to your family, to your friends. So if
For
you
the
can
whole
start,
social life.
yeah, if you can start applying the last, set of skills I mentioned outside our working environment, then we can easily start to do it as part of our working day.
Thanks a lot. Let's have the comment of Sikander that he says that how can learn. I think he means that how these soft skills can be learned.
Yeah. So apparently, it's not that easy, to learn. Like we are just reading a book with a new programming language or the framework. I think there are some books out there that you can learn, but the best thing is to try to apply it in our working environment. Pick one, whatever you think it's easier for us, or pick one that you think will give you the most advantage in your career, and try to work on it. Once you, let's say, master it, go to the next one. It's not an easy process, that it will take some time.
It's practical. It needs time.
Exactly.
So yes, and we have another comment from Zahir that he or she says that how I will agree someone on my opinion or solution.
I assume that is how should I approach someone to agree with my opinion solution, something like that. Well, I think it's all about preparation, okay? Like I said, we need to be prepared to discuss, not force our opinion. Start with the assumption that you have your opinion, someone else have another opinion. You don't even know which is the correct one or which is the best one. So start by discussing, come prepared with arguments, be prepared to answer the concerns of other people, okay? And also be prepared to change your mind. During this discussion, it might be proven that your solution might not be the right one, okay? So put your ego to a side and actually do a very constructive discussion about this point of view.
Thanks a lot. We have another comment, and we watched the Vries says that nice talk at point 7 or 8. You put believe in the skills of a person, not his willingness to do the thing. What if they do have the ability but not the willingness? I think you have been mentioning on trust issues.
Trust the ability, not the willingness. If someone doesn't want to do things, then you can't force him. Apparently, this is something that needs to happen, like a performance review. I don't think it's a soft skill, or like probably something a more deeper problem that you can address with soft skills. If someone doesn't want to work, or I don't know, then probably no kind of trust can fix this problem. But you can try. I mean, we can, if you show that you trust him or her, and you trust them to do things because they can do, you can try that, definitely. But if they don't want, then
you can do your best to persuade someone to do something.
Exactly.
But not.
Yeah.
Yes. Another question that was made for myself is that how can these soft skills be learned to a developer?
So, like I said, developers are not famous about their socialization. Okay, I mean, we prefer working all alone, with our, headsets. Don't interrupt me. Let me do my job. So, and our, let's say, nature of our work is leading us to isolation. But I can spend 5 or 6 hours without even talking to anyone because I'm really, really focused on a specific task. Okay, so if it's hard for someone to learn the soft skills, I think it's even harder for developers because of the nature of our work. So what I would recommend is try to pause a bit and try to wear the other hat of developer. Try to wear a hat of someone that is watching you as a developer and what is expecting from you as a person, not as a developer, okay? So I'm expecting you as a professional, not only to write code, but be able to communicate, okay? So try to wear the hat of the other person and set the expectations. And like I said, try to pick one, an easy one that you feel it's easier because your character, it's fits to that specific soft skill, and try to apply it every day by day. For instance, feedback. Everyone can requires feedback, right? It's super easy to ask feedback by your manager. If your manager doesn't give you feedback on time, then ask them, hey Zara, it's 1 month without the feedback. Am I doing well? Can I improve something? What's your opinion about the last task I did? It's super easy to ask questions. That's the first thing we can start learning. Okay.
Thanks a lot. And we have the last question because we're gonna be at the end of our talk.
Sure.
Carmen says that lacking which of these skills is the most negative in work environments, if you know?
Very good question, Carmen. I wouldn't say negative. I mean, you can be a brilliant engineer without all this. But I mean, in the technical side, I would say the three, let's say, emotions like trust, respect, and lack of empathy can be not negative, but can at some point create some tense between the relationships between your colleagues. Those three, I think, that has to do with emotions and relationships might be not negative, but a bit can create some problems.
Thanks a lot. Again, thank you a lot, Patriklos. You have mentioned noticeable points in your speak, and have a great day.
Thank you so much, Sarah. Thank you, guys. See ya.
Welcome.
Bye-bye. Good luck.
Bye. You too. So, thanks a lot. That's really, I enjoyed the talk, and it was really valuable for me to act as a moderator here. And I invite you for our next speakers and next moderators here. Stay tuned and have a nice day. Enjoy the next left parts of the event. Sorry, Anna, I think that you're muted.
Thank you. So welcome again to the Global Java Summit. So it's my pleasure to be here, and I will be your host for the next couple of hours. I'm sure we will have fun together because our next three speakers are really amazing, and after their talks we will have a common Q&A where you can ask them questions and have a little discussion. So the next session is from Ilia Ilin, who is a Russian developer currently located in Prague. So what's interesting that it's first time for Ilia to be a part of the online summit, but I'm sure that this first time will be really successful. So now I will add to the stream the video recording of Ilia's session, and he will be live on the Q&A session. So please prepare your questions and have fun.
Hi, everyone. I'm excited to welcome you on my talk, How Subjective is Your Testing Approach. Shortly about me before we begin and talk even about agenda. I'm from Russia. I live in charming city of Prague, and they call here Heart of Europe. I mostly develop in two languages, well, it could be called as one anyway, as Java and Kotlin. Besides these programming languages, I can somehow understand in 5 real languages. And something that may be important for you as you are here on this presentation is have around 6 years of professional experience, which I would be really glad to share with you right now. Yeah, okay, so discovered refresher on the abstract. So I assume you don't remember what was written in the abstract on the website for this talk. So let me refresh it a bit for you. So testing of the applications is a very subjective topic, and there are a lot of opinions. And so some of these opinions I would try to explain here, why as even appearing, and what's correct, what's super subjective, and what could be objective from them. So, for example, at least 90% coverage is a must-have. So some people are forcing you in the team, or from even business side, forcing you to write a lot of tests to have this coverage, or not to write any test, but to have coverage somehow. And some people are saying that that's not necessary and just slow us down. And yeah, time to market is more important, etc., etc. Some people are just debating over how you write tests. Do you write them first? Do you write them last? Do you have to use TDD? And well, moreover, then there is also a lot of debates. What kind of tests you need to write? What kind of tests make sense to write? And even people cannot agree. What does it mean to write unit tests, for example? Or what does it mean to have an integration test in your system, etc., etc. So, yeah, that all we will discuss today for sure. So I hope you will have some answers to all of these questions at the end of the presentation. Agenda. So we have shortly discussed already, but anyway, we will discuss why testing is subjective at all, why we're here discussing this all, why do we write tests from both developer perspective and business side perspective. What test types do we have? So we'll agree here on some terminology, because after that I will talk with you about the projects that I've been working in, and it makes sense to agree on some terms and definitions in advance. And the most important ones are, of course, test types. So I will give you some example, and we'll show you what are the units, what are integration tests, contract component, end-to-end, and acceptance tests. After that, since we discussed all the test types, we can discuss shortly the testing pyramid, what's the ideal one, and why it does make sense. Of course, testing coverage to be discussed before. And after that, we will go through several projects that I've been working in, and we will analyze them from everything that we just discussed using the terminology and some consequences. So every of these 4 projects was either a successful one or not that much. And so yeah, after that we'll try to draw some conclusions, to have some rather objective lessons learned from all that. And let's go. So talking about something being subjective, here you see an example of 2 ways how you can write this if talking about curly braces. So curly braces here in the first case are on the end of the line, and in the next case they are at the beginning of the next line. So subjective here is whether you choose first approach or a second approach. So that's it, right? You can find an agreement within your team, I hope, and just use the first way or the second way. So that's it. It's subjective, easy subjective. But talking about testing approaches and testing of the applications, it's way more subjective, because at first you cannot agree. Well, sometimes that either you write tests or don't write them at all, or how much do you write the tests in your team for your application. If you agree on writing them, then it's probably also hard to agree what kind of test do you write for which cases, whether you're using some mocks, stubs, fakes, whether you are targeting some coverage number, some specific one, or maybe you don't care. Yeah, whether you are using which terms like broad stack test or end-to-end tests. Yeah, whether you're trying to have something like testing pyramid, or you're using TDD or BDD. So many things to agree for agree with inside your team, right? And it's all quite subjective, so it all depends. So we will see in future examples of projects. I hope that it will be clearer than how to deal with one or another. So let's discuss why do we write tests at all. So from developers' perspective, it's quite easy in a sense that, well, developers are writing tests mainly for sleeping well at night. Well, mostly, but also, of course, because they like to write new features more like easier, so that it doesn't have to be refactoring all the time. So yeah, it's kind of important, right? So yeah, so from a business perspective, is writing tests for matching some business expectations. So business just wants to know whether some cases are working, right? So this is how they see tests and they are used. Okay, so as I said, let's agree on terminology. It's super important before discussing anything because everything is so subjective. So these ones are quite easy. So production code is something that will be released to production. So this is the main thing in your code. Well, this is your code, but testing code is also very important. It's yeah, quite a big part of whatever you're writing on a daily basis in your code base. Yeah, so we distinguish between two of them. And the test double is either a mock or fake or stub. So it doesn't matter much here. So I would just use the general term, which was, I think, initially used in articles on Martin Fowler's website. So I will use this one just generally for all kinds of systems that are not real. So they are just existing for the sake of testing. Yeah, kind of existing. So while you're looking, I'll take a sip of water. Yeah. Okay, so I thought that would be much better to discuss test types on some example. So here is this one. This boundary that you see, the black one, is the boundary of our system. So whatever is inside belongs to our project, let's say. And here is pretty classic application, which consists of controller layer, let's say REST controller, some services, business services, and the repository. So repository here is just classically saving something to storage. Let's say it's database. We also have external services here in place. External service 1 is talking to our system via the REST controller, and our business service 4 is contacting external service 2. Yeah, so in this case, it's downstream system. So we send data there. Yeah, talking about unit tests here. So unit tests are usually considered to be in two flavors. They are either sociable ones or not sociable. So sociable means that we don't use mocks much. So the unit test, the units, the classes are speaking between each other quite free, without any limitations or mocks, let's say. And another type is not sociable ones, which is, I think, more classic and easier to understand what is a unit, because it just says basically that unit is a class. So here, let's say we have one controller for services and one repository class, which is in total 6 classes, and we have 6 units. So we will write for each unit one test. Not one test, I mean, for each of the unit we'll write tests. So yeah, that's pretty much it. So here I've just shown that the unit tests that are not sociable ones, I think they are easier to follow, but they also have some drawbacks, of course. And here the boundaries of those are in blue. So talking about integration tests, integration tests are something sometimes considered to be tests that are testing these spaces between the units but mostly they are used for, and it makes sense actually, especially in case of sociable unit tests, to use integration tests as boundaries test. So here we have three boundaries where we expect something or send something to external system, and this is very vulnerable in each of the places, and it's better to be tested. So for this sake, integration tests are existing. Yeah. So and also makes sense to say here that usually integration tests are working against some test double. So in case of the external services, we are not expecting the real service to be up and running. We are just okay with running it against the test double. So it could be some fake. In case of a repository, we don't have to connect to a real database. We can just have some in-memory one. So here is a bit different from the web services communication that we have with service 1 and service 2. So contract tests, they are helping us in case we have these integration tests that are talking to test doubles. And in case the external system contract is changing, then our integration test will still be green. However, they are not true anymore because contract has changed, right? So we're expecting something different and getting something different from what we expect. Same. So how to be sure about that is to write contract tests, which are usually in a flavor of consumer-driven contract tests, where consumer is writing tests, basically expectations, what provider system should provide. And after that, so this result is sent in form of JSON, for example, sent to external system to provider, and then provider runs the same tests. Well, not the same test, but test against these expectations. And if it's also green, if it's satisfied, then it means basically that two systems are on the same level, so their contract is in sync. So it's great, right? Yeah, so but it's very much used in microservices environment where you have a lot of small things talking to each other, and contracts are changing back and forth. So you're expecting that to stay in sync. Yeah. So next level. So we're going more and more towards the bigger, the high level tests. Let's say. So the component test is bringing you even more confident than all others. It's not that isolated as the ones that we discussed before. So component tests are bringing you, it's just an approximate number from me, but they bring you like around 95% confidence or so in your system, maybe 90. And so you see here the green line. So this is the boundary of the component test. So basically, it's our whole system end-to-end, but without external parts. So without real database and without external services here. So this is the main difference between end-to-end and the component test. In case of the microservice, component test usually represents the whole microservice or the biggest part of it. In case of monolith application, it's rather some end-to-end code pass in the system. Yeah, but it doesn't matter anyway. So it's end-to-end without external connections, and of course end-to-end, which gives you the most confidence possible. Let's say. So here you have a boundary which has inside everything, our system, and everything real, like outside systems, external. 1, 2, and storage. So everything is real, up and running, and you are running your full test case, and you see how it's propagated, how it is stored. So yeah, you can check it. Also worth mentioning that we can also write acceptance tests, which are rather a bit different from something that we discussed before, because acceptance tests are not really a test type themselves. So acceptance tests are usually component or end-to-end tests. They are called acceptance or business-facing tests for the usage, because these tests are usually driven by the business side of your team, so the stakeholders. So whoever is interested in writing their expectations in some specific form, so the classic one is given when done. So if it's written like this, then you could, as developer side, you could take it and make it executable. So then you can speak with a business side on the same language, and well, you can literally show that, okay, you gave me that case and this is green right now, so this case is working. Yeah, of course, since it's a real case, it's usually high-level test, so it's either end-to-end or component, depends. So yeah, this is just worth mentioning. So yeah. And of course, we have different approaches to write our tests. We have tests first, or test after. I hope it's clear, right? It's just you're writing tests before you code, or you're writing tests right after you've written all your code for the feature, or if you're using TDD or BDD. But I think I will not explain that much into details, but it's quite similar to like test first, for example. TDD, you just write one test which is failing immediately because you don't have any code. After that, you cover this simple test case, and after that you go again and again in cycles until you have the perfect code which is satisfying all the criteria, which already written in form of test cases. So you have at the end both tests and the production code, which is well designed. But yeah, so it's not that perfect, but anyway, sounds very good in theory at least. So BDD is similar to that, but on a bit higher level. When TDD is more for some implementation specific thing, but BDD is more on a feature base. Yeah, so it's often considered to be used when you have some acceptance tests, because you're writing these feature files and then you can use BDD. So basically just going using TDD for every of the scenario in your feature file. Anyway, it doesn't matter much here, so just some theory here, and so that we agree on terms before discussing some stuff to have lessons. Sorry, to draw some conclusions from. So next thing is we're almost there. Next thing is a testing pyramid. So it's a classic picture where basically it's just needed to show you that how many tests, what are proportions between these test types that we just discussed. So you see here a lot of unit tests, a bit less integration tests, even less component tests, and at the very top, just a few end-to-end tests. So horizontally, you see the horizontal line represents the number of tests. So the wider it is, the more tests you write. Yeah, so vertical, it's obviously granularity. If you go down from the top down direction, then we are going towards the more isolation. So unit tests are much more isolated than component tests, for example. And well, that's why also they are much faster. So they're giving us faster feedback. I mean, the lower tests are here in this pyramid. So that's pretty much it about this theory. Testing coverage. So probably you haven't seen this picture before, but I would like to show you the coverage from a bit different perspective than just covering the conditions in your code. But here, if you're writing several test types, you're covering your code several times, and it's perfectly fine, but you cover it from different angles. So here, unlike test pyramid where we just shown how many tests you're writing, here is what parts of the code base your test, this one or another, is covering from your code. So this black line at the bottom means the means basically the whole code of yours. And so unit tests are so here the next level. So you see here almost everything is covered except some small pieces, which are integration between the units themselves and of course the external systems, which are completely mocked. Component tests are here, the bigger lines here. They're covering the integrations between the units, but they miss the integration with external systems, which are covered by integration tests here. So you see it kind of corresponds here. So these red lines are covering something that the component tests could not cover. And end-to-end tests are, so here it's not a complete line because you could not cover all the cases, I assume. So it's still not perfect, but here are different gaps than some other tests can have. Okay, so we are here. It's time to discuss projects. So we discussed before some terminology, some like unit test types and testing parameters, test coverage. So now it's time to discuss projects that some of them that I've been working in. So I will discuss each of the projects. There will be 4 of them in a following way. I will show you the testing parameter that was used there. So we'll discuss the test types that were used in that project. We'll also talk about the way the tests were written there and also about the coverage. And we also, after discussing this for every and each of the project, we will discuss what are the consequences. So how was the developer's life in this project, how difficult was to write new features, and overall, how was the project doing because of this approach to testing. And also as a bonus part, and probably some to improve the analogies for you to remember, then I will compare each project with some Game of Thrones person, let's say, so character. So that's I hope you saw Game of Thrones, but anyway, I will quickly describe why I think it is this character. So it's absolutely not mandatory to know the series. Anyway, so let's go to the first project. So this one has only 2 types of tests that was possible to distinguish. There were not many unit tests, I would say quite a few, an excellent suite of end-to-end tests. Excellent means that it was covering the main functionality, like the core functionality, and was well supported, well maintained. Coverage was not even measured, and a pity, but I expect it would be rather low, even if measured, because you just don't have many tests for a huge system. And way of writing tests, as you may guess already, were rather rare efforts, heroic even, to write new tests in bulk. So I remember there were sometimes tasks to write tests for this part of the system, just write as many unit tests as possible, for example. But it was rather rare and did make sense because you don't understand the business anymore, so you're just looking what's written there, and you just write tests for it. Consequences. So because of all that discussed, there was no confidence while writing new code, which automatically means there was slow delivery and constant bugs in the system. And there were just simply not enough unit tests to cover, and new tests for the new code were not also written, so it was not mandatory. No one did this on a constant basis. So no confidence in the code really. However, so project was doing anyway quite good because this end-to-end test suite that I mentioned was really well organized. So was good, so it saved the project, and even with some bugs in new functionality, they were rather minor because core functionality was still covered. but maybe it's also specifics of the business there, that it was not much changing, but on some specific places. But anyway, so this is how it was for this project. And Game of Thrones analogy that I could think of is probably the best one is Jon Snow. So this guy is always in trouble, right? But somehow keeps up. So the same was about this project. Project 2. So here we have more test types. And it's more interesting to discuss then because here we have also end-to-end tests, quite many of them. So here was a very big suite, not only for core functionalities, but mainly for as much as possible. Quite many component tests, a few integration tests, and lots of unit tests. However, coverage was measured. It's good here, but it was rather low. It was only 33%, but without end-to-end test. Well, I assume it would be definitely more with end-to-end tests, but it was not done. So way of writing tests was rather not systematic, not mandatory. So again, in some waves. So it was done sometimes, it was not done sometimes again, yeah. So that's pretty much it. So not systematic, and the consequences are again quite negative. So there was no confidence again in writing new code, slow delivery, and constant bugs, as well as in the first project. But in this case, it was well, like it was possible to save the project, but was not done. Let's say. There were many contributors in this project, and these end-to-end tests and component test suites were very flaky because of that. Also makes sense to mention then that end-to-end tests were mostly UI based, so they were Selenium tests. They were very flaky, and so test suites were breaking all the time. They were almost all the time red. Which of course required immediate permanent investments in them, but it was not done every time. So yeah, so that's why basically there was almost zero trust in test suites of the high level, and was simply not enough of a low level test, and they were not written constantly for new code, which just basically means there is no testing for the system. Game of Thrones analogy would be the Night King. It's very powerful, but which means a lot of tests, but dies from a girl with a knife. So just the discipline, well, killed the project. Oh, I would not say killed, but it was not fun for developers. Project number 3 is again very much different. So we are going a bit towards the improvement here. So here we have few end-to-end tests, quite many component tests, and not much, but some integration tests and unit tests. Overall coverage was around 85. So here it's counted for all test types. Way of writing tests was this time, unlike 2 other projects that we discussed, was systematic, mandatory. But there was a bias towards high-level tests, as you see. So more component tests for some reason. Yeah, comparing with unit tests. So consequences was success. Bugs were found mostly due to some misunderstandings with business, and was rather easy to extend the code with new features. So it's pretty good, I would say. Game of Thrones analogy is Melisandre, Red Woman. She believed in the wrong person despite all her powers. And here, why I've chosen this character is, I mean, the setup is powerful, but actually, well, like the person believed in Red Woman believed in the wrong person, which here means that people on team, they believed that high-level tests are much more beneficial compared to unit tests, but in fact it was was not really correct because the high-level test required maintenance, and there was rather slow feedback in terms of CI. So when it was running these test suites, we could get faster results in comparison. Anyway, it was a successful one. So the project number 4, here are no end-to-end tests at all. There were a lot of acceptance tests in form of component tests. So here on the top, and there were some integration tests and many unit tests here. Coverage is pretty high. It's around 95%. Without not counting acceptance tests, but would not be much higher anyway with them. And way of writing test is systematic, mandatory, so requirement is here 90% coverage in new code. So quite strict, I would say. Success in the result, almost no bugs, and thanks to acceptance test, there was almost zero misunderstanding between business side and the developers part of the team. And yeah, it was easy to extend the code with new features, but there is a drawback. Team was complaining about number of tests in a way that, I mean, they were writing these tests, but they were complaining that in the end, although they are very much sure in the system because of these good testing coverage, etc., they had to really do a lot of changes when in testing code when they were changing something in production code. So it was like quite a lot of effort to maintain the testing code there. Game of Thrones analogy would be Bran Stark. So he's Vries, knows everything in advance, which translates to bugs were identified in advance. But this guy is defenseless alone. So yeah, here it probably means that the testing code requires a lot of support, a lot of maintenance. Yeah. Okay, so I hope you already have some clue what I will be talking about in lessons learned here. But let's go through some of them. I think we'll agree on them here. I hope they would be rather objective for you because I've given examples already. Let's see. So make testing mandatory is the first lesson that I think is yeah, to the question, do we need to write tests or not? So projects number 3 and 4 have shown us that having discipline within your team, in the sense of writing tests for new code, leads to success. Unlike it was in the project first and the second. However, project number 4 also shown us that there should be some smart decision on the number of tests. So how much do you actually testing? It depends a lot on the business. So how business that you're writing software for. So if let's imagine if software update of yours is so serious or so critical that it could even be a result of some injury of a real person or even death. So it's super critical, right? So it's one type of understanding. I mean, it's one type of risk that you should take care of while writing code. So it should be very well tested, I assume. You could not forget any edge case that can lead to these consequences. Also talking about well, the case when button on some rather not on the front page but on like third or fourth page is not shown correctly or is moved a bit, so it's rather maybe not UI case is not a good one, but something in UI which is some data which is maybe not really important one. So it doesn't really much matter. I mean, of course it is important, but it's not super critical. So if you forget some edge case in testing or you didn't test some part of functionality, you will do it. So if it will be spotted and if it's really an issue. So again, be wise about amount of testing. So don't write too many testing code, because as well as production code, it requires maintenance, it requires your time, which should be spent. Test types. I think it's already clear from what we saw that it doesn't have to be an ideal pyramid to have a success on the project. So probably rather means that you need to have more unit tests and end-to-end tests, or like more than other high-level tests that you have here in the testing pyramid, which is I think more the case of project number 4. Yeah, project number 3, hard to explain. Yeah, okay, well, let's however, let me see. Anyway, so what I wanted to say here is that so the ideal pyramid that is shown every time that you need to write unit test, and after that smaller amount number of an integration test, and after that component test and end-to-end test, doesn't have to be so. So you just have it very much depends on your system from time to time, on the business. So yeah, it's just fine. Just make sure that this is the next part. Make sure you don't write too many end-to-end tests, because they are could be a real pain, and better focus on unit test. I think that's the lesson that could be taken from here. So about end-to-end tests, so keep them to a minimum. Keep in mind that end-to-end tests are quite flaky, hard to trace root cause if failed, slow to run, expensive to maintain. And why it is so? Because the end-to-end tests are dependent on external systems. They are going through a lot of code in your system, and if there are a lot of things changing, quite fragile overall, especially in case you have UI end-to-end tests. But still, it makes sense to have some of them, not many, but still some, because it's useful for regression. After some big refactoring, this is something that other types of tests are not giving you, like unit tests or integration tests, because when you're refactoring, you're usually changing them as well. So this is real use of end-to-end tests, at least. And they also represent real case without any fakes, which is also quite interesting for business side to see, and also for developers to understand that the real case is able to work, at least some of them. Doesn't have to be every case in the system. Yeah, test coverage is not a name. It is a tool. But what could be said about coverage is what we saw in the project 1 and project 2, that low coverage is probably an indicator of project with issues, right? So, but at the same time, if you have some threshold of coverage, let's say you are aiming 85%, it doesn't mean that you are on the safe side, because it's not really hard to write tests for the sake of coverage only. And yeah, so please don't rely on these thresholds too much, even if you, well, it doesn't matter whether you are following it by someone's request, or just in the end you have high coverage. Don't rely on it too much. Coverage in the sense of safety can be achieved by the other way. So if you write tests of different types on several levels, like component, unit test, if you recall that slide with the test coverage, with these different lines of different colors that are covering the code base from different, from different parts. So yeah, so that's pretty much it. So if you have same place in your code base covered by several test types and it's all good, then probably means that you can rely on that kind of coverage. But it's not a number. I mean, so anyway, coverage can help you identify vulnerable uncovered places. So in the opposite, not just looking at something that is covered, you can just go instead to something which is not, and you can see maybe there is something important that you forgot to cover. So, and Yeah, talking about test writing approach as either test first, test after, TDD and BDD. So most of the developers on all these 4 projects were using test after approach. Some developers were using TDD, but I would say quite rare, only for some rather complex algorithms. And several people were using BDD, but also quite rare, and it didn't even become a habit in project number 4, which, if you recall, it was heavy on business-facing tests, on acceptance tests. So there were a lot of them, but still, even so, there was not that many people who were using this approach. So it doesn't matter much. So you could agree with your teammates to use this one or another, but in the end, it doesn't matter much because just the way you're writing tests, the outcome is almost the same. So yeah. That's it. And thank you for your attention. I hope you have some questions. I also hope that I will have some answers to that. Yeah, so again, thank you for attention.
So thank you, Ilia, for amazing presentation. It was really worth seeing, and I hope you have prepared your questions. You can write them down in our chat not to forget them, and you can ask Ilia them a little bit later in the Q&A session. So like before I present the next speaker, so this time the United States joined us. So I'm welcoming new audience here. It's a great honor and a great pleasure for us to having you with us on the Global Summit for Java Developers. Geekle have passed like a long way, so we are 1 year anniversary now. So for this time, we organized like really great events. So it's second time Java event, Python, React, Architecture Solution Summit. Today with us together like 5,000 developers all around the world, and even like what is really cool, like more than 40 amazing experts from the field are with us presenting their topics. And that was really great. So like not to waste your time, I would present our next speaker, who is Roy Braam with topic end-to-end test architectures and dead-end road. Hi. Hi, Roy. You're muted now, but yeah.
Yes, thanks.
How are you?
Hi, fine. How are you?
I'm great. It's like amazing atmosphere here on the summit. So
cool.
How do you feel before your talk? So is it like?
Yeah, well, it's great. I was just outside because I'm living in the Netherlands and it's good weather here now, so that's not so obvious in the Netherlands. So yeah, most of the times it's raining here, so I was just enjoying the weather.
The sun, yeah, because like I'm from Ukraine, I'm located in Kiev, and it's also like finally spring. It's like motivating and getting like really nice mood.
Yeah, like 2 weeks or 3 weeks ago, we were still ice skating, and now it's like 22 degrees summer.
Same thing. Okay, right. So like, do you need my help to share your slides?
No, I think I can. I think I can click that. Hold on, let me check. Yeah, I think I can do that.
Cool. Then I will leave you with our amazing audience, and I remember for everyone, like, please ask your questions in the chat, and after all speakers have their talks, we will have a Q&A session where we can discuss them. So the stage is yours.
Okay, thanks. Yeah. Oh, awesome. Okay. Welcome. So let me introduce to you. Oh, nice. My clicker is working. The Duke of False Positives. The Prince of Time Consumption. The False King of the North. The feared opponent of CI/CD. The gold digger of IT. The struggle of DevOps teams. The challenger of patience. The master of frustration. The end-to-end test environment. Let me do this like that. Yes. So, the place nobody wants to be. The spaghetti that nobody can unravel. It currently looks like production, and then it isn't anymore. My name is Braam. I work for a small Open Value. It's Open Value Amsterdam. I'm the founder and director of Open Value Amsterdam. I also work for JPoint, which is a consultancy company just like Open Value. And we work for the bigger customers in the Netherlands. I work there as developer, lead developer, but also as architect. And on all my assignments, I came across a topic called end-to-end test environments. And in the beginning, I really hated it, and I really didn't like the discussions about it. But after some time, I could convince people that they're evil. So they became I kind of had a hate-love relationships with them, because I really liked the discussion with people, but I really liked it, but I do really hate those kind of environments. And I hope that I can show you why I hate those environments and why I think there are much better solutions for those. So it became one of my favorite topics to talk about. So let's share some knowledge. You can also find me on Twitter. So if you have any questions after the whole Geekle, then please contact me. So first, let's start with architecture. Because if we talk about architecture, and I know at some birthday parties, it's like the #1 topic. Like I said in the intro, except in the Dutch people, they like to talk about weather and complain about the raining weather in the Netherlands. But at some birthday parties, architecture is like a real topic. But when we talk about architecture, we talk a lot about how we are building our software and how we are deploying those software. So for example, well, not for example, most people actually do monoliths first. They build a small app, they install it on their own hardware. But that's kind of like not so scalable. So people are thinking about, okay, how can we split up this monolith, and how can we make it more available for more people to work on? So they start to make it modular. So separate deployable units within a monolith, but still it's on one machine, on one JVM, but it's still not very scalable. So of course, we start splitting those things. So we have multiple monoliths that are communicating with each other, and now the fun starts because we have I/O, network traffic, all kind of things can fail. So how are we solving that? Well, just like everybody else in the world, we start solving it with microservices. So we actually are splitting our modular monoliths into smaller pieces called microservices. And we start with 12-factor applications, network I/O, or resilience, separation of concerns, all those kind of things. So now the real fun starts, right? And you came to know that everything is harder to do. But we're still on hardware, so we're still having some provisioning of servers, and that take a lot of time. So we start to virtualize them. We start virtualizing them, and we build. Because virtualization is easy, we can spin up new machines on hardware. So we start building more VMs and split the microservices over all these VMs. And we are really reducing the hardware cost now because it's much faster to spin up new VMs. And of course, everybody's doing containerization, so we also start doing containerization. And to maintain all these containers, we of course need some kind of managing platform with a controller management API, like for example, Kubernetes. And because that's not still scalable enough, we put it in the public cloud. But public clouds are scary, right? They're unsafe. Anybody can walk in, people think. So what we do to secure those, we just add a bit of blockchain because, right, that's another hype. So before you know, actually, you're actually having a lot of infrastructure for just your blog websites that has 10 visits a month, right? So after some long period, you start revisiting your whole ID, and you came to know that there's a new thing called serverless, which solves all your problems because you don't have to do anything anymore. But all joking aside, because of course this was a joke, for those who didn't got my joke, it's all about production. So the only thing when we talk about architecture is about architecture of production environments. And we think less about non-production. In this case, our test and our acceptance environments or our dev environments. The only thing is that most of the times, the only requirement is it should be production-like. So in this presentation, I want to talk with you about the end-to-end test environments. First, I want to get a bit more clearance about the definition of the end-to-end test environments, because there are multiple. The problem I see with those, my experience, I want to share you a bit, take on my journey, what I encountered. I also want to show you some reasons that I've heard people want to use it, some alternatives, and there's the question slides, but there's later on in the conference, there's time for questions and answers. So first start with the end-to-end test environment. The definition. So what's a end-to-end test environment? For me, a end-to-end test environment is a complete integrated environment with production-like systems with a single purpose of testing. So the end-to-end test environment is there just to test. There is no customer on it. You don't do any development work on it. They're there. They're like production-like. They're like the code that's also in production, that's also in a end-to-end test environment, and it's there for testing. That's it. So real deployments with test data. It's not sometimes when I talk with more front-end minded people, they think that an end-to-end test environment is something that you test your front-end against your back-end, but it's the whole picture. So multiple systems, different teams testing to each other. So it's not verification, there are no stubs involved, and it's, well, most of the time it's not even a monolith because you deploy multiple services to talk to each other. So I came across a lot of aliases. So maybe you recognize them. If you have an alias that's not in my list, then please Twitter me or please ask me on the questions and answers, because I will add it to my slides. So I have more aliases so people recognize these systems more often. So one of these aliases is chain environment, for example, or a user acceptance environment, because they use it to let users accept the changes, or a production acceptance environment, or a broad stack environment. That's actually how Martin Fowler started calling it, and then I think in around the 96 or something. He started calling these systems broad stack environments, or NGA environments, which is actually a Dutch joke. I came across this one. It's kind of funny and sad, but it's in Dutch it's called net geen acceptatie, which actually briefly translates to just not acceptance. So it's close to acceptance, but it isn't. I also got a retailer test environment. Theory, and I like this one, it's for Corey Quinn. It's actually you can test on these environments how things work in theory, but not in production. Acceptance environments, pre-production environments, enterprise-wide integration test environments, which is probably an alias that covers it all. A full stack environment, because there's the full stack in it involved. A production-like environment, or a fake news environment. And even I got staging. So all these are names for naming the same thing, and that is a enterprise or a end-to-end test environment. So if we look at the traditional setup of how we are defining our environments, we have like develop, test, acceptance, and production. So develop is of course the place where the teams are developing their own software. It's kind of isolated. Then you have a test environment where you actually share the team infrastructure. You do your tests within your team. Maybe you test against other teams' code. And then we have acceptance, where actually all the systems that are involved in a larger system are integrated. It's a larger integrated environment. And we have production, the place you want to be actually. So obvious, the thing we're talking about now is on the A level, so on the acceptance level. So, what's the problem with these end-to-end test environments? So let me get some water. So you might think like, wow, these environments are serving us for some long time. So what's the problem with this? Well, there are multiple actually, because we moved along. So people are doing these end-to-end test environments for, well, maybe 10 years or more. It's really helped them in the beginning, but maybe you notice this one, if I show you this, like a pen, right? In the beginning, we had these kind of things. For those who are a bit older, we know we use these kind of things, but IT evolved, right? We're not doing applets anymore, or we're not doing certain stuffs anymore. So why are we still doing these end-to-end test environments, right? So the problems that I see with these kind of environments is like the test data hell. I think the previous speaker also talked a bit about the problems of these integrations, of these problems. So the test data hell, it's like, I can show you an example. For example, if I'm a team that's responsible for the orange box, like the shopping cart service. So we have a page where we have all kind of products that we want to check out. So we work closely together with the catalog service because we want to show some information about the products, and we also want to show if the products are still in stock. So we work with the catalog service and we talk with the stock service. They both have some persistent data because there's information about the products in the database, and there's also some information about the stock. So what do I need to do when I want to put this in the end-to-end test environment? I need to start with arranging data. So I need to arrange test data in the catalog service if it's not there yet, and I also need to arrange test data in the stock service. And if I consume data, for example, if I look at the stock service, if I hit the checkout button and I actually, hopefully, if the test works fine, I lower the stock by 1 or by more than 1, then I have to contact the team again that's owning the stock service to put the data in there, because if there's no stock anymore, I cannot run my tests anymore. It's also not your test data. So maybe there are multiple systems working with these kind of environments, so or these services, so they also might be using your test data. And the test data also needs to be correlated. So a product that's in the catalog, the same product needs to be in the stock service, otherwise your test will fail. And they're living. So these environments are not like static environments, they are living. So test data changes, everything changes, and makes your tests, and hopefully you automated them. I will come back to that later. Your tests will get really shaky, and they will fail a lot with false positives because the test data is not there. So that's why it's a test data hell. So bye independent DevOps teams, because now you need multiple teams to put your own tests in order. So I lots of times I hear like it's but it's a production-like environment. Well, I think that's wrong, because if you look at a certain environment, we have like 4 teams here working on multiple products, and we have the end-to-end test environment. So normally what will happen is a team, the bottom one, it will put something into the test environment, which makes it one version ahead of the production version. And when it's done with testing in the end-to-end test environment, it will put it to production. And it's again the same version that's in production. So awesome, works great. So, but what will happen actually if multiple teams are simultaneously changing things in the end-to-end test environment? So you're now actually not testing against a production-like environment, but a version ahead. Or they're deploying multiple times because things are failing, and then they do a new version before they go to production. Or there's that one team that never puts anything into their end-to-end test environment, but they always put it immediately in production. So as you can see, every team is doing its utterly best to not make it production-like. So everybody is changing it. Also, one of the other things is like that we forget about a test scope. So if we look at the shopping cart again, there's a catalog service and a stock service again. We communicate with those. So let's say we also have a message service for the stock service, which is actually sending a either a mail or a text message to a operator to notify them when a stock reached a certain threshold. So they know, hey, the stock is reaching out, we are reaching out of stock, so please order some more products. Right, so what do we actually want to test if we are, as the team, responsible for the shopping cart? So a checkout comes in. The only thing we, as team, responsible for the shopping cart, want to test if the correct messages are sent to the catalog service, and the message that has been sent back is used in the proper way. The same as for the stock service. We don't want to test if a message comes to a operator, because that's not our concern. I think the SMS service or maybe the message service team will test these kind of things. Also, we all know these kind of things like the unstable tests, the slow feedback time, because you have to deploy it every time. Also, it's a increased time to market, and this one actually works pretty well with management. So if you want to get rid of end-to-end test environment, always use the term increased time to market. Or costs, they're very greedy, so probably they will say, yeah, well, let's fix those kind of problems. So use these kind of things if you want to ditch those environments. But these are all problems with end-to-end test environments, because they're actually real machines. So also if you're in the cloud, it's maybe not the iron you have to pay, but your credit card will be paid, right? It will be charged. So these environments cost a lot of money, and I'm not even talking about licensing and team costs to maintain these kind of environments. So it's kind of funny. I have 2 kids, now 8 and 6. And when I was preparing this presentation, they were kind of asking me all kinds of questions like, okay, what are you talking about? What's this topic? So, and I really like Lego. So I have a lot of Lego. And nowadays, these Lego, with everybody that knows, they are built like modular. So you build smaller pieces of Lego, and if you're finished, you can attach them together. And well, sometimes you make a mistake and it doesn't fit, so you have to fix it. But so actually, I started explaining them like how we work with end-to-end test environments, and then reflected on how we build Lego. So I said like, okay, but now I have this Millennium Falcon. If I want to test if my piece of code, so this module, is working, I actually have to buy multiple of these Millennium Falcons just to build them and to test them. Hey, it really works. Okay, now I can attach it to the real thing, to production. It didn't actually cross my mind that the kids actually like that, because then I said, yeah, let's do that. Let's buy multiple of these Millennium Falcons. Okay, but you get the point, right? You have to buy all these things, all these costs, make all these effort to put out these environments just to test if it fits. So I work for a big Dutch bank, and this Dutch bank really loved end-to-end test environments. And just to explain you a bit of the scale of this Dutch bank, they had around like 300 DevOps teams. And they had multiple products like credit cards, paying accounts, but also mortgages, insurances, investments, consumers of large organizations, etc. They even had native apps or websites, all these kind of things. So they're all building it themselves. So they're not like for example, Spotify that just builds a Spotify product. They had multiple things. So they really had 300 DevOps teams, and they had a very complex infrastructure. So I was responsible, I was in the team, and I was an architect for the small orange box in there. And I think around 120 teams were deploying their software on our platform. And this bank really liked the end-to-end test environments. Actually, they were using it for 10 plus years. And although it was always broken, they still started using it and still loved it. They actually loved it so much that they didn't have one, but they had 5 of them. So imagine they had 5 production-like environments, all the same, used by different teams. So in my time, we managed to kill 1, so that was good. So we had only 4 to maintain, because we had to put our application or platform on all these environments. But with the displeasure of removing one of these environments, people started building smaller end-to-end test environments. And if things are not working as you expected, and things got broken, for example, the black boxes there started breaking up because teams were not maintaining their software anymore in these environments, they just connected it to different environments. So at some point, all these environments were connected to each other and they were using services all across. And that really made me cry. I had absolutely no words for it. And I thought it was like a secret or like a myth that people were doing these kind of things, until I actually had a conversation with a team member. I was on support duty. We always had a support duty. One person that got all the questions from all the teams, because he was like a full-time job answering all the questions. So he came in like, hey, can you help me out? Because our flow is not working on the environment 3. So on the test environment 3. Can you have a look if the platform is the cause? So I said, yeah, of course, let me have a look. So I didn't saw any problem. Can you actually show me the broken flow on my device? Because, you know, like cookies, all those kind of things. So let's show me on my device, so I'm pretty sure that it doesn't interfere with all these kind of things. So yeah. So of course he showed it on my device, but it was working. So he said, oh wait, but you're looking at against environment 3 small. Like, environment 3 small, but hey, that's what you said, right? Environment 3. He said, no, I meant environment 3 big, right? We're talking about 3 big or smaller. For me, it was the same because we only had like 4 environments. So, but he said, no, but it's small environment 3. But I think it connects to the same platform. But he said, no, not to us, because environment 3 small connects to the services in environment 3 big. I said, what? And again, I cried. I ran to the toilet and I just cried. I have absolutely no words for it. But of course, lucky the big Dutch bank, because there's some light at the tunnel, because not all teams are using the end-to-end test environment. So they're really making big steps to change these kind of things. And they're really, like a lot of teams are already testing or deploying all their software in production without doing it even on the end-to-end test environment. Sad for us, because when I was working there, we had a platform, so we had to provide the platform for all these teams. But still, lots of teams were not using it anymore. So that was really good. Actually, when they moved to the public cloud with the Pivotal Cloud Foundry on Azure, like imagine, right, that years ago, a Dutch bank, they moved actually to the public cloud. That was really awesome. And they also made the decision that we're not providing any end-to-end test environment anymore. So it's fine if people want to do that, if they want to within their own bubble make some kind of environment, but we're not making any enterprise-wide testing environment anymore. So if you want to go to the cloud, you also have to guarantee your quality in a different way. So as you can see, you might still think like, okay, but why are people still using these environments if I have all these struggle with these kind of things? Well, I heard a lot of things, and mainly they're like covered in these 5 topics. So you have test data, trust, immaturity, compensation, and requirement. So let's go by them one for one. So test data. The one thing I hear a lot is that tests with semantic correct data can only be run in the end-to-end test environment. So for this statement, I first have to explain you a bit about semantic correct data. Maybe you already know, but let's talk about it a bit. So semantic correct test data in this case is when I have an endpoint, like a customer endpoint, and I call it get customer with a customer ID. I will receive a response body with an ID, with a name and a surname, and with a type of customer. And in this type of customer, the only thing that's in the contract is that it's a string, like a string of max 255 characters, and that's it. So you don't know if it's a wholesale customer or a retail customer. Maybe it's even a private customer, a boring customer, a bad customer, or a greedy customer. You don't know. So when you're calling this endpoint and you're making different decisions on the type of customer, the contract is not strong enough, and the semantic correct data is now actually telling you, like, okay, if I have an end-to-end test environment, the team that's owning that service deployed that service, and they have probably test data in there that is semantic correct. And with semantic correct, it's like production-like. So in the end-to-end test environments, there's a wholesale, retail, bare, private, boring, bad, greedy, not 1111, for example. But actually, I think that's true, right? So it's very hard if you are stubbing things. So if you're stubbing things, then it's really hard to stub the information of a different team. So you don't know their service, you don't know what kind of customers there are. But you can improve these kind of things in a different way. You don't need end-to-end test environments. So in the beginning, of course, make your specifications clear. So in the case of our example, enumerate the strings that are possible. So make sure that in the contract it's shown that either one of these strings is coming back. So make your contract stricter, show you that only these kind of things can come back. And if you're really relying on your test data in your end-to-end test environment, extract it from that environment and move it into a stub. So borrow the information, and the team that's responsible for it, borrow it and put it in the stubs. And also, if your business logic is depending, so there's a different flow for a wholesale or a greedy customer, then you can probably move it to your unit tests. So move it down to the test pyramid. So you can also write unit tests for that kind of things. And the last one, you will hear it more often, is build for failure. So if there's a type of customer coming back that you don't know, then map it as an unknown customer and handle it nicely so the customer doesn't know that it's failing. So build for failure so your customer won't know. One of the other things is trust. So people actually want to see it working before they go to production, right? We want to click through the app before we actually see that it's really working in production. But actually what I hear is not like we want to see it in production. I actually know that they don't trust the automated tests we implemented because they do a manual clicking through their environment. Or maybe they don't even have automated integration tests because they like the manual testing labor. I think that's very dangerous because what if the guy that actually is doing the manual tests doesn't talk the talk, click the click? What if they miss certain scenarios? You will probably introduce bugs into your production environment, and this doesn't cover any of your quality. So again, automate, but automate your tests. And if you cannot automate, there's something wrong with your setup. So start trying to automate it, automate. If there's a bug, start with creating a failing test case first before you solve it. So show yourself that you can actually show the bug in the automated test, and then create a test case for it, either way a unit test, maybe an integration test, it's all fine, and then fix it. And really start investing in the way you're testing your software to just gain trust within your team that you actually are handling all the problems, all the scenarios without even moving to the end-to-end test environment. And if you can move tests down the pyramid, like I said, with a unit test, do it. And continuously prove yourself and also your stakeholders that there are no new issues found while you're deploying into your end-to-end test environment. And you can go immediately to production, and there's still no new bug. One of the other things is immaturity. Because System X had a new release that broke our system, and even though the contract is the same, it still broke. So how can that happen? So within the boundaries of the contract, it still broke your service. So they deployed something, our service broke. Well, people start communicating with each other. So if you're very relying on certain environments and you have a lot of customers, for example, then start communicating between the teams. Make your contract stricter. So there's no implementation details that are missed by the contract. And if it's possible, even start using consumer-driven contract testing. I will come back to that one later because I think it's very nice. You can use it for multiple things. And again, build for failure. So you're responsible for your software. So either way another system is failing, it shouldn't crash your software. So make sure that you handle failures correctly. And if you're really, really, really integrated into each other, start making a one-on-one integration test. So maybe you could put something in a separate environment that tests against a different system from a different team, and just do a one-on-one test, but don't set up a whole end-to-end test environment. Another one is, and I think this is the hardest one, it's compensation. So when they release a new version, we first want to test our system because they often break things. So what we are saying actually is that we as a team are compensating with our tests in the end-to-end test environment just to make sure that they are delivering their quality as we expected. But that's like a bit strange to me, and it's also something for a short period maybe doable, but on the long term, you should put the responsibility where it belongs to, because probably you're not the only one consuming the service. And again, here it is again, build your service resilient. So if they fail, don't make it show to the customers, but try to handle it in a different way. And if you're really, if they're really failing a lot, run separate pipelines that are running your expectations against their environment. So call it with a certain request and make sure that it always returns the same thing as you expect. So you can run tests against their system just to test their software. Maybe you can even hand it over to them. So show them like, hey, we wrote this for you. There you go. Now you own it. And kind of a funny one is a requirement. So our stakeholders demand that we first show it in an end-to-end environment. With that, we actually guarantee quality. And that's kind of weird to me. So of course, the stakeholders and the guys that pay for a certain product, they want to see it working, but they're not. They can tell things about what we are delivering, but not how we are delivering. So we should really tell them like, okay, we are guaranteeing that it will work, and we guarantee that it will have the quality that is required. So not the stakeholders are telling us how we should deliver quality. We have to gain their trust, of course. If we break a lot, it won't help. So we have to tell them what we're doing and show them that we're actually improving these kind of things and we're not making the same mistakes again. But also start improving the non-technical process. And that's a bit hard, especially for developers maybe. You're focused on the software, but also you can deliver software or fix a bug within 1 day. But if the decision-making stuff is like taking 2 weeks, then still it's delivered after 2 weeks. So also start improving the non-technical process. Okay, all nice things, of course, but what are the alternatives to actually guarantee quality of your software without having an end-to-end test environment? So one I already mentioned is the consumer-driven contract tests. I think it's worth a separate talk. There are lots of talks about CDC. I would really check them out if I were you. I can briefly explain a bit what it is, but again, please check out people that have a larger presentation about this, because I think it's really helping you a lot. So a CDC test is a consumer-driven contract test, is a testing pattern. So it's not like a framework. It's a way different way of testing software between systems. With the test, there's an agreement within code, so within a written test between a consumer and a producer. So when services are talking to each other, there's always a consumer and producer. Maybe they're both consumer and producer, and there's an agreement with a test covered with a test that has this agreement. It's also isolation, because you can actually test it on your own system. You don't need a whole setup for it. You can just test it in isolation. And the consumer, of course, offers his or her expectations. So if I do this, then I expect that. And the producer actually is testing with these expectations against their own software, so they know that they didn't break any of these expectations. So I can talk a lot about it, so please read this. It's on the Pact.io website. I think it's a very complete sentence that covers it all. But contract testing is a technique for testing an integration point by checking each application in isolation, like I mentioned before, to ensure the message is sent or received conform the shared understanding that is documented in a contract. So, an example. If I do a consumer with if I hit the customer endpoint again in the previous example, and I put a ID that's unknown, I would expect a 404 with an empty body, for example. Or when I do a customers without any ID, I will get a 400 bad request. Or when I do a /customers without any ID, I will have a 200 HTTP code, and I will have a list of all the customers available. Or when I call it with an ID, I will receive again a 200 with a valid JSON body. And of course, the test cases can also test the correctness of the JSON files. So how would it look in practice? So for example, this consumer consumes something from this producer. The producer has a repository where the software is in, and what they are doing is they offer the expectations, so they're testing expectations, provided as a test to the producer as a pull request. The producer involves it in their build pipeline. They are actually merging it, and the producer now has trust to not break the consumer's expectations. And the consumer, on the other hand, has a guarantee that the producer doesn't break any contracts. But another nice thing is, and it's actually the next level, is that you can also use it for API design. For example, why are we actually, as a producer, telling to our consumers how our API should look like? Because probably they know much better what they want. So why are we not asking for expectations from the consumer party as a API design? So let them first give them all the expectations they have for a certain endpoint, and then we have also expectations and tests, and we can start designing our API, so build our API on top of that. So flip it around. Or if there is no test case or no consumer-driven contract test, if there's no one available, probably nobody cares. So there's no uses for our API, so we can remove it. So these are kind of the next level things that you also can do with consumer-driven contract tests. So if I look at the characteristics of a test, so it's isolation. Of course, you want to test in isolation. The complexity should be low. The test data setup should be easy. Well, these are all characteristics of test data, of tests. So if you look at the end-to-end tests, there's no isolation. It's always complex. The test data setup is a hell. I do agree that you have test data semantics, which is a good thing. I think you can test it probably well there. But the feedback time is slow because you have to deploy things. They're always unstable. It doesn't reveal any unused interfaces. The well-fittedness of your API is not being tested. It costs a lot of money, and it's a lot of maintenance effort. If you look at mock tests, so stubs with mocks, we have like fake things surrounding our borders of our responsibilities. They're always isolated because you can run them on your own laptop. They're not so complex. You can follow them, you can debug them. The test data setup is easy. There's a fast feedback time. You can even include it in your build pipelines. They're always stable because they're static. You don't do any review or well-fittedness of your tests. Costs less money, and the maintenance effort is, of course, always also less. And if you look at contract testing, the nice thing is that you can, like I said, you can review unused interfaces, because if there is no test cases, probably it's not used. And also, like I said, with the API design, you can test the well-fittedness of your APIs. So some CDC tools are, for example, Spring Cloud Contract, which is if you use Spring a lot, it's probably a good fit for you. But also Pack, but it's not only limited to Java, but it's also for more. But they also work with Postman and Newman, which is very nice. If you didn't work with it, you can make tests, and you can actually automate them with Newman, which is really cool. You can run them against any environment. I also talked about a lot about minimizing the risk, so making it more resilient. So by minimizing risks when deploying into production, so we are skipping the end-to-end test environment, we're moving to production, we really have to minimize the risks. So if you make a new feature, which some people call the bug, we have to make sure that it's not hitting us very hard. So when you're deploying new services, you can do a lot of things to minimize the risks. For example, you can decouple the deployment from your release. Which means is actually, if you have new code, you have a new feature implemented, just don't turn it on yet, but deploy it in production first. And for example, with a feature toggle, if everything works smoothly and the feature is not turned on yet, but your new artifact is running in production, you can toggle it with a feature, for example, with a config server, and you can actually turn on the feature separately from your deployment. Also start thinking about, if you have a larger group of customers, start about test groups. So maybe you can have a smaller test group in production that tests your feature. And also, still I see a lot of teams not doing proper monitoring, but monitor what's in production. Make sure that you know what's happening in production. And if our certain thresholds are very important, build alerts that you can have either way in your Slack channel or in your text. Maybe if it's even that important that it sends some text message to an operator that's on duty in the evenings, for example. But think about it. And also, I know people want to roll forward always, but also think about that rolling forward might cost you much more than rolling backwards. So if a rolling forward takes you like hours, and you can also do a automated rollback, and the risk is too high, then start automating your rollbacks. Because if it's minimizing your risk of showing this new feature or bug to your customers, start thinking about rolling it back. Also, to start thinking about canary releasing. I'll come back to that later. And also, blue-green deployments are very important when you want to minimize the risks. For example, canary releasing. I think a lot of bigger software companies are doing that. What you're actually doing is, if you deploy a newer version, you just make sure that you route 1% of your customers to this newer version or this new feature, show it to them to make sure that, see how it's used and how it's fixed. And if everything is fine, then you monitor it, then you put all the traffic to this newer version. The same with blue-green deployments. It's a way of deploying your software. So you have a production route, production.example.com, that goes to your blue application, so your current version, where you deploy a new version, your green app. You have a test route where you can actually test if it works in production. So it's not visible for customers, but you as a team, you can do it. So you test it. If everything works fine, you also put the real customers on it. And if there's no problems, you remove the route from the blue app and you move everything to the production. You remove the test, and your green becomes blue. So I'm at the end of the presentation, and I'm not saying that you should skip integration tests, because that's what I hear a lot. So what should we do with the integration tests? I think you can still do integration tests, and you can do them in isolation. I'm also not saying it's easy to do. So you will fail, and you will fail probably a lot of times. But in the end, and when you don't need the end-to-end test environments anymore, it will really help you speeding up your development process. And also, the rest of the people will notice that you're doing much better than before. So, time for questions is, I think, a bit later.
Yeah, thank you for your presentation. I think it was
You're
really
welcome.
interesting for our audience. So we have a couple of questions, but yeah, as you mentioned, we will have time later at the Q&A session. So thanks again, and you can have like a little rest and rejoin in 40 minutes.
Yeah, like it's the Dutch are always very strict on dinner time, right? So normally we eat at 5:30. So now I'm maybe you heard already my stomach, but I'm 25 minutes over. So I really need to eat now.
So bon appetit.
Thanks.
So thank you, Roy, for the presentation once again, and thank you for your questions. So thank you for being active. It's really important for us. And our next speaker is over here. So Berwout, hi, how are you?
Hi, how are you?
I'm great. So this summit is really great, and yeah, so atmosphere is amazing. How are you?
Yeah, I'm doing all right. It's great weather here in the Netherlands, so that's nice.
It's nice to hear, because I'm from Kiev, Ukraine, and it's already spring here. So yeah, that's making me smile and be really happy. So are you ready for your presentation?
Yeah, let's go.
Let's go. So the stage is yours.
Hi, everyone. Thank you for joining me. The funny thing is that my talk is after Roy's, and even though we did not coordinate, my talk sort of does the exact opposite of what Roy's talk was doing. So he says ban end-to-end test environments. My talk is a story about how me and my team automated our end-to-end test environment to make it more easy to keep up with dependencies, basically. I work for Open Value, just like Roy. I work as a developer for a large education company in the Netherlands. And to frame my talk, we're going to start with a little bit of a story. And the story we're going to start with is a classic. It's the story of Orpheus and Eurydice. And Orpheus was a lyre player and a singer. And he fell in love with this beautiful woman called Eurydice. And they were madly in love and they got married. And one day, Eurydice went for a walk in the forest. And in the forest, something terrible happened. She got bit by a snake. And it was a venomous snake. And she died almost immediately. And Orpheus was heartbroken. But he wanted to win her back. So he went and devised a plan. He was going to go into the underworld and meet Hades. So into the underworld he goes. And he plays his lyre to set the demon dog Cerberus to sleep. And ends up in front of Hades. And Hades was so impressed by his playing and his singing that he thinks, okay, I'll strike you a bargain. I'll let you take Eurydice back from the underworld. But on your way up, you cannot look back. You have to trust me. If you look back, you'll lose her forever. So Orpheus agrees because he can get his loved one back. And he starts on his long way up. And step by step, he goes up. And he's almost near the entrance when he starts to doubt. And he starts to doubt whether Eurydice is still following him because he hasn't seen her, he hasn't heard her whatsoever. And right at the exit, he turns around and he looks. And he sees the soul of his soulmate flying away back into the underworld. Completely shattered, he basically sang only sad songs from then on. And a group of people murdered him. Okay, so what does this story have to do with IT? Well, basically my team was in a similar situation. We're Orpheus, the programmer. And we have this project we really like. That's Eurydice, basically our work project. And then something happens to that work project. Some external change bites our project. And it makes it so that our project, we can no longer work on our project properly anymore. Basically, we get slowed down by all sorts of stuff. And then we have to go into the underworld to save our project. And to do that, we have to bargain with Hades, our product owner. And just to be clear, my product owner actually looked like Hades at the time. Like Hades in this picture had a large, impressive beard. And was a very scary, tall man, basically. We have to bargain with them. And then when we finally get to save them, we have to believe that our solution works on the way up. And we have to take small steps all the way back up into the light. All right, so we're going to start my talk at the depths of hell. What was hell like for me and my team? Why did we decide to do this? And then I'm going to share with you basically the path we took, 5 steps up, little steps up out of the underworld. And with those steps, I'm going to give you some concrete examples and basically my experience. So from this talk, it's not an advice to do this exactly, but it's to see and look what matches with your team and to see what maybe you can use, basically. So I hope you get something out of it that way. And then finally, we're going to take a look back, basically what happened and are we happy with where we ended up? And let's hope our project doesn't fly away forever. All right, so the depths of hell. I was part of a platform team that did the hosting, security, development, automation, and support, all of it, basically a DevOps team, on tools for software developers. So other software developers would come to me with their project and they would say, I want to build this Java application, for instance, and I'm going to need a Jenkins, a SonarQube, a place to put my Git repository, all that sort of thing. And basically we took care of hosting a GitLab or a Jenkins or a GitHub, all these different applications that software developers use in their daily work, basically. And because software developers are a picky lot, there were a lot of applications. I think we had between 35 and 50 external applications that we hosted ourselves, did security on, network security, and we did we created some automation so that when you came to me and you said, I want a project, I just enter your project name and a few tools, and I click go, and our automation would roll out an entire standardized environment for you. All right, and we also did support on the phone. Then what did hell look like? Well, when I entered the team, there were only 2 developers at the time supporting all these applications. And it's pretty difficult to have knowledge of all these different applications and see in which different ways they fail, because some were written in Ruby. For instance, GitLab is written in Ruby. Some were written in Java, like maybe Bitbucket or Jira. And they fail in all sorts of different magnificent ways. You have these undocumented legacy features of places where people installed these applications manually at the time. And they didn't document exactly what they did to install them, so they would fail because their certificate went missing or something. We would have unhappy users on the phone, and not just any users. We would have unhappy developers on the phone, which, like, developers is a whole different kind of user. And we would have these expedites. Basically, we would be developing our platform, working on new automation, that sort of stuff, and then something would pop in, and it would ruin our workflow. And we would have to focus on that first, some security emergency or someone's build server that died, or something like that. And we had these manual rollouts still because we didn't automate everything yet. And then because there were so many different applications, all of these had security and feature updates that just keep going. So if you have 35 to 50 applications, there's something you need to update every week. So the first step for us, when I entered the team, we went from 2 to 6 people. And that's kind of a large change. And like my previous colleagues already said, is you have these junior team members that come in, and like the team maturity is not at a certain level yet. So you have to be extra careful. So for us, chaos ruled in the start. The snake bit our project hard when we came in. It had to do with team size. 4 people were added. It had to do with the complexity of the environment, lots of different applications scattered across Windows and Linux machines with different operating systems between the Linux OSs as well. There were 4 juniors to then 2 seniors, so that's kind of a risky part. And then we had these production issues of stuff just randomly failing, and we didn't really know why. What I'm trying to say is that a higher degree of chaos, so for instance, these things that I mentioned, they require a more structured and deliberate approach. And the first thing you can look at is human solutions. It's basically when you enter this team and you make these kind of deals with each other about this is how we're going to work. But you have to be very careful about these human solutions because your teammates might not want to change, for instance, their behavior, or these new behaviors could cause you to add extra administration or extra handwork that nobody wants to do. So I'll give you a few examples of human solutions that worked for me and my team. For instance, the 4 eyes principle, everybody probably knows this. It's basically nothing goes to production unless at least 2 people have looked at it. So you always review code, basically. You register all significant work. So one of the problems we had is that a customer would call with a problem or something. Someone would just start working on it, and there would be 4 hours gone, and nobody would know where it went. So we started registering all the calls that came in that were longer than an hour. That's why I said significant work, because you have to keep the paper mill somewhat small. We instituted these work in progress limits. Basically, every team member could have only one thing in progress at a time on a physical board in the room, which was very nice for us. And we put a protected master branch on Git. So basically, no one could commit directly to master. It would have to be done through a feature request, to a pull request, which had to be reviewed. So there was a check on that. So these were the ones that stuck around, but there were other ones we tried, which didn't stick around. And it's important for your team to have that mentality of wanting to try these different things for a month, or maybe 2, or maybe 3, and then evaluating whether they work or not. Because too often you see that these teams adopt a certain style and they don't really know why they're doing it anymore, and they're still creating this overhead, which is actually not giving them any benefit anymore. So for instance, I know of a team that every release, they had to fill in an Excel form with their signature on it, stating that they did the unit tests, they did the integration tests, and that sort of stuff. Then they had to email that form to someone before they could deploy. You can imagine that everybody hated this, but also our builds do this. Like if the build is green, it did run our unit tests, it did run our integration tests, and from the commit, you can see who made the change. So you don't need the autograph there. So you got to be careful with these human solutions, because they can be, like, they seem cheap because you don't have to build any software for it, but they can be very expensive. All right. The second step for us was moving to a GitOps solution. So one of the problems we had was we had this massive distributed environment of like 900 machines. And we didn't know what the machines were configured like. We had desired state configuration, which would run over the machines and configure them a certain way. But in the past, if someone made a change, that wasn't registered anywhere, and it was giving us a lot of trouble. So we went to this GitOps approach. And for those of you that don't know, it basically means that you keep your state of your environment inside a Git repository, and you try to keep reality and the Git repository matched together. So if you change something in the Git repository, it automatically updates reality, and it becomes reality. And that way, if someone makes a change, you can see who did it. So you can track environment changes. You can see when it happened. You can see who did it. That's very nice. You can roll them back. And you can also query configuration. So for instance, you can look at what gateway is configured for these 300 servers. You only have to query inside a Git repository. You just do a text search. Very easy. And it makes it easier to roll back and rebuild your environment if it's completely broken. Like you now have a documented, you've basically written down exactly what your environment looks like. So if it breaks down, you can rebuild it from scratch, maybe even within a day. So that's very nice. And that's what you use to convince Hades, I want to do this. In reality, however, for us, it was a whole lot of YAML. At the time, we had Docker Compose to deploy our applications, and over 900 servers. You can imagine that that was a massive environment to manage, and YAML is not always the most friendly language. So you need a certain structure in there. You need a structure like split it out over different environments or different customers or different applications. You need a nice solid structure to manage that intense load of YAML, basically. And you need something else. You need squeaky clean pipelines. And what I mean by that, it's automation. So for us, it was Jenkins automation usually. But it's automation that has a definitive result and that doesn't lie about that result. So for instance, we had an automation job that would create a new VM, a Linux VM, and install Docker on it. If it did that and then failed, for instance, maybe the Git commit wouldn't appear in the repository. So now you have a server which exists, but in your GitOps solution, it doesn't exist. That's a problem. So you need to be able to deal with these failures in pipelines in a way that your GitOps state and your reality, they stay in sync. So I like to call that squeaky clean pipelines. And if they fail, they have to tell you about it, and they have to tell you where they failed so you can restore it. All right. So for us, this was a lot of work to get our pipelines to a level where this GitOps solution would work for us. The third step for us was we were managing a lot of products, and we were thinking about getting a monorepository. And monorepositories are slightly dangerous. And this tweet best illustrates that. So what Matt Klein here asks is who are the bigger zealots, supporters of monorepositories, Rust, or invalid polls, same people. And I like that he used the word zealot here because it illustrates some sort of religious fanaticism. Like you have to chase and you have to believe that you need this monorepository. Because it's actually quite hard to build with a monorepository. And I'm going to show you why. And big companies use monorepositories, but they usually have the resources to support those monorepositories. And I'm going to show you why it was difficult and how we solved it. But I wouldn't recommend this for everyone. So the promises of a monorepository is that you have the ability to review change sets as one. So for instance, you have a backend application and a front-end application, and the API between those services change. Now you probably need to change some models in the backend application, but you will also need to change the same models in the front-end application. Now you have the ability to put that in a single pull request because those two products are in the same repository. So you have a nice overview of basically exactly what changed between the two services. And you can verify that that's correct. With two services, this is still kind of simple, but you can imagine with 35 or 50 services that integrate with each other, this is very valuable. You have the ability to build the minimum. And what I mean by that is that when you make a change in a monorepository, you can detect where that change was, and you can build only that product and test only that product and deploy only that product to your end-to-end test environment. So if a service never hits a different service, you don't even need to deploy it to your end-to-end test environment because there is no end-to-end test that verifies it, for instance. So you get the ability to check what is the minimum that I want to build and deploy. And you get the ability to fully automate your tests because the repository knows about all the products inside the repository. So it knows about your entire reality. So you can make a test environment with exactly the stuff in it, just from the repository, exactly the stuff you need. All right, so why is it complicated? Well, for instance, think about what you want to build in a pipeline. So let's say my monorepository looks like the bottom right here. You have a few products, you have a blog. This is the blog that Roy was talking about when he meant you're using Kubernetes for only 10 visitors, by the way. It's my blog. You have your dinner planner, you have your ingredient service, and a meal service. It's 4 products, right? Completely different services. Now, if we make a change to, for instance, the dinner planner on a feature branch, what do we want to build? Well, we want to build the change between the feature branch and the master branch, right? But if we build that, so for instance, we change the dinner planner. If we build that and master changes, then basically the difference changes. So let's say master changes the ingredient service, then it's also going to build the ingredient service because your base changed. So actually, you don't want to build from the feature branch to the master branch, but you want to build the difference between the feature branch commit over here and the base. So that if you commit something here, you're only testing that change, and you're not also testing the changes that your co-developers are making on the master branch at the same time, right? So for branches, you want to build the difference between the tip and the merge base. Then for master, that's not relevant, right? We kind of want to build the difference between the last commit on master and the previous commit. Like if we only change the ingredient service here, we only want to build the ingredient service. Kind of natural, except when this build failed. Because then you want to build the difference between this and this build, right? So let's say we change the meal service here, this build failed, and I change the ingredient service here. You want to build both the meal service and the ingredient service. So you want to build from the tip of the master branch to the last successful commit. Right. And then you sort of want some flexibility. So you kind of want the ability to be able to say, I want to build just the dinner planner. or something. So you need to build in that flexibility as well. Okay, so it starts to get a little bit complicated when you think about it this way. Then it gets a bit more complicated when you think about tests. So what tests do we run? And for tests in this case, I'm referring to anything above the red line here. And that's because anything below the red line, you can sort of run in your build. So maybe the application doesn't have to deploy for that. Like you can run your API tests inside your product build, right? But things that integrate with multiple products and things that run end-to-end tests, they really need to be run on an environment, maybe an end-to-end test environment, because, well, you need the other products that are part of the integration flow, right? So below the line is product specific and above the line is multi-product. And we're talking about multi-product tests. So what tests do we run when we build specific products? Well, basically, it's all the tests that have an integration with this product, right? So if we add to the test which products it's for, then that should work, right? We can select which test we want to build. But if we change the test, then we also have to run that test, obviously. So it's the integrations that hit the product that we built and the tests that we changed. Right. And then what do we want to deploy? Well, that's even slightly more complicated because we just built a product that had a few integrations. In order for us to run those integration tests, we also need to deploy the other products it integrates with. So we look at which tests we want to run for this product, basically, and then we check out which other products does this require, and we want to deploy those. And we don't want to deploy any specific version of them. We want to deploy this version from the merge base. So we have to check out that from our feature branch, the product that we built actually shows the version that we built, and the products that we integrate with, we have to take the version from master from the merge base so that it doesn't change when we change our test, basically. So it doesn't change when our co-developers make new commits to master, right? All right, so our strategy is as follows. To build, find products based on changes. So we look at the repository, what changed, what products do we need to build. Then to test, find the tests that we need to run for these products. So anything that integrates with this product, plus any tests that were changed. And then to deploy, we find the products required to run the tests, right? So we do it backwards, basically. We check out which tests there are, what products they use, and we find those. And we need to check out that we have the right versions of those. So we need the master versions for the integrated products, and we need the build versions for the ones that we just built. Right. So I guess you're starting to understand why this is slightly complicated. If you're not following along exactly, I will show a different example in the future. So just bear with me here. So for us, the fourth step was a major problem we had, was that we only had one test server for us, and it was kind of a large Big Bertha server that hosted all our services at the same time. But whenever you want to create any changes to that, individual developers want to make changes, they all need to use that same test environment. So that's kind of difficult. And it was proving to be a bottleneck for us because we had a large amount of these small changes that each of us would just pick up, right? And it was this huge monolith of a server. So scaling test. One of the promises it had for us was that every developer could get their own test environment, and we could pay for exactly what we use. We used to have this one big server, and now if we use the cloud, basically, we could turn it back off when we don't need it anymore, or we could clean it up at night. So in the end, that's what we ended up doing. We had these 5 different test environments, and basically when a git commit would come in, it would create a branch on the mono repository, and it would start up one of our environments or clean up one that wasn't used currently. And then at the end of the evening, we would shut down all 5 instances. And in the end, we had 5 different test environments with the costs of the single Big Bertha server we had at the start, just because we didn't have to deploy every product on it anymore. All right. So the fifth step for us was Kubernetes. And Kubernetes was mainly attractive also because of the test environments, because scaling these physical servers is kind of hard. So the issue we had was we had this overwhelming amount of complexity dealing with basically 900 hosts in production and these different hosts that we scaled up and down in our test environment. And it was machine dependent. So if you wanted to add resources, you add an extra machine. And we had a lot of scripting to manage basically the cleanup and installation of different machines and putting the network settings correctly and all that sort of stuff. A huge amount of scripting, right? And Kubernetes promises us to have like this multi-customer setup that we could use. We could use one cluster for multiple customers, and we could have more efficient use of the resources. So where we had to scale one machine previously, we could now just scale in pods, and then whenever capacity was reached, we would scale up another server. And it gave us this nice abstraction above talking about individual hosts, but starting to talk about services instead, right? And one thing that was very nice for the test environment is that you can get this nice cleanup with a namespace. So you develop and deploy everything inside a namespace, and when you're done, you just chop off the namespace, and that's it, right? It's cleaned up. It cleans up all the stuff inside the namespace. So that's very nice for the test environment. All right, so you've seen me talk about a lot of theory. Let's have a look at how it actually works in practice, right? So I have this machine, and it's a little computer, and it's living in my utility closet right now, and it runs Kubernetes. And on there is a little proxy called traffic that has a certificate for my website, basically. And I can make any route that I want. It's a wildcard certificate. And I have a few cluster services. I have a MongoDB and I have a Jenkins. And I have an ingress route basically configured to my different namespaces. So I have a production namespace, which hosts that blog that only has 10 viewers. And it hosts a little demonstration app that I made just for this purpose that consists out of multiple different apps. Because to test integrations, it's kind of important that it uses multiple different apps, obviously. So I have a front end to the dinner planner. I have an ingredient service that deals with ingredients, and I have a meal service that deals with meals. And if I want to add a test, for instance, by changing just the dinner planner, then I can add a new namespace with the name of my Git branch, for instance, and just the services that I want to test. So that's very nice. So for instance, if I just change just my blog, I can route it to update my blog, for instance. All right, that still sounds fairly theoretic. Let's have a look at how it works in practice. So I have this mono repository that you saw earlier, and it has these products: the blog, the dinner planner. So the blog is a little Hugo app. The dinner planner is an Angular app, and then you have these two Python apps over here that are the different meal and ingredient service. And let's say I want to make a change to the dinner planner. And for now, I'm just going to add to the README. And I'm going to make a change to the meal service as well for our hypothetical example, right? Let's have a look what I changed, right? Let's make a branch. Right. I changed these products, and I pushed that commit. And it's set up, right? And this app, it's actually also quite simple. Let me show you. It's this little dinner planner app, And over here, I have a single testing scenario. And the testing scenario that I have, it adds a meal. So you can add, for instance, a salad, and you can pick from the ingredient service, which lists ingredients here on the left. And you can add your own ingredients. Let's say we add 50 grams of corn, and then you can submit that meal. And basically, the idea was that it prints out 7 meals for a week, and then you can do your groceries, right? Quite simple. And you submit this, and it goes to the meal service, right? So we use the ingredient service on the left and the meal service on the right, basically. Then in our monorepository, we have this multi-branch pipeline that we can scan, and it's going to detect the new branch, hopefully, the Geekle branch, and it's going to decide what to do. So the test scenario that I'm running is exactly what I just ran. And as we just discussed, I've changed the dinner planner and the meal service. So it's going to build those, hopefully. Then it's going to try and run this test because the dinner planner requires this test, right? So it's also going to need to deploy the ingredient service for this. So it's going to deploy the ingredient service, the dinner planner, and the meal service, right? So let's have a look. I'll open the Blue Ocean view because the builds can actually, because they're completely independent of each other, they can run in parallel, and the same goes for the tests. So right now it's building our dinner planner and meal service, and we can actually have a look and see what it decided to do as well. If we look here, so I hope this is legible or somewhat legible. Products to build, dinner planner, meal service, tests to run the dinner planner tests, and the products to deploy, the meal service, the ingredient service, and the dinner planner. And because, as Roy already said, it's sometimes hard to get test data, there's a little Mongo setup container that contains test data, and it inserts it into the database for me. So our pipeline is done, and it uploaded those both as Docker images. It's created a namespace for us. It's now updating the Git repository, and then it triggers a deployment. And the deployment is actually quite simple. The Git repository looks somewhat like this. So we have my cluster here with the main namespace, which is my production namespace, and I have these services. And I'm using a little tool called Customize, and what Customize allows you to do is it allows you to add these YAMLs together, basically. So for my blog service, for instance, I have a deployment.yaml, and I have a service.yaml like you would have. And then the customization.yaml, it just says I have these two resources and combine them for me, please. Right? Then I have my cluster has namespaces. And in the namespaces, I have a few routes, basically to make my production routes work. And I have a customization.yaml that adds these together. So in my main namespace, there's a blog, there's a dinner planner, there's an ingredient service, there's a meal service. And what's nice about this templating tool basically is it lets me overwrite the namespace. So basically it will deploy all this stuff inside the main namespace, which means that if I throw it away, it's gone again. So right now, if we pull, our pipeline should have created a Geekle namespace. And the Geekle namespace has Geekle routes, like for instance, geekle.dinner.berwout.nl, which is where my current brand new end-to-end test environment is actually running, right? So you can actually go in your browser right now and type this, and you will end up on my app. So it's running in production. And it deployed that, and then it creates the test job, and it runs the test. So it's kind of a smart pipeline. Inside my monorepository with many different products, it decided which products do I need to build, which tests do I need to run for that, and which products do I need to deploy for that, right? And it created this new namespace with these new routes. And for my GitOps to work, basically all I had to do was say deploy customization.yaml, and that includes all this stuff. And so my deployment is very simple. It basically deploys this whole thing. And then if I throw away a namespace, it will delete that namespace as well. So it looks at differences between the Git repository and the cluster, and it just adjusts them, syncs them together, basically. Very simple deployment strategy. All right. So now you have sort of a view of what my team and I built. Now, keep in mind, we had 35 to 50 different products, all integrating in different ways and different groups of products. So it was a bit more complicated than this. And I mean, for running my 10-viewer blog, this is definitely not worth it. So this is just an example, obviously. And you have to look for yourself, like, when would this be worth it? Like, how many products do I need to have in order for this solution to work for me? All right. So now looking back a little bit. First, we had the snake that poisoned our environment. And it's usually the introduction of chaos or the introduction of an external dependency gone wrong, right? So it's an external dependency that's updated and it changed their API, or it's an operating system upgrade, or it could be 3 or 4 team members entering your team and creating chaos, right? Then we have to go into hell. Like, it's usually work that we don't really like doing because you end up with the same result as which you started, except it's more organized, right? So you have to change this environment, but it doesn't actually give the customer any new features. It just improves your ability to do better next time. And you have to face your fears by migrating the production environment as well. And in the daemon dog Cerberus, like, you have to face that dog and migrate your production environment to Kubernetes or to GitOps. Like, it's a huge change. And you have to convince your product owner, Hades, to let you do these kinds of things. And then while you're doing them, you have to actually believe that it's right. And you have to keep faith that this will lead you to, like, a better future. And then you look back and maybe it wasn't the best solution after all, or maybe it was. What did you think? I think it's almost time for questions now. So thank you all for listening. If you want to check out any of this, I've posted all the source code publicly on my GitHub. And there's a blog which nobody reads, which is www.berwout.nl. And I basically explain how to set up the cluster like I have in my utility closet there. And if you have any additional questions, you can always tweet at me. So thank you all for listening. And I think it's time for a Q&A. I think your microphone is still muted, Anna.
Oh my God, twice, the second time per day. Okay, so thank you one more time for presentation. I think like everyone will like it and we're receiving that comment that was really great. And before we start our Q&A session, we want to like say thank you for everyone who is commenting our summit, who is like asking questions. And that's why like to make it more interesting and engaging for our audience, we want to like say that we will have tomorrow a small giveaway for everyone who is posting questions or feedback in Twitter and tag our official account Geekle US. So please write what do you like the most about the event, some topic or speaker or some bullet points from some talk. So there will be like 5 winners and the winners get 3 free tickets for the event. So sounds really good. And we have like the speakers for the Q&A in waiting room. So Ilia and Roy. So happy to see you all here. How are you doing?
Hi,
yeah,
fine.
Great.
Great. That's nice. So first of all, like small organizational questions. So for Berwout, please, could you share the link to the comments?
Yeah, sure.
So yeah.
Hang on, I'll join the YouTube chat and I'll share it.
Cool. So here we come to the questions from the audience. So I think it is a question for Roy. So is it really painful to debug end-to-end tests, especially when there are so many app versions to support and test data is complicated to create?
Yeah, I think it's a statement to reflect my feelings, indeed. Totally true. Yeah, it's really painful, like I said. Like debugging an end-to-end test is always costly and painful. So, yeah, if you can avoid, then would be nice.
Cool. So, Ilia, Berwout, do you have something to add here?
Well, just like as guys already said, basically end-to-end tests are like always a pain. I would say, like writing them, supporting them. So it's enjoy.
Okay, and the question from the same person. So, like, if not end-to-end, what alternatives can we have?
Yeah, like I said, there are lots of alternatives. I think in a discussion I also mentioned before, it's not on this presentation, but earlier I said, I think end-to-end test environments is a solution, but it's never the best solution. So I think you can always solve it on a different way and a better way. Like alternatives, like I said, like test it in a different level of your test pyramid, be critical about that also. And yeah, like I said, start using consumer-driven contract tests and try to isolate your test cases. Yeah, I think it's not so much done, but I think people should really be critical about their testing setups.
I would add a bit like I think contract tests are testing a bit different part of the system. So if you compare with end-to-end, so the closer one would be component tests, which is a bit like easier to support. So yeah, contract is a bit, I mean, so it's basically a unit test, which is like you're testing on one service and after that on another. Yeah, so I would not compare CDC and end-to-end myself.
I would probably agree with what Roy was saying in that you should be very careful of what the tip of your testing pyramid looks like. So it's a tip for a reason. Don't put everything there.
Cool. And what would you say about like manual testing? Can it be still useful?
Yeah, I think manual testing is good for exploration testing. So, like if you really want to explore how the app is working for in a customer point of view, I think I'm not sure if there's a better alternative for. But yeah, you probably also can do this with. I close my window because there's like. But there's like I think I think that's a better. There's no better alternatives for, I think. But yeah, manual testing you should avoid because my focus, nice man, live stuff. Okay, I'm a bit my camera's trying to focus, but okay, but yeah, I think manual testing should be avoided because you can make mistakes. But there are certain things that you can do with manual testing that you can't do with automated tests. Like I said, you cannot a real person. I think that you should always try to like explore testing, do it with manual tests.
Ilia, Berwout, something to add?
Yeah, I completely agree. So exploratory testing is still a must. So like basically you have to automate as much as possible, but still there is a place for some manual checks, but they should not test some routine things that are already covered, but something interesting, trying to break the system. Yeah, so definitely agree.
Yeah, I would agree with that last part as well. Like for instance, you should basically automate your most important flows. And you can still use manual testing in the other flows, but you could even do it in production. Like sometimes it doesn't matter if like your form is 5 centimeters to the right or something. Like if you deploy in 2 minutes and you make that change in a pipeline that lasts 15 minutes, right? Then you could be doing that on production if you want. Like it doesn't really matter for those non-core features. So I would say there's still a place for manual testing, just maybe also on production even.
Sounds good. And like personally for each of you, so what is your like favorite test writing approach?
I think everybody would say TDD, right? like the holy grail of first write your tests, and then yeah, I tried that often.
Well, I would say that I like tests. Well, I think many developers would support me here. I usually write tests after. So when I have this production code and I understand how to test it better, then I do it. But sometimes, rarely, but still, it's super useful. Very rare. I'm using TDD also, but cannot be used like anytime, because usually TDD is nicer for some hard algorithm when you implement in it, and yeah, not for just simple business code.
Yeah, and for me also, like if I don't really know how I want to approach the story yet, then it can be difficult to start with TDD. And then I usually just start building it until it works, and then go from there, basically. And then you can split it up and write nice tests for it, and then fix your code, right? So it depends on what kind of stage, like how much you know of the thing you're going to build.
Cool, and we have really active person for now with nickname Blue Flame, and thank you for being active. It's really important for every one of us. So when does automation start in a project? So should automation scripts be developed at the same time as feature development, or as soon as it's done?
So I really like this question also because it doesn't have the answer, which is that, in my opinion, it should start before you develop any feature. Because in your company, many teams will be facing the same problems over and over again, like how to build a Java application, for instance. And there will be build pipelines in the tools that your company uses that do exactly what you need. So in many cases, you can just grab whatever your company has off the shelf and use it for your applications. And then with the added benefit that people already know how it works. So I would say before you start writing, unless you're starting completely greenfield, in which case I would say at the same time. Don't wait till it's done.
Yeah, I totally agree. But most of the times when we develop new stuff, like new applications in an already existing environment, the first story that we pick up is like setting up a whole automated pipeline till production. Although it's an Hello World app, it doesn't matter, but then at least you have everything set up, and the rest of your development will be much easier. So also, like I said, like Berwout said in the beginning, as soon as possible at least.
Ilia, have you something to add to the answer?
Well, I'm not expert in here much, but it completely makes sense what guys just said. Yeah.
Okay, thank you, everyone. And can you come up with a situation where end-to-end test environment is a good solution? Is there any?
Well, I think you know my opinion, but no, just to be sure, I think it's always a good solution if you cannot do it with all the other solutions. So the end, probably never. No, but no, probably like I said, there are some teams that are working very closely together, and like a real consultant should say, it depends, right? It's every environment is different. So I never seen a environment where a end-to-end test environment is a good solution, but I never saw all the environments, so I don't know.
Well, I guess it should probably be something rather critical. The business should be very important, right? So if you are, I don't know, projecting the software for airplanes, then you definitely want to test it very well, right, end to end. So not like writing mocks and after that, when the plane takes off, it explodes, you know.
Yeah, I can only agree with that. Basically, don't explode planes. Really good motto.
And one more question, in general, how to understand you, how many testing what amount of testing do you need for your project, for your business? Is there a question? Is there an answer for this question? Or once again,
just enough.
Just right for you, yeah.
Just enough.
There are two definitively wrong answers. The first definitively wrong answer is everything. And the second definitively wrong answer is nothing. And I would say it highly depends on the criticality of the system. So like Ilia said as well, like if it's for an airplane or for a pacemaker or something, like you're gonna need to be more thorough than for my blog website that no one visits, right? So it depends on how critical your project is.
Don't be so sure about your blog anymore. So may change.
So you can copy a link like one more time to the chat, and we all will visit.
I've done a good job plugging it. Yeah.
Okay, and like here comes one more question, like how to persuade colleagues who hate testing.
I think just by example. So like the colleagues who hate testing, they probably fixing most of the bugs, right? I mean, the business side is coming back to them with a request to fix that again and again, or they see it fails in production, I guess. And like if on the other side you are very happy going early back home after work and you're just writing tests, I think it's better to show it than just try to explain it over and over.
And what I would like to add is why do they hate testing? Because there are a lot of ways to set up testing for yourself in a way that you're going to hate it. For instance, if you set up too many acceptance tests, your build is going to run for an hour and you're going to hate it. Because every time you make a change, it's going to take an hour. And you're like, why did these damn tests take so long? You know? So you can make it very painful for yourself. And also a lot of developers write very copy-paste like tests. For instance, their mock data and stuff like that. They copy and paste a lot and they only change one line. And then it ends up being this very long test file with a bunch of cases. They don't really treat it as code. And if you treat your tests as production-like code, like there should be no difference in the joy you get from writing that code than other code, right? So be careful not to make it too painful for yourself, is what I'm trying to say.
Yeah, I agree. I don't understand why people should hate testing, because it's also part of your code, indeed, like Berwout said. And also, if you're responsible, you're building your software, and you also need to run it. So you also get called when things are getting wrong out of your bed because shit hits the fan. Then I don't understand why people are hating testing, because it just guarantees your quality and it guarantees that you have a good night, right? So I don't see why people should hate it.
Part of the problem is that sometimes someone else gets called.
True.
So they don't feel the pain, you know? They have to feel the pain a little bit.
Yeah.
Well, and they also feel like they are delivering features faster if they are not writing testing code. So they're like, oh, it's done. And like,
but it's not no guarantee.
Maybe, yeah, maybe it is working. Yeah.
So users will check, yeah. And okay, and maybe it's like it can be opposite situation. So like how to persuade people, like colleagues who are like too much in love with testing. So there's also like possible situation, yeah.
Yeah, I've had several on my team. Like they would insist that everything needs to be tested. But if you do that, then you're not delivering actual features to the customer. So there's definite middle ground there. Like you don't need to maybe write an end-to-end test for your stub implementation of a third-party service or something, right? Like, are you getting joy out of the fact that that it's always correct, but you're actually not delivering anything? That's yeah, it's kind of dangerous to think like that.
But if you don't deliver anything, you can't write bugs, right? I'm just kidding. Yeah, I agree.
Yeah, I would just compare, just the time that they spend, well, in the end. So like you got this feature and how much time did you actually spend on production code and on testing code? and it's I think it's obvious with the time that it's like definitely too much of effort is happening.
And actually, like maybe a small advice how to find this balance, like between too much testing and like hating it. Okay, so maybe like, is there a balance? So first
I'm gonna
question.
say
There should be.
Yeah, but it's trial and error, and try to be on the safe side of error, right? So go a little bit safer than you think should be safe, and then if you go wrong, too bad, you'll fix it next time, right?
Yeah, fair enough.
Agree.
Right, agree.
Yeah, I agree.
But most of
Yeah, I think-
it's super subjective. So I mean, we can of course we can say that okay, test these amount or like have these coverage, but it cannot be like this, right? It very much depends on like these factor in the end. So it depends on your team, on the business, yeah, on the rainy day or sunny day, many things.
Yeah, like I said, I've been in projects where when you make a mistake or a bug, you're for sure in the news. But then testing coverage is much higher. But I also have been in situations where it's not so important to test certain things. And like Berwout said, it's still code and it needs to be maintained. And everything that needs to be maintained because is costly. Is costly. So you need to be really critical, and it really depends on the system you're working on.
Okay, great. And like one more question from me, like how should testers and developers work together? Like, are there any patterns, recommendations, in your opinion?
Well, yeah, ideally they can be the same person, right? The guy who writes code can also be a tester, and the guy that tests can also write code. So because it's still code. So yeah, it really depends. I think like I'm a developer, so I'm not saying that I'm a testing a guy, but I do can learn a lot from testers, like the way they approach certain ways of testing, and I think it's good to learn from each other, and still you're in a team, so the work that needs to be done is done by the team and not by a single person or by a tester or developer. I think you need to cooperate with each other and learn from each other, because I think the only way to do and deliver quality is to work together. So
Well, like, can it be some miscommunication? So like from your experience.
yeah, I also worked in a team that did a lot of mob programming, and they did it together, even with testers and with developers, and they wrote like everything, like features, but also the infrastructure. They wrote everything together as a mob. So yeah, they learned a lot from each other how they approach certain things, and I think that's a good way of doing things. But if you're not capable of doing it within a mob, I think still like communication is a critical part in any team. So also with testing, I think.
Berwout, Ilia, something to add?
Yeah, I would just say that there is sometimes there is, well, like very rare, but depends on the people. There is a tension between developers and testers. Like, you know, we are working together, but at the same time, developers are building something and testers are trying to make it unstable or fail somehow. And sometimes our testers are very glad when something is broken and they coming to you and yeah, telling it with, you know, with such a joy that, and you feel offended. So it happens, and like yeah, well, I think it's sometimes it should be avoided somehow or not treated very seriously, or yeah.
Yeah, because like these roles, yeah, definitely have different missions, I would say. Different intention.
So I also like when they're the same person, but in my team they're not. And I feel like sometimes the argument they use for them not being the same person is that the testers have a lot of domain knowledge that the developers may not have. I think that's a false argument, though. I think the developers should also have that domain knowledge, and them not testing is sort of an excuse for them not learning the domain. And like I feel if they're developing features for that domain, they should know it to such an extent that they can test it as well, basically. And I feel the split in developers and testers is not really helping address that. Like, I feel it's usually because developers are a bit more expensive that they think, well, it's more efficient if we buy a few testers. But it also leads to features that don't really completely understand the customer. So I like for it to be the same person.
And is it like efficient enough, like in terms of like how much time person spent per like one process and another?
Yeah, basically the idea is that testers are cheaper and they're doing the same work as developers. So if we hire a few testers, we'll be more efficient off, basically. But yeah, I think they're forgetting that the developers also, they need that background to build their features, basically.
Yeah, I think also like what Berwout said, I totally agree. But also we are mainly focusing on like feature testing, but of course we also have different components of testing, like performance testing and security testing. I think also most of the times it's still a different person that does it, but of course as a developer you should know about that domain also. So you should know about security, you should know about performance, and also how you can test it and how you can debug it. So it's still important to approach this as a team and try to work as much as closely together as possible, and try to be the one person that can do everything, and all the team members can do that all. So of course you always have a specialty, but it's still good to learn from each other.
And if you're doing Scrum, there is no such position as tester. There is a team member, and like team is responsible, right?
Cool. So I think it's a cool answer. Thank you. And like we are running out of time, so I would like ask you the last question. So like everyone, so could you give a small piece of advice for our audience, like from your experience? So it can be like anything you want to tell the audience. So recommendation, advice, everything.
Probably my advice would be, yeah, just don't treat testing code worse than you treat production code. So I would say, yeah, at least the same.
Go ahead.
Oh, yeah, I want to say enjoy your work. Like life is too short to not enjoy your work. It's like more than 8 hours a day. So whenever you get up out of your bed and need to take a very cold shower just to get up after your laptop and do stupid work, then change your job. It's too much fun in this development world to actually do great stuff. So just enjoy it. And if you hate testing, automate it away so you don't need to spend any time on it.
Yeah, that's a great setup for me. Because it kind of ties into my presentation. Like if your work or your project gets bit by a snake and ends up in hell, right? You're having a tough time. Convince your product owner and face your fears, and take those steps upward and get out of hell. And don't stay in the underworld, basically. Don't torture yourself.
Great. So I think it's like really worth implementing for our audience. So guys, like thank you again. It was really like great time with you. So thank you for your talks. Thank you for sharing your experience. Thank you for participating in Q&A sessions. So I think it was really useful and interesting for our audience. I hope you enjoyed participating in the summit too.
Thank you. It was a pleasure.
Thank you. Thank you.
Bye-bye. Have a nice rest of the day.
So yeah, it was really fun, this blog. So we are like coming to the end of the testing block. So, and actually I'm gonna to say goodbye to you like in a couple of minutes, but the last thing I wanna like introduce to you is that we are having our like next flash sale. So it is for Python, ML, and AI Global Summit 21. So, you know, probably the world is being obsessed with artificial intelligence and machine learning like already. So this is significant reason for the like volume of information we gather every day is overwhelming. So analyzing and probably using the data can make your lives better and easier. But so like, how can we do this? So you can find the answers on our upcoming summit. So please come and visit our ML and AI Global Summit to supercharge your expertise. And special for you, we have a proposal, 50% discount. So only 20 tickets are available at the price $99. So please attend the website with a QR code and use promo code JavaFlash. So once time, I remind that just 20 tickets at the price $99. So thank you for your attention. I enjoyed moderating the summit. So I'm like saying goodbye to you. And so you have a small break and the next moderator will join you soon. So bye-bye.